este evento. Soy Elena, Engineer Manager de Unit 4 en nuestra sede de Granada. Hoy voy a tener la oportunidad de poder estar con todos ustedes compartiendo este escenario donde, junto con todos los ponentes que tenemos a lo largo del día de hoy y de mañana, vamos a poner de manifiesto la importancia de la inteligencia artificial, especialmente en el contexto actual en el que nos encontramos. El evento que hoy presentamos será el punto de encuentro de un total de 45 ponentes de primer nivel, que compartirán su conocimiento y que analizarán el alcance y el poder transformador de la inteligencia artificial en la sociedad. Un nuevo reto digital que representa diferentes incógnitas. Por ejemplo, ¿qué oportunidades nos ofrece? ¿Cómo podemos aprovecharnos de ellas? Pero también, ¿qué retos supone? ¿Qué límites habría que poner? ¿Qué riesgos representa? ¿Y qué elementos hay que proteger? Esperamos que durante estos 2 días podamos dar respuesta a esas y muchas más preguntas. Por el momento, aprovecho para dejar en este escenario a doña Virginia Fernández, delegada territorial de Empleo y Economía de la Junta de Andalucía.
Pues buenos días, señor alcalde, señor presidente de la Diputación, amigos y amigas. Pues para mí es un placer estar hoy aquí tras retomar estas jornadas del South Tech Week. Tras su cancelación, ya sabemos que fue los días 11 y 12 de marzo por unas circunstancias que todos conocemos. No obstante, hay que decir que eso no le ha hecho perder ni la más mínima fuerza ni mucho menos su interés, puesto que más aún después de esta pandemia, la inteligencia artificial y el machine learning están en todos los espacios de nuestro día a día y nos están condicionando. Hay que decir que estas disciplinas están cogiendo un gran impacto en la era de la informática y en la digitalización y que las empresas lo están utilizando a diario. De hecho, cada vez lo están utilizando más en mejorar sus procesos productivos, en conseguir nuevos modelos de negocio o incluso para los análisis de mercado. Si echamos la vista atrás, fue hace ya 24 años cuando una de las primeras tecnologías emergentes, de los sistemas emergentes, fue el Deep Blue, consiguió vencer a un campeón ajedrecista, a Garry Kasparov, en 1997. Lo que por aquel entonces, hace 24 años, parecía algo extraordinario, que una máquina venciera a un humano, hoy es algo que vivimos a diario, puesto que una de las definiciones más sencillas de la inteligencia artificial es crear sistemas que sean capaces de razonar y de aprender como los seres humanos. Y está más que probado que lo estamos consiguiendo. Como ya he dicho, las empresas gastan cantidades ingentes de dinero en incorporarlo a sus sistemas productivos. Empresas de todo tipo, alimentación, energía, industria, ciberseguridad, ya no distinguimos por sectores. Evidentemente con una ligazón muy importante a las redes sociales. Para el ciudadano también tampoco es desconocida, la tenemos en nuestro día a día, desde las comunes redes hasta la domótica de nuestra casa, los asistentes virtuales, incluso los coches autónomos que vienen. Y por eso hoy pues es muy importante que estemos aquí, poniendo a Granada en el foco, con más de 45 profesionales que van a estar hablándonos de todas sus aportaciones desde diversas perspectivas y contándonos claramente cuáles van a ser sus oportunidades y, por qué no, sus amenazas. Ya sabemos, como acaba de decir la consejera delegada de Unifor, que todavía hay límites que poner y en ello están y hoy se va a debatir aquí claramente. Me gustaría resaltar que el hecho de que sea Granada no es casual. Tenemos una de las mejores escuelas universitarias de informática y telecomunicaciones, que día a día demuestran su potencial, tanto académico, investigador como docente, y de sus aulas salen muchos egresados que incluso antes de terminar ya tienen trabajo. Y no es, que digamos que no es hablar en falso, decir que van a seguir creciendo este tipo de profesiones. También tenemos que decir que nuestras empresas ya están apostando. Aquí nació On Granada, hoy On Tech Innovation, que se está expandiendo por el mundo, donde nuestras empresas están apostando por las nuevas tecnologías de manera decidida como un motor tractor de cambio que los ayudará a posicionarse en nuestra economía. Y también tenemos, aunque un poco más centrado en la ciencia de la vida, un parque tecnológico de ciencias de la salud donde se aúna un gran hospital, facultades, empresas, organismos investigadores que pueden hacer que la inteligencia artificial se genere a gran escala. Por eso tengo que decir, se escucha igualmente, ¿no? Me gustaría decir que estamos aquí en un evento muy importante porque la inteligencia artificial va a condicionar nuestro presente, lo está haciendo, es totalmente transversal y, por supuesto, va a dar forma a nuestro futuro. Cosas como el 5G, el Internet de las Cosas, la ciberseguridad ya están aquí y van a seguir condicionando las profesiones del futuro de una manera muy importante. Hay que decir, desde aquí, expresar mi deseo de que este evento sea pues, un gran éxito en el día de hoy, que se constituya como un referente nacional y, por qué no, internacional, y que nos ponga en el foco de la inteligencia artificial en el mundo. Desde la Consejería de Transformación Económica estaremos muy atentos a todas las aportaciones y sugerencias que de aquí se hagan y, por supuesto, tiene por descontado nuestra colaboración. Muchas gracias y que disfruten de la jornada.
Muchas gracias, Virginia. Continuamos con esta inauguración llamando al escenario a don José Entrena, presidente de la Diputación Provincial de Granada.
Bueno, muy buenos días a todos y a todas y en primer lugar darles la bienvenida a esta provincia, a las personas participantes en este congreso que os habéis desplazado desde fuera de ella y desearles, si tienen oportunidad dentro del desarrollo de la jornada de conocernos un poquito más, seguramente no se arrepentirán. Tenemos una ciudad, y ahora la defenderá el alcalde, con posterioridad magnífica, y una provincia que nosotros la llamamos Granada 1001, por las 1001 experiencias que podemos tener en ella y por nuestra diversidad en todos los sentidos. Bueno, agradecer a UNIFO y al Palacio de Congresos la organización de este congreso aquí en Granada, agradecerles porque es verdad que si hay una de las cosas que como provincia nos ilusiona, nos llena de satisfacción, es cuando leemos en los rankings universitarios a nivel mundial la posición que tiene nuestra propia Universidad de Granada, la Facultad de Informática, de Telecomunicación en ese ámbito internacional. El gran nivel que tiene en cuanto a la formación de su alumnado, el gran nivel que tiene en la generación de conocimiento y fundamentalmente también, entre otras cosas, respecto a la inteligencia artificial con profesores de reconocido prestigio como Francisco Herrera, que sé que va a participar en el congreso, en este congreso que vamos a desarrollar. La verdad que la tecnología absolutamente nos inunda, como decía la delegada provincial, la inteligencia artificial la tenemos en muchísimos ámbitos de nuestra vida personal, también en los sistemas productivos, en el desarrollo social, y va a ser sin ninguna duda clave para el futuro de nuestra sociedad, para el futuro de la economía de nuestra provincia. Nosotros queremos que sea clave para el futuro del desarrollo económico de Granada y el desarrollo social de nuestra provincia, porque tenemos las mimbres, tenemos los expertos, ¿no? Espero que sea un congreso de mucho conocimiento, de mucho compartir conocimiento, un congreso que se genere redes de contacto entre los profesionales, entre las personas que os dedicáis a estos ámbitos y que puedan servirnos para el futuro. Sin más, pues bueno, desearles de verdad un buen congreso, que sea provechoso para vosotros, para la sociedad en su conjunto y para dar oportunidades a tanta gente joven y buena, muy preparada, que quiere dirigir su vida hacia estos ámbitos del conocimiento. Buen congreso y muchas gracias.
No sé si me sé. Ya. Muchísimas gracias, José, por los buenos deseos. Y por último, dejamos en el escenario al señor alcalde de Granada, don Luis Salvador.
Buenos días, querido presidente, querida delegada, querido presidente del Palacio de Congresos, Vito, también máximo exponente de Granada, amigos y amigas que estáis aquí en Granada Y en primer lugar haceros un pequeño homenaje, porque todos sabemos que cuando se inaugura un congreso hasta ahora es muy complicado que haya mucha gente, y aunque hay poca, pero estáis muchos más de lo que es habitual a un horario como este. Por tanto, agradeceros que estéis aquí en esta inauguración del congreso, que para nosotros es muy importante. En primer lugar, quiero felicitar tanto a Unit 4 como al Palacio de Congresos por haber sido persistentes, por entender que este congreso era fundamental y que se tenía que desarrollar independientemente de la situación que vivimos, que hizo que se tuviera que aplazar, pero hoy estamos aquí y por tanto vamos a sacar el beneficio de tantas personas pensando, haciendo aportaciones y de una manera también absolutamente interdisciplinar para tocar todos los ámbitos que tienen que ver con la inteligencia artificial. Yo como alcalde de Granada, evidentemente si miramos esta ciudad, que es una ciudad reconocida en el mundo por su patrimonio histórico, que es probablemente una de las ciudades patrimoniales más importantes del planeta, si le añadimos el valor de la cultura, que nos hace aspirar a ser capital cultural europea en 2031, pero que ya somos per se la capital cultural del sur de Europa permanentemente por toda la actividad cultural, que además se ha mantenido durante este verano con todas las medidas de seguridad y que ha hecho que no haya ningún caso de coronavirus vinculado ni al Festival Internacional de Música y Danza, ni al Festival de la Guitarra, ni a las Noches de Lorca, ni a Granada Festival, ni al propio Milnov, que se han realizado con un gran éxito. Pues digo, si Granada es conocida por todo ello, Granada está empezando, y va a serlo mucho más, conocida también por su grandísima apuesta por la ciencia, por la innovación, por la tecnología. Granada tiene la definición de ciudad de la ciencia. Granada llevamos bastante tiempo trabajando todas las instituciones para conseguir que una infraestructura como el acelerador de partículas, que es una candidatura española, termine residiendo y esté ubicada en Granada. Políticos granadinos desde hace ya muchos años fueron visionarios y crearon y pusieron en marcha el Parque de las Ciencias, que muchas veces he dicho que de ese Parque de las Ciencias, que tiene ya cerca de 1 millón de visitas en los distintos apartados por donde desfilan todos los niños de los colegios de Granada varias veces y también de la provincia y también del conjunto de Andalucía, siempre he dicho que ese Parque de las Ciencias terminará dando algún premio Nobel a Granada porque lo que trabaja es sobre el despertar de las vocaciones científicas. Pero tenemos un Parque Tecnológico Ciencias de la Salud que está especializado pero que cada vez también se está diversificando más y están entrando también más espacios a competir en un momento donde, digamos, tenemos que ser bastante más transversales. Y tenemos una universidad como la Universidad de Granada, que es una de las 300 primeras en los rankings de Shanghái, que va a cumplir 500 años también en 2031, pero que tiene 54.000 alumnos, de los cuales un 7% son de fuera, que es la universidad que más Erasmus tiene y que es reconocida por tener la principal facultad de ingenieros informáticos de España y una grandísima facultad de telecomunicaciones. En la Universidad de Granada residen varios de los principales grupos de investigación del país vinculados a inteligencia artificial, a Internet de las cosas, a Big Data, a computación y a muchos otros campos. Por tanto, como alcalde, ¿qué es lo que pretendo? Pretendo que todo ese ecosistema, tanto público, privado, institucional, que en este momento tenemos, que tenga un sentido, que tenga una orientación. Y por tanto intentaremos que cada vez haya más eventos vinculados a la tecnología, a la ciencia y a la innovación, como este que vamos a disfrutar hoy, o como Ecosystem 2020, donde vendrán también de los principales pensadores del mundo dentro de un mes aproximadamente, también aquí en Granada. ¿Y por qué? Porque queremos trabajar porque todo este ecosistema basado en estos ámbitos esté permanentemente creciendo, haga que las personas que os vais a dedicar a estos campos queráis venir a vivir y a trabajar en Granada, haga que nuestros universitarios que están en las facultades sepan que pueden salir montando una startup para aportar soluciones en alguno de los campos a los que hoy os vais a referir y mañana también, y por tanto hacer que este ecosistema funcione. Que la Consejería de la Junta de Andalucía, que está haciendo un enorme esfuerzo en toda Andalucía, sepa que todo lo que invierta en Granada va a tener una respuesta y va a tener un retorno económico y de talento muy importante. Que todo el potencial que tiene la Universidad de Granada no va a tener que, cuando termine, ver en dónde se ubica, en dónde se coloca, qué tipo de salario van a tener, porque intentaremos promover que estén en campos donde ellos mismos estén trabajando para aportar soluciones. Por eso siempre digo que quiero que Granada sea la ciudad de las startups y que trabaje para aportar soluciones en cada uno de los ámbitos, porque eso va a ser el autoempleo de los propios universitarios que saldrán poniéndose de acuerdo, creando modelos de negocio y poniendo en marcha su propia iniciativa, que tiene que ser después apoyada por las instituciones para que todos los mejores se puedan mantener. Si hacemos esto, estaremos también construyendo el Silicon Valley del sur de Europa, también teniendo en cuenta que tenemos a Málaga, que ya lleva bastante tiempo también trabajando en este terreno y es de reconocer que con muchísimo acierto. Pero en este momento, teniendo la plaza tecnológica más importante de Andalucía en Granada, que además también tiene un carácter nacional, teniendo embajadores internacionales como tenemos en Granada, tenemos a una Junta de Andalucía que hace de esto una apuesta absolutamente decidida. Tenemos a una Diputación de Granada que se suma a cualquier cosa que sea buena para la provincia. Y tenemos un ayuntamiento que está dispuesto a apostar decididamente porque este entorno haga que se promueva el desarrollo y el potencial de futuro de nuestra sociedad. Estamos en un momento donde hoy y mañana vais a empezar a debatir sobre aspectos que no están cerrados. Por tanto, todos sabemos la importancia que tiene la inteligencia artificial. Pero todos sabemos que en plena transformación de cambio de era, sin embargo, no están resueltos los problemas sociológicos, los problemas éticos, los problemas, digamos, de dónde se le ponen esos límites y cómo hay que hacer las cosas de una manera ordenada para que esto no sea una selva, sino que sea una fuente de progreso. Y, por tanto, eso demuestra que estamos en el inicio y que están andando en paralelo los avances sobre inteligencia artificial y su asociación con cualquier otra disciplina y cualquier otro campo, donde tenemos también que al mismo tiempo trabajar por desarrollar al máximo todo lo relacionado con la ciberseguridad y al mismo tiempo también su encaje en la propia sociedad. Estamos viendo ahora con el coronavirus, con esta pandemia, cómo de repente se le vuelve a dar importancia a la agenda digital de un país, pero nos damos cuenta que no la tenemos. Que esto empezamos en el año 2004 prácticamente a trabajar por un plan de desarrollo de la sociedad de la información en España, estamos en 2020 y ahora ha tenido que venir una pandemia para decirnos que la agenda digital es importante. Pero Virginia, que ha comentado lo del tema de los vehículos sin conductor, me acuerdo cuando hablaba con los taxistas en su conflicto de taxistas y Uber y Cabify, decía: el problema no está entre vosotros, el problema está en que vais a tener que competir con vehículos sin conductor. Y eso es lo que tenemos que resolver, porque las tecnologías disruptivas van a cambiar todo el mercado laboral. Van a hacer que muchos trabajos dejen de ser, digamos, efectivos y dejen de realizarse. Y van a hacer que muchas personas que no tienen la formación adecuada tengan un problema serio. Y a eso tenemos que dar respuesta las instituciones. ¿Cómo? Pensando mucho antes de que se produzcan esos ámbitos, digamos, de focos de conflicto. Estamos viendo hoy, cuando ponemos cualquier telediario, que están empezando a existir pequeños conflictos sociales, que al final no son fruto ya simplemente de una decisión de un momento, sino de la insatisfacción de no saber exactamente hacia dónde vamos. Por tanto, como alcalde de Granada, quiero deciros que os felicito por estar en este entorno, por trabajar en el entorno de la inteligencia artificial. El trabajo que vayáis realizando es muy importante, porque hay que dar pasos despacio pero sin pausa, porque tienen que condicionar al desarrollo después posterior de toda la sociedad, y para eso las instituciones tenemos que trabajar unidas, sin ninguna fisura y sobre todo sabiendo que Granada, cuando digo que Granada Human Tech, es porque la tecnología también tiene que tener su toque de humanidad y Granada será el ecosistema ideal y propicio para que los mejores queráis venir a trabajar aquí. Muchas gracias, buen congreso, aprovechar muy bien estos días y sobre todo tenemos mucha confianza en lo que hagáis a partir del día después. Buen congreso.
Muchísimas gracias, Luis. Y gracias a todos por acompañarnos en un día tan especial como es el día de hoy y mañana para todos nosotros. Y por contribuir a que este evento vaya más allá de las barreras físicas de este palacio. Y ahora, si me permitís, lo que vamos a hacer es, este congreso se está realizando de forma presencial y virtual y hay mucha gente que nos está escuchando desde fuera de España. Entonces vamos a dar la bienvenida a esta gente que nos escucha desde fuera. Good morning, bonjour, guten Morgen, bon dia, egunon. And now we're going to switch to English and we do the presentation to English. Good morning everyone and welcome to South Tech Week 2020. First of all, thanks to all the official institutions that have helped for this event to happen here in Granada. My name is Elena, Engineer Manager at Unit 4 here in Granada, and I will be your host during these 2 days of event. Event that was supposed to happen in March this year, due to the circumstances back then, was postponed to now, and is happening here. Here we are. A lot of time, effort, and enthusiasm has been put to deliver a first-class event around artificial intelligence and machine learning. And here we are. This is the result. Well, the main person that was supposed to be here right now and that is leading this initiative from Unit 4 is Vanessa Llorens. Due to personal circumstances, she won't be able to join us personally. But we will be lucky enough to have her this afternoon at the closing ceremony in a virtual way. Well, as I mentioned before, the subject around these whole 2 days of talks, master classes, workshops is artificial intelligence and machine learning. But this event is being prepared for people like us. Because artificial intelligence is not about replacing the humans with a robot. It's taking the robot out of the human. And we hope to understand much better this statement after these 2 days of the Congress. Events in figures. Let's see what's going to happen and how many people is going to be here. Hold on. We expect over 1,000 attendees, 45 speakers, 13 of them being women, and contributors across different sectors of our society, from private companies such as Unit 4, Microsoft, IBM, Telefónica, BBVA, and other AI-specialized leading companies on the market. 2 universities, University of Granada and University of Jaén, are collaborating as well, and organisms like the OEPM, that is the Spanish Patent and Trademark Office, and Odisseia, the Observatory of Social and Ethical Impact of IA. What are we going to be seeing here during these 2 days? Well, we're going to see a wide range of topics. From the challenges that artificial intelligence is going to propose, the ethical impact, the security patterns around it, the monetary implication, and we will also have a peek at how AI is evolving in the European market. Now, we will see as well how different sectors, very different sectors of our society are making use of artificial intelligence, sectors like the financial one, medical, marketing, environmental, and how they benefit from making use of it. Then, in a more technical part, it's a technical way of all this, of course, then we will have master classes. And on those master classes, we will see what techniques are used to make this into life. And what are those? It's natural language processing, deep learning, reinforced machine learning, recommendation patterns, neural network, etc. But also, we will have time as well for extra activities and subjects, such as innovation, which is very important, diversity, and gender equality. Now, how can we enjoy everything that we're going to propose in these 2 days? Well, as I said before, due to the circumstances, there are 2 ways to see here or to enjoy this event. One is as you are doing here, physically on the stage, on the Palacio. And the other one is going to be virtual. For the ones that we are here, you all have downloaded an app, and within that app, you could see the agenda for the next 2 coming days. And see, I'm so sorry, this is really driving me crazy. And you could see what is happening, where, and when. Same how. People that is at their houses, they are joining us through a virtual platform. And again, in the virtual platform, the agenda for the 2 days is very well explained. The ones at home, should you experience any technical issues during these 2 days, you'll find on your screen, on the top part right, a red icon, and there you could ask for technical assistance at any time. Now, how this is going to be organized? It's going to be a lot of talk, master classes, but how is it going to be organized? There are 4 tracks that they are going to be running in parallel. We have talks, master classes, workshops, and additional activities. The talks and the masterclasses are going to be held here in this auditorium, Manuel de Falla, and in the room Andalucía 3. The workshops are much more practical ones. They're going to be held in Andalucía 1 and Andalucía 2. But please bear in mind, for the workshops, as I have limited capacity, and it's not physical, but limited capacity as to the number of people who can attend, only the people who has previously registered for the specific workshops will be able to attend. Then we have as well another space that is called the 360 degrees space, where all the additional activities will be held. Now, all the tracks will be running in parallel, meaning it could be something happening here and something happening on the 360 degrees space. Very important then, if you have not done so yet, have a look at the agenda for today and for tomorrow. Have a look what events interest you the most to make sure that you make the most out of your days and you don't miss anything that you like. Okay. As well as that, although we are in this very funny virtual way of presenting an event, there will be place for networking. For the people that we are here, we have a space just outside this room, is the exposition area, and we could actually interact there, obviously taking into account the social distance, etc. But even so, we could interact with any of the attendees to this event, any of them, being at home or being here, both through the app that you have downloaded on your mobiles and the virtual application. There you will find the list of the participant meaning here, people that is attending, and you could actually chat with them and even do video calls. Furthermore, if you have, there will be a lot of people talking, due to the format, we won't have time to raise questions live to the speakers. But you always have the chance to ask them through the tool that we have, the networking tool. It will be presence as well, constantly about the information, what is happening, news, things are happening on social media. Places like Instagram, LinkedIn, Facebook, Twitter. And I will invite you all, if you want to do so as well, if you find anything interesting, please to do so and tweet and post it with hashtags such as STW, from South to Week, Granada 2020. Well, if all this that I have just said was not enough, and we haven't done enough with that, we have launched at Unit 4 2 contests, a very interesting one. The first one, Mini Crazy Labs. And what do we do in Mini Crazy Labs is we reward innovative ideas that are focused on the application of artificial intelligence and machine learning to business software. So it's just to submit ideas of how the use of artificial intelligence can be used on real use cases. If you want to submit any of your ideas, I'm so sorry, but you are too late. The time closed, I think it was last week or the week before. Quite a good number of ideas were submitted, and out of those, five of them have made it to the final round. They are the finalists. Yeah? Now, you could have a look at those 5 final ideas, that they are the finalist ones, both in the app, there are short videos on each one of them, and the virtual platform. And also, at 10 to 11 today, I think it is, at the space 360 degrees, our colleague Rafa Artacho, who has organized this contest, will be presenting the ideas. There is out of those 5 people that have 5 teams that they have been made it to the final, there will be 2 winners. One of them is the jury choice, and that will be the jury selecting who is the winner. And the other one is the people choice, and we are the people. So this is when I ask him for your collaboration. You could have a look at those ideas either in the app, virtual platform, on the talk that Rafa is going to give later on today, and vote for the idea that you like the most. And that will be then at the end of Tuesday, the closing of Tuesday, the 2 winners will be announced. And for us, for the ones that we haven't submitted any idea, but we are voting, there will be a raffle for 2 Alexas. So it's a good incentive there. But if you haven't won the Alexa there, and even if you have, there's another chance still to win another one. And this time is with Unit 4 quiz. As you know, Unit 4 is one of the organizers of this event, and we want to see how much you know about Unit 4. It's a very small questionnaire, not very difficult. Yet again, through the app and through the virtual platform, you could go there, click, and participate. And again, the winner will win an Alexa, and it will be announced in the closing ceremony on Tuesday. Let me see. Now, very important. Because we are having this event that is being held here physically and virtually, more important than ever, be on time. We're going to try to be very, very, very on time with every single presentation, because there will be people joining from home, and if we don't start on time, then they'll have to be waiting. So please be on time for every single event that you want to attend. And now, given the current circumstances, please be aware and respect the security and health measures for everyone's well-being. And that obviously applies to the people that we are here. Like wearing a mask at all times, respecting the social distance. You will find sanitizer gels everywhere along the Palacio. Very important then. In any room, not only this one, there will be an entrance, a door to enter, and a door to exit. Please bear that in mind and respect these signs. And also very important for this room, the seats that you have taken now, please try to keep them. If you're coming back to this room later on today, try to use the same seats. For the ones here as well, there will be some drinks just outside these rooms, and coffee and some soft drinks. And that's about it. That's all that I have to say. That's the short presentation, because the important here is not what I'm saying, but what the speakers are to tell us. If you have any questions or any doubts or whatever, then you could ask me, any member of the staff, and we will be very happy to help you. But the most important of all, we have put a lot of time, a lot of effort, and a lot of enthusiasm, as I said before, to make this happen. To bring here the first or the best people that we have found to talk about the topics that we wanted. So please enjoy as much as you can. And that's about it. In around 5 to 7 minutes, I believe, it's 9:45. It will be the first speaker taking the stage. Is Cristina Aranda. Cristina is co-founder of Mujeres Tech. It's an organization that promotes the presence of women in the technology field. She's also business development in Europe of the international company Tiger. Tiger is an artificial intelligence company that helps organizations optimize operational efficiencies, enhance information processing, and drive productivity by automating complex cognitive tasks. We will also be able to enjoy Cristina, which is very worth it, on the 360 degrees space today at 1:30, sorry. And she will be talking then about hacking stereotypes. And that's all for me. As I said, in around 5 to 6 minutes, we'll start here again with Cristina. It's 9:45, I don't know whether this is right, so just in case, 9:45, I think it is. We'll start with Cristina here, and she will be talking about where is the, I don't see the slide anymore. Inteligencia artificial, retos futuros y retos de siempre. So thank you very much to all you all.
Buenos días a todos y a todas. Muchísimas gracias por vuestro tiempo y por la asistencia. Para mí es un momento muy importante, porque hacía antes del estado de alarma no pisaba el escenario. Para mí es genial hacerlo aquí en el South Tech Week en Granada. Muchísimas gracias a Unit 4 por la invitación. Bueno, supongo que ya me habrán presentado. Soy doctora en lingüística, yo hice filología hispánica para forrarme y me di cuenta que con el biocid pues las empresas poco les importa, ¿no? Ahora sí que el boom de la lingüística computacional, pues sí que está habiendo bastante relevancia, ¿no? Entonces hice un máster en Internet Business y soy Social Innovation Fellow por parte del Gobierno de los Estados Unidos. En la actualidad trabajo en Tiger, la mejor empresa del mundo en inteligencia artificial y procesamiento del lenguaje natural, que es uno de los retos que vamos a abordar ahora. Y también tengo el honor de ser cofundadora de Mujeres Tech, para que haya más mujeres en el sector digital de cualquier perfil, ya sea de humanidades, desarrollo de negocio, programadoras. Y pertenezco a la mesa de género de Red.es y también al comité de expertos y expertas del think tank del Gobierno de Aragón. Cuando pensamos en inteligencia artificial, vemos en los medios de comunicación esto, ¿no? Que van a acabar con nuestros puestos de trabajo, que van a acabar con nosotros, los algoritmos asesinos, ¿no? O titulares como este, ¿no? Facebook ha apagado la inteligencia artificial que había cobrado vida. Claro, las personas que trabajamos en inteligencia artificial decimos, ¿cómo que cobra vida? O sea, mi lavadora no me cobra vida, no pone en blanca ropa, la ropa de blanca y de color. No, 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 es una máquina, las máquinas no cobran vida. Otra cosa es que se le programe y de forma autónoma, por deep learning, haga cosas que nos esperan. Y también, pues hablas con gente y te dicen esto de los datos, ¿no? Se quedan con nuestros datos, ¿no? Esto que estamos viendo, luego no pasa nada si me descargo una app para ponerme más vieja, más guapa, da igual, ¿no? Y cosas como esta, como un amigo o una amiga que me dijo, ay tía, mira, que hay una respuesta en una solución conversacional automática. Y te estás para pensar que Google te está leyendo el email. Claro, pero ahora veremos los retos de la inteligencia artificial, pero yo siempre digo que tranquilos, tranquilas, que nunca va a superar la estulticia humana, nunca. Como es el caso, el ejemplo de los amigos que cuidaban la seguridad nuclear de Hawái que posaron con el password ahí en un medio de comunicación. O sea, hay cosas de estas, ya quienes trabajéis en ciberseguridad sabéis que el phishing, que en muchas empresas el principal riesgo son los propios equipos, ¿no? Las personas. ¿Has ganado un viaje a no sé dónde? ¡Ay, qué bien yo! Pues no. Y es que vivimos en una revolución industrial. O sea, y más con la pandemia, esta maldita pandemia ha acelerado muchísimo más toda la automatización de procesos, la digitalización, y no es baladí que haya un montón de dinero para acelerar toda esta digitalización. ¿Y esto qué pasa? Que va a haber una reestructuración del mercado laboral, va a haber puestos de trabajo que se suplan y se generen otros nuevos. Esto es como cuando las calculadoras, ¿no? Pues había personas que calculaban y ahora es la calculadora la que hace ese proceso. Y el reto es enorme como sociedad, esa gestión de formación a las personas para que adquieran competencias digitales o conocimiento para poder trabajar en estas áreas, ¿no? ¿Y qué es la inteligencia artificial? Porque nos ha empezado Cristina aquí a hablar de inteligencia artificial y esto, como es la charla inaugural, supongo que muchas y muchos sabéis de qué va, pero para quien no lo tenga de todo claro, ¿no? Pues inteligencia artificial es dotar de áreas cognitivas o de capacidades cognitivas a una máquina para que pueda aprender o resolver problemas. Aquí vemos en el GIF el cuadro. ¿Y por qué ahora me están dando tanto la turra de inteligencia artificial? ¿Por qué ahora tanto? Pues resulta que se han dado varios factores. El primero, el hardware, el desarrollo del hardware, ¿no? Con los CPUs, los GPUs, las tarjetas gráficas de imagen de NVIDIA, por ejemplo, que permiten una computación muchísimo más barata y muchísimo más rápida. Para empezar, y el Internet de las cosas. Hay más cosas conectadas ahora en el mundo que personas que habitamos en él. Entonces, imaginaos, y esos bicharracos, esos dispositivos, nosotros, que somos emisores andantes de datos, producen ese Big Data, esa cantidad de datos grandes. Cuando hablamos de Big Data, hablamos de gran cantidad ingente de datos. Hay veces que vamos a empresas y dicen, no, nosotros tenemos Big Data. No, tú tienes un Excel, guay, con sus pestañitas. Pero Big Data es tener gran cantidad de datos generados o bien en un tiempo histórico, que los tenemos, o generados en tiempo real, como las telcos, las energéticas y demás. Y todo eso, gracias a los datos, sin datos no hay inteligencia artificial, es lo que permite a la inteligencia artificial a generar, a extraer patrones y extraer conclusiones para aprender o tomar decisiones. O, eso explica la robótica, ¿no? En la industrialización, la personalización de los contenidos en plataformas de streaming como Netflix, etcétera, o de Amazon, la predicción de estocaje, ¿no? Pues esto, o depende de qué pues área, por ejemplo, en campos de aerogeneradores se puede predecir cuándo se va a romper una determinada pieza. Y la automatización, que es lo que hacemos en Tiger. Nosotros en Tiger hacemos una automatización inteligente de procesos. Somos capaces de leer actas de constitución o notas de poder entre 6 a 12 segundos con un margen de acierto del 97%. Y eso es automatización. Pero hay dos tipos de inteligencia artificial. Yo me voy a centrar a lo largo de mi discurso de esta charla en este primero, en el de persona-máquina, la interacción persona-máquina. Son sistemas que emulan y que imitan, tanto conductualmente como de procesos, a los humanos. En cambio, máquina-máquina, la relación máquina-máquina, como veis ahí en el Tesla, donde tiene 7 ordenadores conectados y que se van comunicando entre ellos, pues eso ya responden a sistemas racionalmente o actúan racionalmente, pero es conexión entre máquinas. Y como yo os decía antes, resulta que necesitamos gran cantidad de datos, pero curiosamente el 80% de esos datos que disponen las empresas o cualquier institución resulta que es no estructurado. Los datos no estructurados son aquellos de naturaleza lingüística. Como veis, emails, las comunicaciones, los manuales de usuario, los argumentarios de venta, el call center, etcétera. En cambio, los estructurados son Excel, son aquellos datos pues, numéricos, cifras que sí que se pueden cuantificar y hallar patrones. En cambio, aquí, pues aquí está el gran reto, uno de los grandes retos, la lingüística. Ya ahora los lingüistas valemos ya para algo, ¿eh? Antes, no sé si habéis visto la película de La Llegada, ¿no? Que ya salvábamos a la humanidad comunicándonos con calamares gigantes. Ahora ya los lingüistas ya tenemos un papel muy relevante y de hecho yo de aquí hace 2 años a esta parte continuamente me están pidiendo si conozco a lingüistas computacionales. ¿Por qué? Porque se han vuelto un elemento clave en entender el lenguaje. Las máquinas entienden en binario, las máquinas no entienden nuestro lenguaje. De hecho, es ceros y unos. No entienden esa simbología o esa capacidad asociativa, o esa capacidad evocativa, poética, etcétera, que tiene el lenguaje. Y para ello vamos a hacer un repasito. Yo sé que sabéis mucho de lingüística, aprobasteis lengua en COU o en el BAU, pero vamos a repasar un poquito para que veáis la complejidad del lenguaje a la hora de no solamente evaluarlo, estudiarlo, sino luego trasladar todo ese conocimiento a las máquinas. En un primer nivel estaría, pues, cómo aprenden los niños o las niñas, la fonética, ¿no? Los sonidos, la articulación, la glotis, todo el aparato fonador. Eso sería el primer nivel, que dice, no, que ya hablar. No, eso se llama protolenguaje, está empezando a hablar y hablará con bilabiales y demás. El siguiente nivel sería la fonología, que es la representación mental de los sonidos. El siguiente nivel, la morfología, y una vez que ya articulo determinados sonidos, las vocales, consonantes, ya lo que hago es construir palabras, y esa palabra ya empieza a haber significado en esa palabra. La sintaxis es la disposición, el dominio de unas palabras sobre otras, y ¿quién domina en la sintaxis? El verbo. El verbo dice tú, sustantivo, ponte aquí, ponte allá, y ahí se hacen los sintagmas preposicionales, y quienes trabajáis en NLP sabéis las tripletas sintácticas y demás. Y fijaos que la semántica aborda todo. La semántica aborda todo y ahí está el gran reto. Porque yo, por ejemplo, puedo estar en una reunión y decir algo y que alguien me haga... Me ha dicho mucho. O, por ejemplo, no solamente en sonido, sino en una palabra, un fragmento o todo el discurso tiene una semántica. Y la importancia del contexto para evaluar y sustraer ese significado. y la inferencia, lo que hacemos los hablantes muy bien y que las máquinas no hacen, porque no tienen capacidad de asociar conceptos y asociar conocimiento, porque no tienen ese conocimiento del mundo que nosotros tenemos. Y de eso os estoy hablando y eso estudia la pragmática. La pragmática es el estudio del uso del lenguaje en un contexto dado, para una finalidad comunicativa. Entonces, eso me va a condicionar pues, el discurso, el registro, la forma de hablar. Esto es muy fácil. Pues no es lo mismo, no tenemos el mismo registro, ni utilizamos el mismo léxico con mis colegas de barbacoa que cuando estoy en una entrevista de trabajo, en una entrevista para un medio de comunicación profesional. Y claro, ya os he dicho, lo estamos viendo, lo estáis viendo, las máquinas hablan ceros y unos y entre las personas nos cuesta entendernos muchas veces de, es que yo pensé, es que tú pensabas que yo pensé, Fijaos, es el gran reto, no sé si habéis visto la película Her, pero no os voy a hacer spoiler, pero es que vamos hacia allá, hacia la personalización, hacia la adquisición de ese conocimiento. Claro, me diréis, bueno, Cristina, me has hablado de lenguaje, de inteligencia artificial, pero ¿cómo se relacionan esta disciplina? ¿Cómo se incardina esta disciplina del Natural Language Processing, del procesamiento del lenguaje natural? Pues como veis, aquí está el área de lingüística y aquí está el área de la inteligencia artificial. Y está esta disciplina, el Natural Language Processing. Y ese Natural Language Processing, el procesamiento del lenguaje natural, hay dos áreas muy diferenciadas. Pensad en cuando estudiáis un nuevo idioma. Muchas veces entendéis, pero no podéis producirlo. A mí me pasa con el catalán. Yo entiendo el catalán, pero no sé hablar catalán. Esto es, una cosa es el Natural Language Understanding, NLU, y otra cosa es el NLG, Natural Language Generation. Nosotros en Tiger, por ejemplo, hacemos solamente Natural Language Understanding, hacemos que entiendan las máquinas el lenguaje, pero no producimos lenguaje. Tenemos asistentes virtuales, pero no, por ejemplo, somos capaces de, porque no es nuestro modelo de negocio, de generar noticias, como hace narrativa y como os voy a mostrar. Y, una vez más, es el gran reto, pero no lo digo yo. Nuria Oliver es una eminencia, de hecho es cofundadora de LIS Alicante, y en su discurso que os recomiendo, Ciencia Ficción y Sueños, en su discurso de acceso al Colegio de Ingeniería como académica, pues ella habló y puso esta slide, que no lo veis muy bien aquí, pero se llama Inteligencia Artificial e Inteligencia Humana. Y los bullets, los diferentes bullets son acerca de la semántica. El primero es el principal reto, la semántica y el procesamiento del lenguaje natural. Los siguientes puntos tienen relación con capacidad de entender y generar oraciones dubitativas. Oraciones, ¿os acordáis de las dubitativas, desiderativas, etcétera? Claro, eso es lingüística. De hecho, durante esta exposición me encontré a una catedrática, la gran Violeta de Monte, y nos agarramos las dos como diciendo, hay la lingüística que vamos a suponer una gran pieza dentro de la inteligencia artificial. Y claro, el reto es apasionante y uno de esos retos la semántica, por lo que os decía, porque en la semántica se engloban muchas cosas, interviene el sonido, la palabra, la frase, el conocimiento del mundo, etcétera. ¿Y cómo lo abordamos? Claro, diréis, bueno, ¿y ahora cómo lo hacéis vosotros en Tiger? Pues en Tiger lo que hacemos es, y en más empresas de procesamiento del lenguaje natural, de NLU, de Natural Language Understanding, de entendimiento del lenguaje, pues lo que hacemos es aplicar el Machine Learning, lo que se llama el enfoque no simbólico, aplicamos matemáticas, patrones, algoritmos, etcétera, para extraer patrones y entender bien dónde están los sustantivos, etcétera. Y una vez que ya tenemos esa extracción, metemos nuestra calpa de algoritmia y nuestras tecnologías semánticas centradas en ese aproximamiento, en esa aproximación simbólica del lenguaje. Todo el simbolismo, esa capacidad connotativa, esas inferencias, todo eso lo extraemos a través de algoritmos de relevancia, algoritmos de clasificación, etcétera, ¿no? Pues, y eso es lo que hacemos, por ejemplo, con nuestras soluciones Tract, que somos, como os decía, pues en el Banco Santander, para el Digital Onboarding, el registro digital para pymes, del Banco Santander, pues procesamos, somos capaces de leer actas de constitución, notas de poder, DNIs, entre 6 a 12 segundos con un margen de acierto del 97%. Imaginaos todo el ahorro de coste operacional, pero sobre todo la experiencia de usuario, que yo hago así, clic, 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 doy y en unos minutos ya tengo activa mi cuenta. ¿De acuerdo? Más que luego se puede normalizar y además somos capaces de extraer determinadas entidades, data points, y cotejarlos con el BORME o el catastro. De tal manera que entre 6 y 12 segundos no solamente estamos extrayendo, sino también estamos validando. Como os decía, en el onboarding del Banco Santander, en la gestión de mails para Citibank, para traders, Citibank USA, estamos en un montón de procesos. Ahora no os voy a poner el vídeo, pero si lo vierais con mucha más nitidez, estos son otro de los retos. Esto es un ejemplo del Natural Language Generation. Resulta que es una cadena china donde no hay periodistas, son avatares, están creados por inteligencia artificial o narrativa, del gran David Llorente. Pues narrativa genera una media de 20.000 noticias al día a través de sus algoritmos y genera noticias pues para medio mundo, incluido España. Entonces, hasta aquí nos ha quedado claro que el lenguaje es un gran reto. El hacer que las máquinas entiendan algo que para nosotros los humanos también es muy complejo, es uno de los principales retos y además exige que co-creen y participen y trabajen de forma colaborativa perfiles de humanidades y perfiles técnicos, porque ahí necesitamos lingüistas computacionales y un perfil que se llama NLP Engineers, son ingenieros e ingenieras del procesamiento del lenguaje natural. Y ahora voy a abordar otro reto que tiene que ver y que también tiene que ver con esos retos de siempre, ¿no? Hemos dicho que somos máquinas andantes, productoras, generadoras de Big Data, de datos. Quien tenga móvil, nuestra experiencia de usuario, aquí vemos un concierto, nuestra experiencia de usuario ha cambiado totalmente, incluso en el restaurante, ya, venga, voy a subirlo, a postear. Todo ha cambiado, ¿no? O nos levantamos y lo primero que hacemos es coger el móvil. Y claro, todos esos datos, si trabajáis en Big Data, y yo os dijera, bueno, ¿trabajaríais en una empresa gestionando datos que luego esos datos pueden ser utilizados para armas nucleares o para guerras? Por ejemplo, si habéis visto esta película de HBO, Brexit, que explica muy bien cómo se articuló la campaña para conseguir el Brexit. ¿Trabajaríais en una empresa donde la democracia puede ser susceptible de ser manipulada? De esto va lo que vamos a abordar ahora, la ética. O sea, quienes trabajamos en inteligencia artificial necesitamos tener ese componente ético, saber que el impacto, los datos, se habla del algoritmo, el sesgo de los algoritmos, no. El sesgo lo tenemos nosotros. Utilizamos datos, producimos datos, luego volcamos nuestros sesgos en los datos. Ahora bien, los algoritmos son matemáticas, extraen 2 más 2, 4, no tienen esa capacidad de enjuiciar o decir esto es bueno o esto es malo. Y como decía la gran María Zambrano, el ser humano está en la sociedad y solo en ella aparece. Y si ahora el yo digital, el encubrimiento tecnológico del yo moral, los troles en las redes, eso es delito, pero se campan impunemente. Y son datos, están generando datos muy tremendos. Los troles de las redes sociales, por ejemplo, la gente anónima. A mí me encanta este GIF, ¿no? Son 2 perros ladrando, pero le abren el cristal y ya, cuando tienen esa presencia en el tú a tú, ya se pasa todo. Aquí en las redes sociales muchos troles no tendrían la capacidad de decir las burradas que dicen a una persona si la tuvieran de frente, ¿no? Esa impunidad de la ética, ¿no? O la personalización. Vayamos a la personalización y ahora os voy a mostrar un montón de ejemplos de ese impacto, de esa falta de conciencia ética de las personas que trabajan con datos o en creación de soluciones de inteligencia artificial. Sabemos que tenemos gran cantidad de datos, pero tenemos que procesarlos para extraer información y de esa información nos va a dar conocimiento. Y una vez que ya tenemos ese conocimiento, vamos a generar algoritmos que me permitan a mí personalizar, ¿no? Que creen un patrón, pues Cristina, que tiene 44 años que no los aparenta, que es de Huesca, etcétera, etcétera, sus gustos son estos, que sea totalmente personalizada la experiencia, ¿no? Pero claro, se dice, bueno, toma decisiones la caja negra. Hay dos tipos de inteligencia artificial. Está el machine learning, que la máquina de forma supervisada, una persona le va diciendo, sí, máquina, lo has hecho bien. Muy mal, máquina, lo has hecho mal. Es supervisada, hay una persona que está... En cambio, el deep learning, que es el aprendizaje profundo y que os recomiendo ver el documental AlphaGo, muestra que las máquinas aprenden por sí mismas. Y aquí es donde está el momento que da un poquito de miedo. Porque imaginad, si las máquinas pueden hacer algoritmos, ¿no? La noticia que os ponía antes, ¿no? Han desenchufado una máquina que ha cobrado vida. No ha cobrado vida, lo que pasa es que por deep learning está aprendiendo ya por sí misma y puede tomar soluciones, ¿no? Pues aquí se habla de la caja negra. Hasta que no sepamos qué ha pasado, o sea, se puede saber qué ha pasado, pero muchas veces no se tiene ni idea por qué la máquina ha tomado esas decisiones. Y es lo que vosotros, si trabajáis en esto, en algoritmia, lo sabréis, ¿no? Esto es un árbol de decisión. Es un árbol de decisión, ¿no? Se cogen unos parámetros, venga, pues si me van a pedir un crédito, tantos ingresos, de tal sexo, tal edad, estado civil, sexo, antigüedad, y aquí no pone uno que es muy importante, el código postal. Si yo llevo muchos años viviendo en determinado, mira lo que está pasando ahora en Madrid, ¿no? Ser del sur o ser del centro de la capital es muy distinto, ¿no? Pues eso condiciona mucho. Pues aquí, en virtud de eso, pues se hace la regla, si se cumplen estos parámetros, luego hacemos esto. Vale, y dices, oh, qué bien, qué bien, sí, qué bien. Ahora vamos a empezar a ver cositas que impactan en estos sesgos, porque la gente que hace esos árboles de decisiones no tiene en cuenta otras cosas que vamos a ver. Pero seguro que estáis pensando, Cristina, me estás hablando mucho de sesgo, pero ¿qué es un sesgo? Un sesgo es de forma inconsciente, una decisión que tomo yo de forma inconsciente y racional y no sé explicar el por qué he tomado la decisión. Ejemplo, aquí no se ve muy bien, Wolfgang Kohler, aquí tendría que salir una imagen, una estrella naranja, así puntiaguda, y aquí tendría que aparecer una figura bombeada así, rosa. Y entonces él hizo un estudio y propuso a varios grupos, cuál era Kiki y cuál era Bauba. La mayoría señalaba la figura puntiaguda. Claro, y cuando le preguntaba, ¿pero por qué? Claro, si hay alguna fonosimbolista en la sala, o sea, especialistas en la simbología del sonido, sabrán perfectamente que es la representación mental del fonema K. La K es puntiaguda, pues Kiki, pues si yo estoy procesando esa palabra, para mí la imagen será puntiaguda, ¿no? Claro, tú dices, qué guay, jaja, qué bonito, pero ahora vamos a ver casos prácticos de por qué tomamos decisiones. Os invito a ver esta acción que hizo la BBC y que le invitaba a varias personas y que les exponía un dilema. Y les decía, un padre y un hijo viajan en coche, tienen un accidente grave, el padre muere y al hijo se lo llevan al hospital porque necesita una compleja operación de emergencia. Llaman a una eminencia médica, pero cuando llega y ve al paciente dice, no puede operarlo, es mi hijo. Entonces le preguntan a las personas, ¿quién es? Claro, empiezan, pues es gay. El 80%, solo el 80%, dice que es la madre. ¿Por qué? Por ese estereotipo, esos sesgos que tenemos, ¿no? Y es que tenemos sesgos. Las personas que trabajamos en Big Data, hay 5 tipos de sesgos comunes de las personas que trabajan del Big Data. Uno es el sesgo de confirmación. Si voy a coger siempre aquellos datos que a mí me apañen y que me vaya a resultar el ejercicio más rápido. Luego la disponibilidad heurística, esto es la falacia de la observación, ¿no? De lo que se llama en lingüística o en las investigaciones de humanidades la falacia del observador. Ejemplo, si yo estoy haciendo un estudio de sociolingüística acerca del registro y os pongo un micrófono, a que vais a cambiar, te voy a decir, voy a evaluar cómo te expresas. A que va a cambiar mucho si nos vamos a tomar un cafelito, me escondo yo el micrófono y empiezo a grabar la conversación. Cambiará, ¿verdad? Pues esto es igual, depende de cómo yo aborde, refiere en cómo los datos hacen inferencias entre esos datos. La paradoja de Simpson, esto es muy importante para explicar por qué es necesario las cuotas de mujeres en las empresas. Esto es aplicable a los datos. Si yo tengo los datos de una gran cantidad de datos, pues imaginaos, si tuviera en el árbol esa decisión, gran cantidad de datos, qué sé yo, de edad, necesito otros datos que me compensen, ¿no?, la balanza, para poder dar y tomar esas decisiones. La no normalidad, ¿no? Los datos se distribuyen de forma normal o normal. O sea, ya los propios sesgos que tenemos las personas que hemos decidido en cómo vamos a abordar esos datos o cómo categorizamos esos datos. Imaginaos, todos estos sesgos están ahí. Y pena que tampoco se vea muy bien esto, os invito, y si tuviéramos mucho más tiempo, os invitaría a ir a la página web moralmachine.mit.edu, o sea, del MIT, tiene una página web que se llama Moral Machine, y entonces es un coche autónomo y nos pide tomar decisiones. ¿Atropellarías a la señora y al niño o atropellarías al niño? ¿A quién atropellas? Claro, porque si yo soy ingeniera y tengo que tomar decisiones, decirle al algoritmo, oye, cuando pase este momentito hay que tomar esta decisión. Y es muy interesante porque no nos explica ningún código ético que tenemos que seguir, simplemente vamos respondiendo y nos sale nuestra toma de decisiones y la comparativa con el resto de usuarios, que hay veces que coincide, ¿eh? Que coincide. No adelanto nada, pero los hombres salís muy mal parados. Salís muy mal parados. Cuando lo hagáis ya lo veréis. Porque está señora embarazada, niño, abuelo, anciano. Y claro, como os decía, y también hay sesgos, obviamente, en persona-máquina, en las redes sociales, en cómo nos expresamos, en los emails, en todo eso hay sesgos. Ejemplo, en Google Translator hace... No sé qué pasa, pero no se ve. Bueno, os lo digo. En Google Translator, ¿sabéis? Se ponía, si ibais a Google Translator hace un año y algo, poníais en Google Translator, she's a doctor, he's a nurse, ella es médico, él es enfermero. Lo pasabais a turco, aunque en turco no tienen marca de género, esa flexión de género no la tienen. Y cogíamos otra vez el turco y lo pasábamos al inglés, ¿qué pensáis que pasaba? Que she's a nurse, he's a doctor. A la mujer no la consideraban. Esto sigue pasando en Deep Delay. El otro día que hice también pruebas en Deep Delay, otra plataforma de traducción, también se dan estos sesgos y hay que corregirlos. O, ejemplo, una chica que decide en un portal de empleo, esto es el año pasado, no os creáis que hace 20 años, no, el año pasado, que dice, ¿qué pasará si yo mi mismo currículum lo pongo en versión masculina y en versión femenina? ¿Qué pensáis que pasaba? Pues resulta que le ofrecía, si era mujer, puestos menos remunerados y menos cualificados. Ejemplo, de ser secretaria a ser profesora contratada doctora. Profesor contratado doctor. Ojo, O esto ya es también, hablábamos de, ¿os acordáis? Los árboles de decisión, género. Pues resulta que el fundador de la plataforma colaborativa Basecamp, pues denuncia públicamente vía tweet que a su mujer no le conceden el crédito ganando igual que él y viviendo en el mismo lugar y le conceden 20 veces menos de crédito que a él. Pero lo más divertido en Apple, esto es en Apple, cuando sacó su tarjeta de crédito justo en noviembre del año pasado, es que Steve Wozniak también denunció que a su mujer no le daban el mismo crédito. Y esto es el año pasado, O otro ejemplo de lingüística, sesgos y demás, y ejemplo de lo que hablamos de la falacia del investigador. Microsoft decide sacar un bot que aprenda de la interacción de los hablantes, pero antes de lanzar el bot lo tiene que entrenar. ¿Y con quién decide entrenarlo? Con estudiantes de universidad que son formales, que van ahí, ¿no? ¿Y cómo es Twitter? Twitter es un campo de troles que eso van a por ti, ¿no? ¿Y qué creéis que pasó? Pues sueltan a Tai, que quería interactuar, pues en menos de 24 horas se volvió machista, nazi, invitando a que volviera Hitler a quemar los judíos y diciendo burradas de todo tipo. Claro, porque ahí ya ha habido un fallo a la hora de entrenar, ¿no? O, por ejemplo, aquí aparecería un slide de lo que nos responden los asistentes virtuales si yo, por ejemplo, tengo, les insulto, les llamo zorra, etcétera. Hay algunas que te siguen el rollo y se ríen. Imaginad, esto es una imagen de marca. El asistente virtual es la marca, es Google, es Alexa, etcétera. Y si yo, por ejemplo, tengo una conducta no ética y me sigue el rollo, imaginaos, yo porque soy adulta y tengo ética y puedo distinguir, pero si son mis sobrinos, si es gente o las fake news, a mí me dicen, no, hay fake news. No, siempre la propaganda ha existido, lo que pasa es que ahora la propaganda es mucho más incisiva, mucho más al detalle, porque nos tienen totalmente localizado lo que pensamos. Incluso saben que nos vamos a divorciar antes de que nosotros hayamos pensado que nos vamos a divorciar. Lo saben las máquinas. Entonces, imaginaos todo ese proceso. Si veis la película Brexit, vais a entender la democracia y por qué insisten no solamente los gobiernos, instituciones en esto, porque es nos la jugamos la democracia en estas noticias, ¿no? En las fake news. O esto, otro ejemplo de sesgos. Hay gente que tiene mucho tiempo, como la gran Judith Duportal, que un día que dice, bueno, me voy a poner a leer toda la patente de Tinder. Toma, oye, fíjate, ¿eh? Dices, tú esto sí que es aprovechar el tiempo. ¿Y qué descubre ella? Pues que resulta que si eres hombre heterosexual, te va a ir muy bien, porque te va a emparejar con mujer de menos recursos y menos competencias, o menos acceso económico, etcétera. ¿Por qué creéis que será? Por la relación de dominio, ¿no? No te vaya a tocar una tía lista que gane más que tú. A ver, a eso puede ser danger, very danger, ¿eh? Pues, y lo expresan en la patente de Tinder. Si eres hombre, varón, heterosexual, te vamos a hacer match con mujeres, perfiles más bajos que tú, ¿eh? O pues la UNESCO también está impulsando que se haga un código ético. De hecho, antes de ayer invitó a las 5 grandes para que empiecen a elaborar un pacto universal sobre la gestión de los datos y la inteligencia artificial. Pues Michal Kosinski y Yurun Wan, de la Universidad de Stanford, han desarrollado una inteligencia artificial que es capaz de reconocer tu imagen, a partir de tu imagen decir si eres gay o no eres gay. Imagínate, vale, dices, bueno, vivo en una sociedad occidental que admite, pero imagínate vivir o estar en una empresa que es homófoba, o estar en un país que es homófobo y que incluso está penado con delitos de cárcel o de muerte, ¿no? Imaginaos el impacto que puede tener eso y solo con una fotografía. O el caso de esta aplicación FaceApp, que cogías, te haces la foto y te pone en ultra guapa, ¿no? ¿Qué pensáis que le pasaba a las personas de color? Que les ponía blancos, pero no solamente blancos, sino porque no la podéis apreciar el público de aquí, pero este señor tiene los ojos, le ponen los ojos hasta azules y no los tenía azules, o sea, un patrón totalmente caucásico, ¿no? O Google Fotos cuando lanzó su versión beta, que etiquetaba a las personas. Tú imagínate venga, voy a etiquetarme. Y si eras negra te ponía gorila. ¿Por qué? Porque los equipos de desarrollo, la mayoría, el 80% está compuesto por hombres blancos, judio-cristianos, de mediana edad, heterosexuales y sin discapacidad. Entonces, todo lo que se salga de ahí no hacen beta tester, ¿eh? No hacen testing ni nada, ni prueban con personas de color. Y ahora, y esto porque no lo leéis bien, pero es un tuit que justo lo he añadido hoy, porque lo vi el viernes, hice pantallazo y lo he subido hoy, acerca de un chico que denuncia públicamente que en Zoom no puede ver a su compañero de trabajo. ¿Y sabéis de qué color es su compañero de trabajo? Negro. Zoom no lo reconoce, sale tal que así. Esto la semana pasada. La semana pasada. Y claro, y esto no lo veis bien, pero es la imagen de una mujer, un reconocimiento y luego un robot enfrente, un concurso internacional de belleza que lo evalúa una inteligencia artificial. Vamos a ver, ¿qué es belleza? ¿Qué es lo bello? Luego, ¿qué patrones se van a seguir para qué es lo bello y qué es lo feo? Se van a seguir patrones de, como hemos visto, lo caucásico, blanca, perfil blanco, ojos azules, ¿no? O este ejemplo, un dispositivo de dispensador de jabón que a personas negras no les da jabón, porque el sensor no es capaz de reconocer la piel negra. Otro ejemplo, Compás, no sé si lo conocéis, es una herramienta de inteligencia artificial que diseñaron en el gobierno de los Estados Unidos para evaluar el índice de criminalidad de las personas. Obviamente, si las personas con menos recursos no pueden acceder a una buena defensa, las personas de color y las personas latinas, hay mucha más población latina y de color en las cárceles. Entonces ya la máquina dice negro, criminal, latino, criminal. Ejemplo, este señor, porque no lo podéis leer, que es blanco, es un pieza con robos, con violencia doméstica, o sea, un montón, le ponen solamente un índice de criminalidad 3. En cambio, el pobre Robert Cannon, que está aquí, que solamente ha insultado, o no sé, que ha tenido una ofensa, que tal como están las cosas, como ya veis en Estados Unidos, una ofensa, vete a saber si ha sido que no le quería dar el DNI, o el ID, ¿no? O el carnet de conducir allí. Pues un 6. Y ya lo han quitado. O el caso de Cambridge Analytica, ¿no? Todo lo que eso conllevó, que llegó a declarar y simplemente hace pues un Juan Carlos, lo siento, no lo volveré a hacer más y ya está. Pero, claro, yo espero que las personas que estáis trabajando en inteligencia artificial o que queráis trabajar en inteligencia artificial seáis conscientes de esto. Este es el gran reto, es que este es el reto. El decir, estoy haciendo cosas que tienen un impacto en las personas bestial, no solamente económico, o sea, no le puedo negarle un crédito, puedo, hacerle sentir fatal, ¿no? Y menos mal que hay personas como Rachel Thomas, que os recomiendo sus charlas TEDx y su trabajo de activismo, que denuncian todas estas prácticas, que denuncian estas cuestiones y que se explican muy bien en Armas de Destrucción Matemática, si no lo habéis leído, de Casey O'Neill, que dice que, claro, los modelos apuntalan a los afortunados y castigan a los oprimidos. Bienvenido al lado oscuro del Big Data, ¿no? Vivimos en la edad del algoritmo, las decisiones que afectan a nuestras vidas no están hechas por humanos, sino por modelos matemáticos, como habéis visto en todos los ejemplos que hemos ido viendo. Así que yo espero que a lo largo de esta exposición os hayáis dado cuenta que los robots no son asesinos. Los robots aprenden patrones, es pura matemática. Los asesinos, en todo caso, o las asesinas seremos nosotros, las personas, o quien realmente ponemos sesgos en los datos, o quienes realmente podemos cambiar el mundo somos las personas. Y esto es lo que dice la gran Nuria Oliver, que es necesario regular esto. Y claro, pero es que empezamos con la autorregulación. Es que nos quejamos mucho, pero ¿cuántos de nosotros, he leído y acepto? Ya. Y no nos paramos a pensar las consecuencias de todo eso. Y claro, ¿en qué se trabaja? La gente que trabajamos en inteligencia artificial, pues inició con las leyes de Isaac Asimov, ¿os acordáis, no? El robot en ningún caso va a hacer daño al humano, ¿no? Si se tiene que autodestruir, no va a dañar al humano, que vienen a decir eso en Yo Robot, ¿no? Pero ya hay estos códigos éticos, ¿no? Los aspectos del Big Data, de la ética del Big Data, pues la identidad, o sea, evaluar qué es lo que constituye la identidad. Imaginaos el gran reto para nuestros niños y niñas y jóvenes. Nosotros no teníamos esa identidad digital, pero ahora ellos construyen su propia personalidad y su identidad a través de las redes, de esa influencia. Bestial, ¿eh? Bestial todo lo que reciben. La privacidad, gran reto, esa privacidad, esa capacidad de yo exponer los datos que quiero. Es que aun omitiendo no me sigas, me siguen. O nos están escuchando, claro que te están escuchando, o sea, etcétera. El ownership, esa capacidad de quién tiene mis datos, quién es el propietario real, porque el Cambridge Analytica, ahí el propietario real era Facebook, pero lo utilizaron para conseguir el Brexit. O sea, y luego la reputación, ¿no? Eso se habla. Y sí, aquí no lo veis, pero es Naciones Unidas, ¿no? Que están trabajando por la privacidad, porque no hay código ético, sí. Hay GDPR aquí en la Unión Europea y, de hecho, el artículo 22 de la GRPD, si a mí hay un proceso donde interviene un algoritmo en la toma de decisión, donde yo vaya a tener, imaginaos, un crédito, yo si voy al banco me tienen que explicar bajo qué parámetros trabaja ese algoritmo. Me lo tienen que explicar. Fijaos, ahora vete tú a un banco y que te explique el señor o la señora cómo ha procesado esa información y por qué. Y lo más complejo, que es la ética, lo que estáis viendo, el gran reto, pues resulta que la Unión Europea lanza unas guidelines, ¿no? Dice, tiene que ser justa, tiene que ser ética y robusta. Robusta en el sentido de que se pueda replicar y que se... Pero, como veis, y si nos vamos a la Estrategia Nacional de Inteligencia Artificial, no hay código ético. Pone ahí, prioridad 6, construir la redacción de un código ético de la inteligencia artificial, pero no hay código ético. Y hay gente, hay grupos, asociaciones como AI4EU, ¿vale? Que sí que están, que es una asociación de legalistas, de personas que trabajan en ello. Nuria Olivera habla de estos 5 componentes, ¿no? Para trabajar, para las personas que trabajamos en inteligencia artificial, 5 componentes que nos pueden ayudar a abordar la ética de nuestro trabajo. 1, la justicia, fairness, o sea, que sea justo, que evaluemos si es justo o no es justo. Todo el mundo sabemos si es justo o no es justo. La responsabilidad. Si yo estoy haciendo eso, tengo que asumir que esos datos pueden utilizarse para eso otro. La simetría, la compensación, la justicia, que tiene relación con la justicia. La transparencia, que yo pueda explicar, ¿eh? No es fortuito que el Gobierno de Aragón, que en Aragón haya tantos datos, pero es que en Aragón está gestionando de forma transparente los datos, cosa que en otras comunidades autónomas no se están gestionando de forma transparente. ¿De acuerdo? La transparencia es muy importante y eso, quienes trabajáis en Open Data, es admirable, ¿no? La ética, la educación, todo empieza por educación, por la falta de estereotipos, y la diversidad. Por lo que os decía, si en ese equipo de desarrollo, en ese equipo de negocio, en ese equipo de venta son todos señores blancos, judio-cristianos, heterosexuales, sin discapacidad, no van a pensar en posibles usuarios, en posibles personas diversas. Y esta es una plataforma que os puede ayudar a abordar, a ver los sesgos de los datos. Si subís los datos, os dice cuán sesgados están. Se llama iFairness 360 y es de IBM. Es de open source, subís los datos y os dice cuán sesgados. U otra herramienta muy útil y que yo siempre la recomiendo, el fundador de la web también es fundador de esta asociación para el uso ético de Internet y es un Model Canvas. Yo supongo que sabréis lo que es un Business Model Canvas, que es un plan de negocio en lámina, ¿no? Pues aquí es lo mismo, pero todo centrado en la gestión ética del dato. Cuánto impacto vamos a tener, y esto lo tenéis que crear entre diferentes equipos de marketing, comunicación, legal, compliance, negocio, IT, porque os va a ayudar no solamente a aprender mucho mejor qué se está haciendo con esos datos, sino a evaluar todas las perspectivas. Y ya estoy terminando, ya como decía Francesc Cholet, ¿no lo veis? El creador de Keras, que es una plataforma muy relevante en inteligencia artificial, decía, antes me solía preocupar que la gente no supiera de matemáticas, pero ahora lo que realmente me preocupa es que la gente no sepa de humanidades. Porque la inteligencia artificial y la tecnología, como os he intentado demostrar, es que necesita diversidad, pero diversidad de identidad. O sea, no solamente de género, sino también de raza, cultura, etcétera, orientación sexual, diversidad de conocimiento. Personas de humanidades tienen que trabajar con personas que han hecho ciencias. Ya el estatus está la pirámide de los ingenieros somos el top, los de humanidades sois losers. Esto así no va el mundo, no evoluciona el mundo, porque una persona de humanidades igual puede aportar igual, ¿no? Y mucho a que el producto o la solución sea buena. Y sobre todo gente buena, como decía Machado, en el buen sentido de la palabra, que sepa, porque como dice la gran Maya Angelou, la gente olvidará lo que dijiste, la gente olvidará lo que hiciste, pero nunca va a olvidar cómo le hiciste sentir. Muchísimas gracias.
Unit 4, more specifically Unit 4 FP&A. And yeah, I'm really thankful that we are able and have the chance to share our view on artificial intelligence combined with FP&A and how we use artificial intelligence already. And yeah, I'm feeling kind of honored. So I have now 30 minutes to bring you that topic a little bit closer. I hope you will like it, and let's start through it. So before we dive in, I would like to take the chance to introduce a little bit
Unit 4 and a little bit what we mean with FP&A. So, like a little bit what we see as the Unit 4 overall product strategy on, and also then, of course, with what we do with artificial intelligence, is what we call the Unit 4 People Experience Suite. And the People Experience Suite is our overall product experience. It is our strategy that we will provide solutions which are easy to use, are conversational, are supported by workflows across any organization, automation of tasks, which is an important topic because a system can provide you notification when action is required, and also automate any tasks. And in the end, it's about decision making, it's about insight into operational processes in the organization. So overall, Unit 4 has a strategy to provide some, let's say, smile if you use the software. And I think software and products should make fun, and this is what we also aim for. So with our people experience, and you see the three circles here. It's like the one thing is elevate your business, master your business, and this is what our ERP, Enterprise Resource Planning System, stands for. In the middle, it's about people. Of course, the people are using the software or the solution, and it's about engaging those people working with that. And therefore, we have solutions coming for the human capital management sector. And then finally, the right circle here is plan your future. And that's basically my playground. It's the playground of FP&A. It's about planning, budgeting of any business processes. It's about forecasting supported by AI. And it's about dashboarding, providing visibility into data. So this is basically the three main purposes we follow with our People Experience Suite. And then you see on the bottom here, the People Platform. And the People Platform is somehow, I would say, the powerful engine of our People Experience Suite. The People Platform provides tools and services which are all microservices based, which are all multi-tenant, and can be used from the different solutions we provide. For example, the smart automation services, which is used for machine learning, the digital assistant, which is one of our use cases I'll present you later on. And overall, it could be said that it's a very open, and it opens the People Experience Suite to integrate applications, for example, from partners or from third parties. So this is overall our strategy, how we see our products and how we plan our product to develop. So, but let's have a closer look about FP&A, and FP&A stands for Financial Planning and Analytics. So, and as I mentioned, there are some good practices comes along. So this is what we also provide, because you can provide in a solution functions and features, but this is only one side of a medal. On the other side is what you do with these features and functions. And for that purpose, we have pre-configured models, pre-configured content which we bring to our customers. And I just want to highlight them because then you better understand the use cases for AI, which we talk about later. It's different models which we bring to the customer, which can be very easily implemented and then be used in the organization. So this is the value we bring also with. And you can imagine in a financial planning, for example, the balance sheet or the cash flow report is something which is pretty set in stone. Maybe the input from each organization a little bit different, but overall how you do it is knowledge we bring across. So when we talk briefly about what we bring across to our customers, we talk about intelligent FP&A, and this is a little bit the values and description of the benefit if a customer now have an FP&A solution with us. So one thing is about speed. So, and this is pretty obvious right now. So it's about a planning process takes sometimes a lot of time, and we want to reduce those time to be more quickly, to easily react on some changes, and still ensure the quality. It's about taking control of the operational business, also from a financial point of view. And very important, and this is what we all in Europe, all over the globe face right now, is respond to a change, some uncertainty we have. And the COVID situation showed it quite obvious that we need to respond and need to provide a financial planning to ensure business continuity very, very quickly. So this is one thing, like speed and accuracy. The other thing is about, again, the people, empowering your teams using the software, the tools for the planning process. If you look into organizations right now, no one will scream, yay, let's do the planning process, because usually it's not like something you really enjoy doing it, but still it is required. And with our solution, we try to increase the participation to make it very easy to use, because then you can onboard all the people in the forecasting processes, but you need to make it easy. And in the end, if you then do it, you do not waste time on, let's say, complicated planning, forecasting, budgeting processes. You free up time for your team to do some more value-adding stuff. And this is really important nowadays. And how we do that? On the one thing is, of course, our FP&A solution, and which was now enriched with AI-enhanced forecasting tools. And this is also one of our main use cases. And finally, which comes by, and which is also very important, because how you do your planning. You do your planning based on actual and accurate numbers. This is required because you need to know a little bit the historic to plan the future. And so that's why it's very important to have a common set of database, a single source of truth, and because everyone needs to look at the same number. And I think some of you already experienced it, that you were in a meeting and someone is talking about that revenue number, the other one is talking about that revenue number. They are talking pretty much of the same, but the numbers are different because they are from different sources. So this is also a very important part that you also cover before planning also the analytics part. And then therefore we also provide tools and a tool set of easily interpreting numbers, like visualizations, graphics interpretation of numbers. And this is our A in our name, the analytics part, which we also offer a solution for it. So, but now let's look into the, let's say, most interesting part of this presentation, and I think also what you are expecting, and this is also referring, of course, to the title of the whole South Tech Week. It's about the artificial intelligence part. And here I would like to bring you the use cases closer, what we are looking at and why we do that. And basically, it's also a good question. So why do we do it, and why do we do it now? So, of course, what you know, the computing resources, they are there. They are getting cheaper. And this was also already increased in the last 10 years, 5 years, but in the recent years also, so that the access to computing resources is easy to get. And you look at any cloud architecture we can use. The other thing is the data availability. And nowadays in business organizations, there's tons of data. They are available. Sometimes they are siloed. They are not accessible for everyone. And it's really something which, and we are discussing this a lot with our customers, gets more and more used, but still data back now is here, what we could use also for AI use cases. And if you look back a little bit, it was not there. So this is something important. And another thing is you still need to handle with limited resources. So in organizations, there are not enough resources to work on every request. So a limited team, in an FP&A team, needs to work on requests from management, from business partner on data. So you need to handle those multiple requests with this huge amounts of data with limited resources. And then, of course, the current challenges from outside, from inside, need to be covered. So this is the reason why we think of how could artificial intelligence support our FP&A teams. And so we discussed this a lot, and because our customers are our main stakeholders, and then we come up with some of our use cases, and I would like to quickly go through it, that you get an overview, and then we jump into more detail. So, digital assistant. This is a people platform service which is used from a wide variety of our products. It's about interacting with the software, with a digital assistant. Automated data entry checks to ensure quality, forecasting, and this is, I think, our main use case, that we provide a tool for our FP&A teams to forecast any numbers for the future. And finally, the last use case we are looking at, which is where we don't have so much in software right now, which is planned to do, it's analytics, and we touched it later a little bit in more detail. So let's have a closer look into our digital assistant. Within Unit 4, we call it Wonder. So like you have Alexa, like you have Siri, we have Wonder. And it's like really that this assistant, Wonder, does speak FP&A, we can say. So and you can imagine a situation where a CFO, financial director, wants to understand, for example, in a specific region, where are my revenues, my cost levels there, and wants to get that number very quickly while he is on the way and only has access to his mobile phone. So, and he could easily just open MS Teams, for example, put in some questions like show me my revenue, as you see here on the screen, and you get the number from the systems. And then you can do also some comparison of actual to budget. And then also finally, you can say, okay, dear Wonder, please send this report to my regional manager and ask for feedback. So in the end, this is a conversational interaction with the software, and which can be, is therefore very quick and easy and can support, because otherwise the financial director would sit in the office or need to make a phone call to get to the information. The second one, which is already in the software, it's about data entry checks. It's about data quality, and data quality is somehow really key for an efficient financial planning and analytics. It's otherwise if you don't ensure a specific value of quality, then you really get into trouble and time-consuming activities. And so this is the use case where imagine a user, he is open up the FP&A solution, needs to type in data for a forecast for the next week and wants to plan, for example, a project, and then he types in some numbers which are from the system, which are kind of seems not correct because it's an outlier. And then he instantly gets a response from the system that tells him, dear user, please have a closer look. Are you really sure about that number? Because from my comparison, it does not fit into that. And so it's a really instant interaction and can help to get a double check on the number, because later on to check and clean the data, it's time consuming. And so this interaction can help to ensure data quality. And then another thing which happens daily in an FP&A situation, that you have some kind of deviation. Many things do not run as planned or as forecasted. So you have a deviation to budget, to plan, to forecast. And what do you do then? So the FP&A user sees the deviation, then he needs to dig and investigate where does this deviation comes from. And in most cases, this identification does take only a few minutes. But if you sum up all the few minutes during a week, during multiple employees working on that, you really come to a huge amount of time where you think, this is not really value adding, this is just time consuming. So the AI-enhanced analytics will take over this time consuming, and sometimes it's a little bit boring as well, right? Investigation to explain the reason for deviation. So if you think of a revenue number comes from an area or from different customers, and in the end it's a multiplication of the amount of a product and the price for a product. So it's pretty set in stone where a deviation could come from, and this can be automatically analyzed, and then the results can be brought back to the FP&A team. So this is really, for me, also a very huge use case, because it could save a lot of time. And then if you think that thought a little bit further, it could be in a second step that not only the deviation would be presented from the AI-supported tool, but also like proposals how to improve the situation. So like, because you have reacted in the past like this, why not doing this and that? So this is a little bit more future sound, but already in our discussion how we realized that, and I think there's a real benefit and value add for our FP&A teams and providing more capabilities for this automatic analytics. So the next use case, which is for me the most promising and also already the biggest portion what we have brought into the software already, it's about the AI forecasting. We call it Smart Forecaster, and it's like it's when you want to forecast time series, for example, revenue, for example, cost. It's really a great tool, and it helps to get an understanding and to provide an easy forecast. It's based, of course, on historical data. It's based on neural networks. It's based on a training which needs to happen before you can use that. But if you then imagine, we dive into an example, is that there, and it's for me, it's the most interesting thing also of that, because if you think of doing a forecast, and you know, for example, if you want to provide some hotel bookings, and then you have some influence factors like number of tourists, number of events taking place, or multiple influence factors which come up then with a forecast for you as a human. But the volume of information you can digest is kind of limited. And with the AI Smart Forecaster, it's like almost limitless, because you can look at multiple influence factors. It's automatic, it's processed. Then maybe a longer training process needs to take place, but in the end, all these influence factors can be taken into account. And secondly, such a system will get trained over time, so it will improve the forecast results even more while using it. And I think these are the most important parts and benefits of the smart forecasting, and we see already in real life. So the approach, I briefly touched on it. Of course, it's based on past experience. Of course, you need to have some assumptions for the futures, and then you get the results of a forecast. So basically what we do in our software is, on the one hand, what I said, okay, the definition of a use case. This is a first 0 step. This needs to be done also with our customers. It's all about data preparation. There needs to be some data preparation done, and also FP&A is a multi-dimensional data cube tool for planning purposes. There needs to be also some preparation done here. This is in our project team. Then a training needs to be defined, and then you can start the training in our cloud environment because you need some computing resources for that. And in the end, you get results, and you can use that one for further forecasts in your organization. Yeah, the topic about retraining, I will jump over it, but yes, this will happen then. So, yeah, but I would like to jump into an example in that you see it now also in real life. So imagine we have a situation that we are in UK. There is Petrol Station Corporate Limited. Me, Oliver, I am a regional manager for this gas station. We have multiple gas stations across UK. In my area, I have 4 different local gas stations. I have the M25 motorway, which is a larger gas station. It has an opening hours between 16 hours and 24 hours a day. But I do also have some smaller gas stations in my area. And here are some indicators, some factors which are influencing my my numbers for each gas station. And within my weekly processes, I have one process where I need to forecast my staff, which I need in order to get the station running. And of course, if you have a large motor station, which is open 24 hours, I need more staff. And if I have only my smaller one, I need less. And also, of course, the day, if it depends if it's a weekday or a weekend. So, and I get asked of my weekly forecast process to do that. And usually it's manual input where I type in the number of staff in full-time equivalents needed per day. And usually I also need to talk to Barbara, Richard, Robert, Margaret, the local guys, to have a discussion with them and to get the alignment on number. And then I need to provide that feedback to the petrol station corporate controlling. So, but this morning I received an email from the corporate controlling that we have something new in our FP&A solution. It's called Smart Forecast, and I think I want to try that out. So let's let's do it, I would say. For that purpose, I jump into my FP&A solution, quickly need to log in. So that works. Let's start it from the beginning. Need to log in. 1 second. Yes, here we are. So here is my landing page of my FP&A solution. And then let's have a quick look into the data which is used for this AI forecast. So they open up the cube which is used then for the AI forecast. So I see here different scenarios. We are only talking now about the base data. Here are my different gas stations I want to do, or I have to do the forecast. I see we are working on data of the last 4 years, starting in 2016. We get the data from the weekday, if it's a Monday, starting with a 1, and the Sunday, it's the 7, so 1 to 7. We are looking if the day is a holiday, and if it's a holiday, then there's a 1. If it's not on holiday and a regular weekday, it is a 0. We are looking at the business hours, as mentioned before, and okay, they also use the oil price, which kind of makes sense, of course. I did that from a gut feeling, more or less, but I think it would make sense, definitely. And then we have here our staff actuals. Of course, we are looking in the past that we have these numbers. So, but let's have a look into the AI forecast. So for that purpose, I open here the AI forecast. This is my 7 days forecast. That was already trained from corporate controlling. So this is done. I just want to show it briefly. Yes, we have here the AI forecast, a name and some comments. The definition of the training was already done, and I said yes, they look at the weekdays. I don't want to edit it right now. It is the holiday, the business hours, the oil price, and the staff actual. So they all take this into consideration, which is good. Then there are some, yes, it's also important, like how the data should be forecasted and then transported back to the FP&A solution. So yes, I just have a quick check. We look at staff forecast, yes, next 7 days, base data, and here, okay, we look at now the 2 gas stations. So yeah, it looks good. Let's just do it, save and execute. So what happens now? Out of the FP&A system in the data cubes where we have our data model, this gets now transported to our AI service, the artificial intelligence service in the cloud. And then the forecast is done, and then I soon have my data back. So the only thing I would like to have a look, because what happens automatically in the system, that 10% of the data for when they did the training of the neural networks is used to make a test. And this is what I want to look at right now. And you see here some values from the days from 2016, and this goes all along until 2020, and this is randomly picked numbers, and this is also the way the system kind of self-optimize itself, because it tested it, how it was, the training. And when we look at the data here, for example, here for the M25, and we have the staff actual, there's some kind of pattern, of course. And then there was the test results without the oil price, and we see it's pretty good alignment of the test data, taking into account the influence factors we talked about, and staff actuals. There are some outliers, yes, but overall I think that the pattern is there, which is good. And then they also include an additional influence factors, the oil price, which is then here. And I think this is also a pretty good forecast. And if you compare both, like if we look at both, we see that with including the influence factor, the oil price, it's a little bit better result than without the oil price, which from a gut feeling also makes sense to me. So let's have a quick look also at the other station, how the results look there, the test results. And by the way, this is our analytics part of the FP&A solution. Here the numbers then changed. And I see also a very good result, I would say. The test results look fairly good. We have included 4 years, which is almost 1,460 days of data, of actual data where we can look at. And yeah, here, for example, there is some outlier. It's the 26th of December. I'm not sure. Maybe this results to within the past there were maybe some additional resources needed because people are traveling out. I don't know exactly. So maybe then we should go into the data. But overall, I would say a pretty good test result. So let's have a look at the forecast. I would say go back here into my smart forecaster, and this is basically now open up the template where I filled in the values, and here we are. Let's close that. So this is my typical template where I fill in my forecast, and as you can see here, this one in that column is the forecast which was provided from the for the AI forecast, and I think it's pretty good. It's really, the pattern is there. You see the same. Maybe it's a little bit higher expectation, and I can now do a little bit manual adjustment on it. Maybe it's because I look into full-time equivalents also, so I kind of readjust a little bit. But yeah, in the end, I get a good feeling, and I think I do not have to call now Barbara and Richard because I already got my numbers here, and seem to be a pretty good tool, and I will use it definitely in the future. Yeah. So yes, this was basically the smart forecasting, where I say so this can be actually the way how it could be used in the future, and it's very easygoing. It's very easy to use, and it's kind of really saved my time because I did not need to call Barbara, Richard, Robert, etc. So, but let's have a quick look, like how does this could look in practice, and that's why we briefly touch a actual project. And this is a project where we use the AI forecast already, and it's a supermarket chain with 150 stores, and they have developed in the past an algorithm to forecast the staff needed in those stores. So imagine 150 stores open 12 hours a day. They need maybe 10 to 12 full employees working in that store. So it's a huge amount. And our result here, and this was really magnificent, like how it could be improved, because they built this algorithm, which was manual, which was done in the tool, but it took a very complex calculation and the definition of the algorithm, which needed 300 influence factors. So, and we did the same, and we looked, and it was perfect for us because we had the comparison of the algorithm and our AI enhanced forecasting. And what you see here is that the algorithm has a mean error of 9.27, and the AI forecast was way lower, about 4.45%, which, and overall, in 69% of the test cases, and the AI forecast was better. So what that means then for this customer, it is like the forecast is way quicker because they just now hit the button, the model is already trained. They do it in the future, would not need to maintain the 300 different value drivers to get this algorithm up and running. It's a much more simplified approach with the AI and forecast, because there we only need about 10 influence factors, and it's again about speed and accuracy. So this was an example which is still ongoing. The project is ongoing. They want to improve it even more, but this is how we see it much more coming in the future. So, yeah, with respect to the timing, I think almost my 30 minutes are over, and I just would like to recap the AI use cases, what we touched upon in that short presentation, and what is kind of food for thought for you as well. So we looked at our digital assistant, which is a Unit 4 wide service, which is used also from the ERP system. We looked at the data quality and how we could improve data quality in our FP&A teams in the yearly processes of budgeting, forecasting, and planning. We looked at our smart forecaster, which is already in the software, and with the first projects we start working with customers on the use cases and on the specific projects, which is great and will really improve the forecasting. Either you trust it 100% or you get more used to it. And I compare it very often with Google Maps, where nowadays we are really trust Google Maps right now. If you look 10 years back, it was not the case. And finally, the automated analytics, where we say, yes, this is a
Há muitas maneiras diferentes de ser humano. Temos de respeitar e abraçar essas diferenças.
这个6月，我们一起庆祝彩虹骄傲月，请不要因为他们不同于我们而歧视他们、攻击他们、剥夺他们平等的权利或法律的保护。
Kampen om rättigheter för hbtqi+-personer är centralt i kampen om mänskliga rättigheter.
Members of the LGBTIQ+ community continue to be targets of brutal attacks, many of which are left unpunished.
Nemalo by byť nič kontroverzné na zastavení vražd alebo ukončeniu diskriminácie ľudí len za to, akí sú alebo koho milujú.
Более чем в 70 странах мира однополые отношения по обоюдному согласию преследуются законом. А в 12 из них сексуальные связи по согласию между людьми одного пола могут караться смертной казнью.
15 países penalizan la identidad y/o la expresión de género de las personas transgénero, utilizando las llamadas leyes de transvestismo, de suplantación, de disfraces.
LGBTIQ+-mensen kunnen worden geconfronteerd met lange gevangenisstraffen en in sommige gevallen met fysieke straffen. Deze wetten moedigen ook impliciet vooroordelen, haat en geweld.
But laws can change.
Pary homoseksualne mogą legalnie zawierać związki małżeńskie w 26 krajach na całym świecie.
Par av samme kjønn kan adoptere barn i 28 land.
Weltweit kennen 12 Staaten ein drittes Geschlecht gesetzlich an.
Brasil, Ecuador y Malta han prohibido las llamadas terapias de conversión.
In 19 Ländern können Transgender offen bei den Streitkräften dienen.
9 pays ont inscrit dans leur constitution l'interdiction de discrimination fondée sur l'orientation sexuelle.
Huirseachta chathair cosc ar idir ghaelú san Ionad Oibre, bunathe ar chléin a gnéasach.
El amor es amor.
L'amour, c'est le respect.
El amor no tiene género.
Ama quem tu és.
El amor gana.
Ser pitaknek čuni.
Unidos en la diversidad.
Ah, genial. Pues le doy. Hello everyone. I'm Samuel Muñoz. I work for BBA Next, which is a company from the BBA Bank, BBA Next company. And I would like to thank you all to assisting to this presentation on this topic, which is a gentle introduction to reinforcement learning and inverse reinforcement learning. I've heard there are people from France, Brussels, Brazil. Greetings to all of them. Y un saludo al auditorio que estáis por ahí, a todos los hispanohablantes. Es una pena no poder estar con vosotros en Granada, pero con el tema del COVID ha sido muy difícil. So from now on, I'm going to continue this talk in English in order that everybody can understand it. Okay, the motivation for this talk is that, as I've said before, I work for BBA Next Technologies, and I work as an innovation engineer. Especially, I lead the artificial intelligence area. And 2 years ago, we wanted to have a good grasp on what was reinforcement learning. You know, it was on the top of the wave. Everybody was talking about AlphaGo, DeepMind, and we wanted to know the real deal. So the talk I'm going to show you today is going to be about reinforcement learning without bullshit. That's it. So you're going to learn a few things. It's a pretty introductory talk, and if we have enough time, I don't know if it will be possible to talk about inverse reinforcement learning, which is the real deal we wanted to know about. From now on, I'm going to start and see the time. Okay, first of all, what is reinforcement learning? To put it in the science area, we're talking about computer science, then inside there is artificial intelligence, then we have inside machine learning, and at the same level we have supervised learning, you know, classification or regression, unsupervised, which is clustering, and reinforcement learning, which is, in my opinion, the art of taking decisions. So this is an area of machine intelligence where we have an agent in an environment, and it has to take actions in order to perform or to optimize some function, and you can give it rewards if it performs well, or you can punish it if it performs bad. So what are the elements? There is an environment that is the world where the agent lives in. The agent has sensors, so it can read the world or the state of the world. It has actuators, so it can do things, it can perform actions. And the thing is that the agent knows the rules of the environment of the world. So it has to learn in order to perform the task he has been given to. It is driven by if it does good things, I will give him good rewards. If it does bad things, I will punish it. So good rewards encourage good actions, bad rewards discourage bad actions. So key concepts. What is an agent? We say the agent is an autonomous entity which observes through sensors and acts upon an environment using actuators and directs its activity towards achieving goals. It's the intelligence we put in the world in order to perform things. You can think about a robot, a physical robot. You can think it about a program, or you can think it about, from a Pavlovian perspective, a dog, and the task is that you want to give him the leg. The environment is the world where the agent lives. And the policy, in this case, is stated with the Greek symbol P, or PI, is the map or the function the agent uses to take action on a certain state. So what we're taking here is that when the agent is in the environment, when it reads the word at this specific moment, we're gonna call this as a state of the word, which is an instant in that specific moment. So you are gonna grasp that the state of the environment could be, an environment could potentially have infinite states. And the policy is, given a state, what should I do in that environment, or the agent? Okay, so if the policy gives the agent the best expected reward, then it's optimal. So the best policy, the best thing the agent can do, the best action it can take, we say it's a PI star if it is optimal. That is what we want. A bad policy leads to bad actions, so the agent is not going to perform well. So then the difficult part of this kind of problems is to balance between exploration and exploitation. That is, we have said at the beginning that the agent doesn't know anything about the world, so it has to explore, to test things. But at the same time, we want it to perform well. So how much are we letting the agent to explore the world? How much can it fail versus how many rewards are we gonna take from it is a quite difficult problem, especially in some places, for example, the stock market. You have a limited budget, and if the agent explores a lot, you're gonna lose a lot of money before it becomes profitable. So you have to balance it. Other example is, for example, in autonomous driving, if the car crashes at the first time because it is exploring, you could die, so we don't want to have this kind of behavior. So this is archaic concepts that you have to take in mind for the rest of the presentation. Okay, formally, from a mathematical point, we're going to model it like a Markov problem decision framework, which is everything is a 5-tuple, and in each step of the problem we have S, which is a finite set of states. I said before that it could be potentially infinite. In this case, we're going to reduce it so we have a finite number of states in the environment. We have the actions we can perform. We have the P, which is a P of A, S, and S prime, which is the probability of transition from S, from one state to the next state if we choose the action A. That is, for example, if I throw a ball, the ball is going to fall. That is probability 1. It's going to happen for sure. But for example, if our agent is playing in another environment, for example, in Dungeons and Dragons game, it can say, I want to kill the wizard. And the master of the game can say, okay, throw a dice. And if you have more than a 6-faced dice, if you have more than 3, you perform the action. That is, we have a 50% of probability. That is what it models in some kind of problems. Okay, the reward is if we go from a state to the next state given an action, how much is the agent winning? How we compensate this behavior? And the gamma is a discount factor because there are some actions that are very good in approximate future, but in a far future they are not so good. It happens, for example, in environments like the chess game, that you can be very greedy taking the opponent pieces, but it could be a sacrifice in order to checkmate you in 4 or 3 next moves. Okay, so what is it useful for, the reinforcement learning? Okay, it is used in industry and robotics, especially where there are very complex environments where you have to, or very high dimensionality environments where you have to test a lot of things. In finances, it's been proven to be successful, especially in high-speed trading. You know that micro crisis we faced every day because of this kind of technology. It's made its point in games like chess and Go, where the environments are very limited and the rules are very well known. So they are nearly solved games. In chatbots, in advertising in order to have a better revenue, and in recommendations. I left some resources in the presentation, so if you have access later, you can check them. So the first thing of reinforcement learning It was robotics a lot of time ago, and it was the the carpal example. It's been modeled virtually, I think, in the DeepMind AI gene. And the thing is that you have a pole and you have to take it in an inverse equilibrium with a thing that moves forwards and backwards. And then we see that in the first trial, it is exploring. There is no way it can put the pole to the top and keep it in on an equilibrium. Then we passed. And for example, in trial 83, it has learned to spin it 180. It can spin it and put it on the top and nearly balance it very well, but it's trembling. So you can punish this kind of behavior so it stays the most still possible. And at the very end, it is possible to adjust it with the less movement and make external forces to test it. So you can see it performs very well, the thing. And nowadays, I say today, but it's 2018, 2 years ago, Boston Dynamics presented this robot, which is what was called Parkour Atlas, and it was a bipedous robot who can perform parkour tricks. It's pretty amazing, but the thing is that it's part of reinforcement learning. I think it's minimal because it's been modeled with other kind of engineering techniques. But there is potential to do this kind of things in reinforcement learning. The problem is the exploration part where you can lose the robot if it not performs very well and have a fatal accident. But you can see it's pretty amazing, the performance. Okay, so we have these things in mind, and we wanted to perform some kind of experiment to our level. This is the very first experiment. It's quite easy, but if you understand the things, you will have a solid foundation on what reinforcement learning is about, and other things that will be present to you in the future. So, first thing, we have to choose our environment. Yes, it's a little bit inspired by war games, and we chose from the games. So we play a game, then we have the list, and of course we are in innovation. We took the global thermonuclear war. No, I'm joking. We took the tic-tac-toe. Okay, the tic-tac-toe is a very easy game. It's a 2-player turn-based deterministic game. X is the first player symbol, and the O is the second player symbol. The board is a 3x3 grid, and a player puts a symbol on an empty cell, and the first player to own a row or a diagonal or a column wins. That are the rules. So from this easy environment, what can we infer before tackling the problem? The first thing is that we have over 7,000 essential different positions that are few positions. There are over 26,000 possible games with rotation and reflection, which is, it seems to be a lot, but with modern computational power, it's nearly nothing. It is a futile game, so it means it's a solved game. It means that one can only lose or draw against an optimal opponent because it's solved. If you know the optimal strategy, you cannot lose. It's a solved game because it is possible to calculate the game tree, and it was and if both players are optimal, the result is a draw. You cannot force the other player to lose. Okay, they are 138 terminal board positions. 91 win X, 44 we know, and the second player, and 3 are wrong. And there are over 255,000 games, unique games that can be played. Okay, if you see these numbers, there's a serious bias, especially in the last line. You can see in the 255,000, where the first player, the X player, has nearly the double of possibilities to win than the O player. This is a biased game. If you start playing, it's likely that you win if you play randomly, not with an optimal strategy and the other player. So random versus random, the first player is gonna win twice. Okay. This is a game tree for the first player. You can see where it starts, and it is possible to see development of the game. And this is an O, the game tree for the O player if it plays optimal. So everything leads to winning or to draws. So it's a pretty boring game, I know, but we are starting with the good things. Okay, we implemented the environment, the game, which is quite easy, and we coded the following opponents: a human, the following player is a human, where the human chooses the next move; a random player, which the next move is chosen randomly; an optimal player, which uses the classic minimax alphabet pruning algorithm, so the strategy is optimal; and the Q learner, which is our reinforcement learning agent. Okay, we coded 3 Q learners, and each one of them was taught or learned from a master, which was the first one, which was the random bot. The next one was the minimax, and the last was the Q learner. So it learned against itself to play tic-tac-toe. So what is the Q learning function? So we have said that the agent has to learn an optimal policy, P star, from the partial observable word by taking actions in that word. In this case, we don't know the reward for a single action, because we only can know at the very end of the game if the agent has won or lose the game. So the very first thing is how we propagate. The only thing we know that is we have won, lose, or draw to the sequential actions to the sequence of actions we have taken during the game. That is where we use this Q function. So what is the Q learning function? We have to infer an optimal policy, which is a PI, and we have said that our Q function is, we give the Q function our state, okay? That is the board we have. We give the action we want to take in that board, and it gives us how good this action is. It's not per se the reward, but it is a calculated reward. So we want to take in consideration if our actions led to a game that we won, or we lost, or we draw. This is all the meaning of this equation. So we say that the old value we had in this value of the Q function is the learning rate, that is how much are we gonna vary it during the time, plus the reward that we have calculated previously in the game, if we win or if we lose, 1, 0, -1, plus the discount factor, that is how much matters the future actions during the time, and the estimate of the future value, which we have in the Q value, because we're back propagating from the very end of the game. That is, if we have won a game, we have a 1, and we propagate through our set of actions in the Q function backwards to the first move we did. So we have a trace where every action is rewarded in this kind of way. So if we won, every action is going to be rewarded positively. The first one is going to be a +1, okay, it's very nice, but the previously one will be a little less based on the discount factor. So this is what I say: on a game trace, I propagate true reward, win or lose, from the last movement to the first, affecting the previous stored values of the Q function. So we have the trace of the game we have played, we have the final result, which is our true reward, and we propagate this value backwards in order to fill this Q function. Okay, the way of implementing the Q function in this case is very easy, because we can have a table where we have in the rows the actions. We are in this the states, the boards we have, and per board we can have the actions we have taken, and we can see how bad or good are them. I'm gonna say that if we have played one game and we have lost, we could have a potentially bad action, but it doesn't mean that this action is per se bad, because it can be the first movement. So maybe we have not played well, or maybe our strategy wasn't good enough, but that doesn't mean we don't have to choose that action in the next games. That is what exploring versus exploiting rate was what I was talking about at the first time. So if we explore a lot, we have a high learning rate, and if we explode a lot, we have a low learning rate. So the first thing is explore a lot at the beginning, if we can pay the price, and at the very end, go reducing the ratio, so we have to start, we start to have earnings. That is when someone starts to play Go or chess, or you learn to skate, or these kind of things. It's like, okay, be prepared to fail 100 times, be prepared to lose your first 100 games before you start to do something good in this environment. So these are our experiments. We take our agents and we play a lot. So this is our agents. You can see the reinforcement learning agents. The first one was trained with random, the second with minimax, which is optimal, and the third one was taught against itself. In order to be more balanced and have a measure for comparison, we have the agents to play only for 60 seconds. So what we're doing is to equilibrate the computer power they are allowed to take in order to learn. So these are the games that play the random player. The first one, 120,000. The second one, only 300, because it's computationally expensive. And the Q-learner, okay, something between. So we can say the Minimax played a few games because it's computationally very expensive to have the optimal strategy. So our agent could not learn a lot. Okay, and as player one, the random and the Q-learner draw everything, and as player two is more or less the same. So as player one, as player two. So we want to know which agent is better. So we face them all to play against them: random versus minimax, random versus Q-learner, and we have this matrix. Okay, it seems that the minimax does not know how to win, and the problem is that it could not play a lot of games to learn. Okay, the problem with reinforcement learning is to explore all the possible states in the environment. The more you know, the more have you explored, the more you're gonna, the better you're gonna perform. So if you have only played 300 games, you cannot face a machine that has played over 100,000. So it's very interesting also the symmetry in the matrix, more or less, because I told you at the beginning of the presentation that the first player was statistically more likely to win the games if it plays randomly. And it is possible to see so in the reinformer learning, in the Q-learner versus the minimax, and so on. Okay. So we have limited it by the time. Now we're gonna limit it by the games it's gonna play. Okay. So we're gonna teach its agent to play with 2,000 games. So the training time for the random player, it took only 2 seconds. For the minimax player, 800 seconds, and the Q-learner, 3 seconds nearly. So we have these results from the training. They cannot win, or they don't know how to win. They know how to draw. If we look at here, we know that the minimax as player one has learned to make the most draws. Okay. So very bad performance on the minimax, a lot of time to train, and as player one, okay, it's learned to draw. And if we face them, we're gonna see strange things. Our Q-learner versus random can win. Against the minimax, can win, and against itself as player two, can win. And the minimax, it's very curious because it's if you think it, if you learn with a coach that don't let you win, you are not gonna explore that part of the tree. If you have never won in a game, you don't know how to win in a game, because you cannot explore this part of the game tree. So it's pretty amazing. It can win a random player, but against a Q-learner, it's not a threat. Okay, we're talking only about 2,000 games, which is a little bit only. And that's all that we can say. We can say the Q-learning strategy for training is superior results and requires fewer resources than the optimal coach. The agent with the minimax coach will never learn how to win because he can explore that part of the game tree. So if you are trying to teach some agent, you have to explore all the possible combinations of the game. This is about learning efficiency, which is a problem in some kind of casuistics. Because you want it to be efficient, and if you train with the minimax, with an optimal policy, if your opponent never loses, you're gonna know how to draw at best, but you are not never gonna learn how to win. Okay, so our conclusion here on learning efficiency. Okay, we explore the game probabilistically. That means the balance between exploration and exploitation. So you say, okay, I have my Q table, my Q learning function. How do I choose my next action? Should I choose the best one? No, that will be exploitation, 100% exploitation. Should I choose randomly? Yes, but how randomly? If not all the values of the actions that you can take are equally, you should sample from a probabilistic distribution. Let's say you have only 2 actions, and one is the value is 2, and the third one, the value is 1. So you can sample for that, and you will have a 66% likely to have the first action, which is 2, and a 33% of taking the second action. Okay, that's why I say we talk about the probability density function for each of the actions. Bad moves will have a lower probability of being chosen, but never 0. That means if you have a move with a 0 probability, it's never gonna be chosen. You are gonna lose that part of the game tree. You have to be pretty sure to put a 0 in a probabilistic problem. Okay, learning on optimal policies. The agent, the minimax agent, will never explore the winning positions. That's a futile game because the coach we have used to learn, to teach it, will never allow the agent to explore that part of the game. So the agent wins by chance, and it only learns at best how not to lose. Okay, I've called this auto-double learning because you can infer that policies for a player are different if the player is player 1 or player 2. The states are never gonna be mixed, and it's a very interesting property in this kind of problems. We have 2 policies for a player if he plays as player 1 or player 2. If we're facing a problem where there is another a multi-game player game, for each player we add, it could be modeled as a separate problem, because it's not, for example, if you know the game, the Catan is not the same playing against 2 or against 3 opponents. Okay, and that's what I call the auto-double learning, that when I face the Q-learner against itself, it can fill in its policy as player 1 and as player 2, so I'm having this kind of benefit. And mixed policies, and an agent is playing as player 1 is completely different as player 2. The game states are enjoyed, they are different policies, but we can store them in a single, in the same Q function. Okay, and I think we are on time. If there are any questions or so, because the next thing I had was the inverse reinforcement learning, and I think we're gonna not have enough time. In a few words, inverse reinforcement learning is we start from a policy, from an optimal policy, and we can convert the policy, the Q function, to a linear programming problem. So we can infer, or we can see which states are the best ones. it is very good because we can, for example, from a human perspective, we can take the action or the traces from a human agent. We can model a policy. For example, in stock trading, we could take the policy that Warren Buffett took along all the time, and we can fill in a policy, and then we can apply inverse reinforcement learning to see what states are optimal for him, or how he gives the reward function. It's a way to infer the reward function. At the very end, we applied inverse reinforcement learning, and the results were the boards, as you can see, that or the states that the player thought it was the best for it. So they are winning states or double winning states, like this one where no matter what O plays, player one with the X is gonna win. So it's very interesting to see what states are good. We generated an agent from this kind of solution, in which the agent what did was if the next possible move is in it's a good state that we have taken it from our inverse reinforcement learning process, we take that move. And if it is not in the good moves, we take a random move. And it is we tested it, and it was a pretty good player, because at worst it enrolls all the games. And I think I've made all my time. Sorry for being so quick with this. Inverse reinforcement learning gives us an idea what the agent considers good, because once we have the optimal policy, we can model it backwards, so we can see what a good state is. That is something we didn't know at the first, so it's the best thing we have into intuition or towards steps into interpretability. And it is possible to use the inverse reinforcement learning as heuristics. For example, when you have a game like chess, where you have a lot of possible states, you can apply this technique to see and to have an heuristic of how good a board or a state of the board in some moment is. So it's quite interesting. Problems, there could be infinite spades, so you have to do some kind of strange thing, but you can use sample trajectories from a non-expert state, from starting from a non-expert state. That is the cost of starting. I mean, we are generating a self-driving car, an autonomous car, and we don't want to start from scratch because we can crash it or run over a person. So we could teach it with inverse reinforcement learning to learn how or what states are very dangerous or which ones are good. So we don't start from scratch in our problems. The problem is that the behavioral cloning techniques don't generalize well, and those things. You don't want, when you're facing some high-risk problem, you don't want to start from scratch, because the lose at the first one could undo the agent and have no more exploration. So better be an expert. So I think it's time for questions. If someone has one or want to ask me something. Thanks for your time. I hope you have learned and enjoyed this. I have some resources, and if you want to contact me, please feel free through the LinkedIn links or through my email or wherever you can. See?
Bueno, cuando me digáis. Yeah. Okay. Hi, thank you for organizing and inviting me. I know it's especially challenging because in online and maybe there's a lot of people in their homes. I'm Luis Ramon and I will present Pagantis, Machine Learning in a FinTech. Let me briefly explain a little bit the title. So first of all, what's a FinTech? So it's a popular term for technological companies that provide financial services. It includes anything from mobile payment apps, bank aggregators, online credit cards, currency exchange, etc. So basically it's tech companies, financial services, you mix the words in the other way around and you get FinTech. An important difference between traditional financial companies and FinTechs is that traditional ones offer their customers a wide range of products. So from bank account, credit cards, mortgages, retirement plans, almost any product, you name it, and they will offer you. In contrast, FinTechs usually specialize on one product or a few of them, try to be very good at them, and then scale it to other geographies and ideally across the world. So what is Pagantis? Pagantis is my employer and it's a FinTech. We have offices in Madrid, Barcelona, and also a small office in Italy and Paris. The financial product that we offer is a consumer lending product, and later I will show how it works. And then machine learning is the technology that we use to automate and optimize many of our processes. It's an important part of our product, and it's key to the value proposition. So my presentation is going to focus on how and when a FinTech uses machine learning to improve the product that we offer. And finally, I'm Luis Ramon. I'm the Credit Risk Officer since January. And as Credit Risk Officer, it's a role that you mainly find in financial and FinTech companies. So when you handle money and you handle payments, you have some risk associated with this processing. And our main job is to protect the company's financial interests in order that we don't lose money. I report directly to the CEO and I lead the data science and data engineering teams. So if it was not in a FinTech, I would probably be called head of data science or something like that. And one important thing that I have to share with you is that the message that I include in the second slide is the Afterpay co-founder announcement in LinkedIn. And it basically says that Afterpay is going to acquire Pagantis, that we offer BNPL, that's buy now, pay later services, to merchants and consumers across Spain, France, and Italy. And he says that we have a super talented team, which I'm proud that he shares that, and that he's super happy to expand Afterpay's operation in Europe. Afterpay, it's not widely known, but it's a successful Australian FinTech that also operates in Australia, New Zealand, US, Canada, and UK. Afterpay is listed in the Australian stock market, and it's valued around 10,000 million euros. So it's not a small thing. I'm going to block the phone, sorry. So Pagantis, so the message is from 3 weeks ago, so it's pretty new. And Pagantis is a regulated entity from the Bank of Spain. So the acquisition will be completed once the Bank of Spain approves it. This can take up to 2 months. So until then, we are kind of acquired, but not yet. So the announcement was done 3 weeks ago, but we have been working for months. So I can share that it was an incredible experience to be involved in this acquisition process. And the due diligence started during the pandemic, which was pretty hard. And everything was done online with all employees from both sides working from home. People from UK, Sydney, San Francisco, Barcelona, Madrid were all involved. So it was pretty challenging. In the slides, if you realize there are 2 logos, one is Afterpay and then the other one is ClearPay. And this is basically because in Europe, there already exists a company called Afterpay and they can't be called Afterpay in Europe because the name was already taken. So in Europe, it's called ClearPay. In UK, they operate as ClearPay and Pagantis will operate as ClearPay and rebranded as ClearPay Europe. So Right now, we're in an integration process with their teams and the way that they work. So what I shared today is what we have been doing as Pagantis, but many things will change once we will be ClearPay Europe. Okay, so what's Pagantis' product? So our product is a consumer lending financial product, and it's buy now, pay later product. So basically, it allows, it's included in e-commerce's checkouts and allows customers to buy a product today and pay it in several months. So how it works, imagine that you are buying a sport shoes, you're buying a sport shoes in the Depot Village, you select them in the web page, and when you are going to pay for them, you have 3 different payment methods, regular credit cards, PayPal, and then you have Pagantis. You select Pagantis, and then in your browser, it opens your form that you have to include some information that we require to you, like DNI, address, phone, email. Some of them are legal requirements, others are for contacting you. And you select in how many months you want to pay back the money. Then you provide a valid payment method to pay us back, like PayPal or credit card, and then we analyze in real time the transaction, and if it's okay, it's accepted. So you, the customer, get the product, the sport shoes, and we pay the e-commerce the full amount the next day of the purchase. So all this process that I have shared here, it's taken in less than 20 seconds, and it's completely online, automated, paperless, and almost immediate. So in these 20 seconds, we have to do several things. One of them is anti-money laundering and counter-terrorist financing checks. So we have to make sure that we only accept people and transactions that are allowed to do this. It's a legal requirement that we have, and we need to do these checks. And if you do not do it properly, you could be heavily fined, or even you could lose your license to operate. Then there are other checks that we have to do, and those are fraud checks. So we have to make sure that the identity was not stolen or the car was not stolen. As it's a complete online process, it is very attractive for fraudsters to get some products and use other people's information, which you can claim back the money. And the last thing that we have to do is some credit checks. So we have to make sure that the customer doing the purchase will be able to pay back the money. So we analyze the creditworthiness of the client. So how are we doing all of this in just a few seconds? So first of all, we have a strong technological platform, and we use a lot machine learning. And what's machine learning? So when I took this image from this blog, the Machine Learning Mastery blog, and one quote that it's there and he shares is that if programming is automation, then machine learning is automation, the process of automation. So in traditional programming, you have some data and some program that it's, and some program that is executed in a computer to get some output. The program has to be defined by some business logic, prior knowledge, or analytical experience. Machine learning works differently. So you have to provide data and output, and a computer runs a machine learning algorithm to get a program. And then this program can be used in traditional programming to get new data, be executed, and get an output. Then that you can take a decision there. So in machine learning, nobody defines how the exact program is. So it's the data and its patterns which defines the exact program. So you have more or less the idea that's going to look like, but not the exact program. And one important rule in machine learning is that the more data you have and the more variety of cases you have, the better that the final program is going to be. So there are several machine learning paradigms. So, and it's divided in supervised learning, unsupervised learning, and reinforcement learning. In supervised learning, you have the data that it's labeled, and you have to predict an outcome. So, for example, in Pagantis, a fraudulent transaction. So we have which transactions have been fraudulent in the 4 years that we've been operating, and then we have the information from the transaction, and we can try to predict if the next transaction is going to be fraudulent or not. In supervised learning, this one, you don't have labels, and you try to find some hidden structure in the data that allows you to get some ideas or some insights. A classical example is to do a customer segmentation, that you want to understand your customers to apply different marketing strategies or adapt the product to each customer segmentation. And the final one, it's reinforcement learning. The idea is that you or the machine is learning a decision process. There's no labels, but there's some kind of reward depending on some actions. Some examples are computers that learn to play video games or chess. So there's a few examples like a machine that learns to play Mario Bros, or a Netflix series called AlphaGo, where you can learn to play Go better than the best player in the world. In Pagantis, almost all our work is related with supervised learning. We have one unsupervised model that I will explain later, and one time we thought to use reinforcement learning, but it was just an idea. One thing that I like about supervised models is that you know if you're doing the right thing. So you have the labels that inform you if you're doing it correctly. So if you can have different models, you can identify which one is the best performing one. In the contrary, and this is why we don't use it that much, is in supervised models, you can have many models, different models, and you do not know which one is the best. You have to interpret the results and see if you get some insights. So as we are working basically in supervised learning, there are different types of problems, and it's divided in classification and regression. So in classification is when you have a discrete number of labels. So for example, cat versus dog, or a fraudulent transaction versus a legit transaction. And in classification, you can have two different possible outcomes. One is label prediction. So in the cat versus dog example, you will get the output will be cat or it will be dog. But in probability estimation, what you get is the probability that an image is a cat or an image is a dog. So for example, if you upload an image of a cat, you run the model and it will tell you it's a 95%, a 0.95 probability of being a cat. And then you can take some decisions based on that. In regressions, what you have is a continuous label. So you try to predict a continuous label. For example, the price of a house based on the house size, the location, the number of rooms, floor, etc. In Pagantis, what we usually have is classification problems. And how we divide in Pagantis our machine learning project. So what I like is to divide them in the following steps. And I try to have it defined as soon as possible in order to make the project a success. Because in many projects, and especially in machine learning, you can start to check the data, try a lot of models, try a lot of things, but then you could be easily lost. So if you have a clear definition of the business problem, data science problem, and target, well, I'm going to explain this. So if you have defined everything, the project it's going to be a success with higher chance. So first of all, you need to have a clear understanding of the business problem. And this is what the company wants to solve or how it wants to improve. So if you have a clear understanding of this problem, it can help you promote your project through the company. But the business problem, it has to be translated to a data science problem. So not all business problems should be solved with machine learning. And when you define it, how you're going to solve it with machine learning or with a data science problem, and it will be clearer if machine learning could be useful or not. So maybe you start thinking about that and say, okay, this is not a problem for machine learning. The target is the variable that has to be predicted. It's always when you have supervised paradigm. And sometimes it's pretty evident what's going to be the target. For example, if you want to forecast the sales, then it's super easy because it's the sales. But in Pagantics, there are different definitions could be used for the target, and this could lead to different results. So it's important to think carefully this part. Later, I will show some examples. Then the data is one of the most important things in machine learning. So if you don't have data, there's no machine learning. And depending on the amount of data you have, you will be able to use one algorithm or another. This could also reduce the options that you have to check or to try. The evaluation is the methodology that you will follow to make sure that the results you expect when you train the model will be obtained when the model is used with unseen data. So in this area, you find some words that like train, test, evaluation set, some metrics, sampling, cross-validation strategies. So as this is an introductory talk, I'm not going to dig deeper in this, but if you do not know any of this and want to do machine learning properly, you have to check it. There's plenty of information and books, and it's a very important part. What you don't find easily in books is that if you are able to relate machine learning metrics with business metrics, it's very helpful and powerful. So it allows to contextualize the results across the company. For example, if I tell my boss that I have improved 10 points of the area under the hop curve, he will say, okay, but now what? So is it good enough? Should we put it in production? Instead, if I'm able to tell him that the new model will reduce the credit loss by 30,000 euros per month, now I'm talking his language and he knows how to prioritize it. So maybe he thinks, okay, no, first we have to open to Portugal, or maybe he wants to reduce the cost that we're currently having. So in Pagantis, we try to do that a lot, and it's one of the things that I'm most proud of it. Then we have the model. And the models are basically the algorithms, the machine learning algorithms that you are going to use. So there are many of them, and all of them has different properties. So depending on the problem, you can reduce the space of the models you want to try. Some important properties for me are the interpretability. So if the model is interpretable or not, or how hard it is, the amount of data that they require, the type of data that you have, how robust is the model, and how hard is to put it in production. So in this part, if you have time, so I would recommend to do a few iterations with each model or each algorithm and see the performance and keep with the ones that have the best characteristics and tune it more time. So try more iterations with the few ones that are working fine. And the last point is the future selection and transformation. So this step is to reduce the data that it's not useful or transform it in order to make it more powerful. So some models require that you do this process, and most of them usually benefits from doing this part. So, and also when you put the model in production, I will explain it a little bit later, it's very useful to have just the data that you want in order to just check the data that you're going to use. So finally, which are the machine learning models that we use in Pagantis? So we have risk models to detect if the customer is going to pay back their loan, one for new users and one for existing users. We have different models because the performance and the information that we have with existing users is richer. Then we have a fraud model that allows us to detect if a transaction is likely to be a fraudulent one. Then we have a fraud merchant model that it allows to detect if a merchant is likely to be a fraudulent one or not. And then an ID scanning model that when we upload in the form, when the customer uploads the DNI or the ID document in Italy, we are able to tell if it's okay or not. I'm going to explain some of them, the ones that I think that are more interesting for this talk. So and I'm going to use the same structure that I shared with you before. So the business problem, so we want to distinguish clients who will pay their loans or not. So when we translate it to a data science problem, what we want to assign is to each transaction a probability of default and reject those transactions which have a high probability of default. So the model is a supervised learning, it's a classification problem, and what you get is the probability estimation. And here is when you don't have a clear target. So what does it mean or how we define a client that doesn't pay a loan? So you can get that he didn't pay any of the installments, so the monthly installments, or he had paid one installment late, the first one late, 30, but also late, it could be 30 days, 15 days, 90 days. So depending on how you define this, it's going to influence the results you're going to get. The merchant fraud model, so it's a model that we built because we had last year some cases of merchants that they were fraudulent. So they were not sending the goods that they were trying to sell, or even they were faking accounts. And so my boss requested us to find solutions. The business problem was that we want to identify and get rid of these fraudulent merchants. The way that we tackled it was to do an unsupervised learning, because we didn't have much data. So we have just 2,000 merchants, around 2,000 merchants, and just a few of them were fraudulent. So we wanted to do an unsupervised learning and try to find if there was some structure or not. The data science problem was to group merchants by similar transaction behavior and list the ones that were anomalous, so that didn't belong to any other or were not similar to any other merchant. And in this case, as it's unsupervised, there's no target. And then the ID scanning model. So in Italy, for every transaction that we do, it's required from a legal point of view to ask for the ID document. So to comply with Italian legal requirements, we have an external provider, but this provider is expensive and it takes on average a lot of seconds. So we wanted to look for an option that was cheaper and faster. And translating this to a data science problem is to assign to each uploaded image an authenticity probability and reject those images that have low quality, blurry, or non-ID document images, or use the provider and wait, oops, sorry. No, sorry. Where was I? Yes, ID scanning model. It's a classification problem, but here we also have, yes. Are I sharing? No. Okay, but I'm sharing my screen. Hi. I am sharing the screen. Okay, thank you. So here, once again, we have a target that it's not super clear. So because what's a valid ID document? It's not written down in the legal requirements how you have to validate it. So, and there are also two steps that make it more complex. So for one side, we have to check if it's a valid ID document, and then we have to check the information that the customer provided in our form. It's the same information that the ID document information. So if I upload my brother's ID document, it shouldn't be a valid ID document. Okay. And the last part is the machine learning in production. So to me, this is one of the most important part of the things that we do. So when you do machine learning model, what you get some predictions, but in the real world, what you want is decisions. So you want to get a probability of not paying, and then you're going to decide what you're going to do or what you're not going to do. There's also, when you have models in production, you have two different categories, online versus offline. Online is when you do it on real time, and offline is when you can do it once a day or once a week. And this is super critical to have it clear, because online requires a lot of infrastructure and a different way to approach this project than offline. So probably for an offline project, the same that you have the information or data and infrastructure that you have used, you can use it the same one probably, but in online, you will have to do it differently. In Pagantis, so all the machine learning training models, we do it with R and some Python, but then if it goes for online models, our backend is in Java. So some of the models are built in-house. So there are some easy models like linear regression, naive Bayes, that you can build it and you don't need to do complex things. But then we also have some H2O Mojo Java files. So H2O, it's a company that have some software and some of the software is free to use and some of the software you have to pay for that. And we have used it for training more complex models like random forest, gradient boosting, etc. And then you can export a Java class that can be included in your backend. And now we're exploring some Amazon Web Services services. So we're doing a proof of concept with SageMaker, SAM, or Lambda. This is a current trend in the sector to have models in platforms in order that you don't have to worry about the infrastructure or to scale the server, etc. And so, this is the last slide. So, the Paganti's experience in putting models in production. So if you can do an A/B testing comparing your previous model or your previous situation with you have the model, I always recommend it because you will be sure that you have not messed it up, or if there's a change in the data or the merchants or the portfolio that you have, you can compare the results and you can go to your boss and your teams and say, okay, all the work we have been doing represents this benefit for the company. Then the other thing, especially if you're using or you have to translate from what data scientists do to data engineers or the developers put the model in production, you have to double check that the model features that you have created, they are created the same ones. So this is a big issue that you can have, like for example, you include the amount of a transaction and you have used cents and they have used euros or they have used dollars, then the model is going to behave weirdly. And with this, we have a lot of examples that you have to check it and double check it. And the last thing that I also like, and this is also from a link that is included in the presentation, is that usually what the first models, you get more benefit than the last ones. So, and this is a plot that I like a lot. So when you have nothing, the performance is the one that you have. When you include a good heuristic, it improves. The first model, you improve a lot, but then the following ones, it's harder and harder. So in Pagantis, we have done a lot of iterations in these models, and the first ones were very good in the improvement, but then it's get harder and harder when you try to include more data. So I think that I'm on time, and I have some minutes for questions. So I hope that everything was clear and you have enjoyed. And well, I don't know how to see the question, so if you can read it or. No questions? Okay, perfect. Well, thank you very much and have a nice meeting. Gracias, chao.
Hawking, que en una entrevista que le realizaron el 23 de enero del 2000 ya dijo que este iba a ser el siglo de la complejidad. Como seres humanos queremos modelar y queremos representar los sistemas complejos, simplemente para ser capaces de controlarlos. ¿Cómo podemos modelar un sistema complejo? No podemos utilizar técnicas tradicionales de modelado, por eso tenemos que utilizar herramientas avanzadas de ciencia de datos, herramientas avanzadas de inteligencia artificial y de ciencia de redes. En concreto, se usa una técnica denominada ABMs, modelados basados en agentes. Son modelos de simulación discretos en los que tenemos una serie de agentes simulados con unas reglas muy básicas. Por ejemplo, en nuestro caso serán consumidores, como tenéis aquí indicado, y lo que se modela es el comportamiento individual de cada agente con unas reglas muy simples, muy básicas, en función de unas variables y unas acciones qué salida provocan, y eso genera el sistema complejo completo y nos permite modelarlo, por ejemplo, en nuestro caso, el mercado. En nuestro caso, ¿qué tenemos? Tenemos un modelo bottom-up. No es el modelo clásico que es top-down, como una ecuación econométrica, por ejemplo, o cualquier modelo en que tú tienes una ecuación que te describe el comportamiento de todo el sistema. Al contrario, este modelado es más natural, modelamos los elementos individuales y modelamos sus interacciones. Y eso nos permite, por ejemplo, trabajar con acciones como el boca-oreja, que es muy habitual en marketing, o procesos de marketing viral como la transmisión de cualquier tweet o cualquier campaña a través de Internet que se hace viral en un momento determinado. Aquí tenéis un poquito más de desarrollo de esta tecnología. Como decíamos, cada agente es un elemento individual autónomo, entonces cada uno tenemos modelados sus propiedades y las acciones que pueden tomar, simulando el individuo real, siempre que nuestro modelo basado en agentes esté representando a seres humanos, en nuestro caso un consumidor. Tenemos una población de agentes virtuales formada por miles de agentes y cada uno de ellos es un patrón de consumidor concreto, y la interacción entre todos ellos, esa relación a través de una red social humana, es la que provoca el modelado del sistema complejo. No estamos hablando de redes sociales online, tipo Facebook, tipo Twitter o cualquier otro medio social, sino estamos hablando, esas se pueden modelar, por supuesto, como mecanismo de comunicación, pero también estamos hablando de nuestras conversaciones de seres humanos que nos sentamos a tomar un café y hablamos sobre un producto concreto o mandamos un WhatsApp a otra persona diciéndole nuestro parecido. Entonces, toda la conexión posible entre esos agentes y el entorno. Por ejemplo, las propias marcas a través de los touchpoints, a través de la publicidad. Como decíamos, es un modelo bottom-up, no tenemos una única fórmula, los agentes van trabajando en paralelo, van interactuando y al final se agregan las acciones de esos agentes, como ocurre en un mercado real, para saber, por ejemplo, cuántas unidades se han vendido, contamos cuántos agentes han comprado esa marca y cuántas unidades han comprado cada uno de ellos, o para el boca a oreja, por ejemplo, el word of mouth, para contar cuántos de esos agentes han hablado sobre nuestra marca, de qué forma lo han hecho y durante cada cuánto tiempo. Entonces es muy habitual que aquí se produzcan comportamientos emergentes, comportamientos inesperados a raíz de esas interacciones. El ejemplo típico, y me lo he guardado para aquí, en la esquina inferior derecha tenéis una representación del tráfico. Los que viváis en Granada ya sabéis lo habitual es que tengamos atascos en la autovía de Granada, y en algunas ocasiones esos atascos de la circunvalación se deben a que ha habido un accidente, pero en otras es simplemente que un coche ha tenido una avería y se ha parado en el lado derecho o en el lado izquierdo. Y en ese momento los conductores, que son los agentes individuales de nuestro sistema, van conduciendo, frenan un poquito y miran, y eso que provoca que la interacción con el siguiente haga que frene también, y frene también, y frene también, y nos encontramos con el efecto mirón, que es un comportamiento emergente que te provoca un atasco de 7 u 8 kilómetros por una acción individual y no por un comportamiento reglado que se le ha dicho a esa persona que se pare y por la propagación de esa acción. Una acción viral, como estábamos diciendo. Centrándonos ya en este marco de trabajo en marketing, pues en el año 2015, empezamos a trabajar con una empresa, que ahora la nombraré, y empezamos a tratar de realizar modelos aplicados de marketing para la ayuda en la toma de decisiones. Entonces tenemos claro que el marketing es un sistema complejo. Aquí tenemos algunas de las características. Tenemos una fragmentación continua en los medios publicitarios, disponemos de mucha información descentralizada en las empresas que muchas veces no se utiliza para la toma de decisión interna porque se tienen en distintos departamentos. Los consumidores hoy en día tienen una nueva dinámica, un nuevo comportamiento muy relacionado, eso sí, con los medios sociales, las compras por Internet, el posteo por Internet, y no somos capaces, o hasta hace poco no lo éramos, de modelar los procesos complejos que sucedían en el entorno del marketing como el boca a oreja o el marketing viral. Son procesos que no es posible modelar con técnicas clásicas tipo modelos económicos. La figura que hay aquí a mitad de transparencia representa un poco todo ese entorno con todas las características que tenemos, los informes de venta, los medios online y offline, la parte mobile y social, los consumidores, los productos y los competidores y los distintos modelos que se utilizan parcialmente para cada una de esas técnicas, de esas tareas. ¿Nuestro objetivo qué era? Utilizando estas técnicas de IA que hablábamos, los sistemas basados en agentes, los ABMs y las redes sociales, tener un único tablero de mandos que integrara toda la información y que permitiera definir y validar estrategias al modelador, al director de marca. De aquí tenéis la representación del proceso, se hace un modelo, se simulan escenarios y una vez que confiamos en el modelo podemos hacer escenarios what if de qué pasaría si yo hiciera algo y el modelo interactúa con las decisiones que hemos tomado y nos permite optimizar nuestras decisiones. Ese era nuestro objetivo. Como os decía, trabajamos con una empresa Road Brand Consulting, y en este caso terminó generando la herramienta CEO Virtual Markets o CEO Analytics, que integra toda esa información como comentábamos. No solo información de nuestra empresa, sino de los consumidores, con un gran número de agentes y con toda la información que se disponga de la propia empresa, información externa adicional e información de la competencia. ¿Qué herramientas tenemos? Pues ya las hemos ido comentando. Tenemos modelos basados en agentes para generar el mercado con ese enfoque bottom-up, de abajo arriba. Tenemos las herramientas de ciencia de redes y de complejidad que nos permiten reproducir las interacciones en esa red social de consumidores. Utilizamos técnicas de Machine Learning, de inteligencia artificial, para calibrar los parámetros del modelo y para proponerle estrategias de optimización al director de marketing que puedan mejorar sus KPI, dependiendo del KPI, del KPI que haya propuesto. Y luego técnicas de economía del comportamiento, donde se modela los consumidores virtuales que representen las acciones que verdaderamente suelen hacer los consumidores humanos. Entonces, por ejemplo, se tienen teorías del premio Nobel Herbert Simon para decidir cómo compramos los consumidores humanos. Todo esto, como decíamos, desarrollado con esta empresa, con reputados expertos de marketing y, como veréis ahora en breve, validado por empresas nacionales y multinacionales. Ahora hablaremos de los distintos clientes y pondré un caso de estudio de un cliente concreto con el que hemos trabajado. ¿Cómo es el modelo? Entrando un poquito más al detalle. Pues tenemos el centro del modelo, es el cliente, el consumidor virtual. Ese consumidor virtual tiene una serie de drivers de compra que representan sus necesidades y una serie de atributos. Y unos tendrán una preferencia por el precio y otros tendrán una preferencia por la calidad o por la duración del producto. Igualmente hay interacciones entre esos agentes, tienen conversaciones sobre, en función de su experiencia de uso y de la imagen de marca que tengan, conversaciones sobre esos productos que influencian a otros consumidores. El modelo, como decimos, refleja tanto las reglas individuales de un agente como el proceso de propagación en redes, en esas redes sociales de comunicaciones entre los agentes, y te permite representar las interacciones sociales como el boca a oreja. Los agentes deciden qué producto comprar dentro de los que conocen, no pueden comprar un producto que no conocen, así que se modela el concepto de reconocimiento de marca, y el reconocimiento de la marca puede cambiar porque otro agente consumidor te informe de un producto que ha comprado y tú no conocías, o a través de campañas publicitarias a través de un touchpoint. Entonces, las empresas tienen esos touchpoints, que son los puntos de choque con el cliente, y son canales de comunicación en el que permiten informarle y tratan de sesgarlo para que compre su producto. Y finalmente, como decimos, hay una red social subyacente con una densidad concreta que dependerá del producto. Lógicamente, se habla más, por ejemplo, del mercado de móviles que del mercado del papel higiénico. Es el ejemplo estándar, o del mercado de los cepillos de dientes. Y esa densidad de la red de conversaciones no la sabes y tratas de estimarla a través de un proceso de calibración con datos históricos. Y los agentes serán iguales que los seres humanos, tendrán comportamientos distintos, habrán distintos segmentos de clientes. Somos capaces de modelar la situación real de la mejor forma posible. El flujo de trabajo completo queda resumido aquí. Empezamos delimitando el mercado. ¿Cuántos agentes, cuántos segmentos, cuántos productos, cuántas empresas implicadas? ¿A cuántos consumidores reales representa cada agente? Si estamos en el mercado de Madrid con 5,5 millones de consumidores y utilizamos 10.000 agentes, pues cada agente es como si fuera una encuesta del CIS, representa a un porcentaje concreto de ese ratio de consumidores. Luego construimos el modelo con toda la información disponible, se cubren todos los parámetros concretos de comportamiento de los agentes, ahora veremos cómo. Tratamos de definir el comportamiento de las marcas, las campañas que ha aplicado cada empresa, todo, y aquellos parámetros que no se conozcan se dejan después para la calibración. se valida ese mercado y se calibra con datos históricos hasta que estamos confiados de que tiene un porcentaje de ajuste correcto con datos históricos, representamos ese mercado y ya empezamos a explotar, haciendo escenario what if, de forma que cambio una acción de marketing, cambio una inversión, cambio la creatividad de la campaña, tampoco puedo hacer, y simulo a ver qué ocurriría. Y por último, podemos utilizar una optimización de estrategias para decidir cuál sería la estrategia más recomendable para mí. Entonces aquí globalmente tenéis un resumen de todo lo que hemos hablado. Tenemos los comportamientos de los agentes, su estacionalidad del consumo, la frecuencia de compra, unos drivers, un conocimiento, unas percepciones, la red que interconecta a los agentes y los touchpoints donde tenemos modelada la campaña, el marketing mix, el media mix, dónde se invierte, en qué momento y con qué creatividad, a qué alcance llega. Tenemos el share de una determinada cadena de televisión sobre una determinada población, un determinado segmento, y el modelado de las decisiones de compra de esos agentes en función de su racionalidad, de su emocionalidad. Son unas heurísticas sencillas que en función de sus propósitos, de los precios, de las características de los productos y de los productos que conocen, toman la decisión de qué comprar. Entonces, todo esto es lo que se mete junto en el caldo de cultivo y vamos a ver muy rápidamente las decisiones que vamos tomando para modelar el mercado. Primero tenemos que inicializar los consumidores. Tendremos los distintos segmentos, tenemos el tamaño de un segmento, si tenemos 10.000, 20.000, 30.000, 50.000 agentes, lógicamente cuanto más mejor, porque tenemos una granularidad. Para cada uno de ellos tendremos que determinar a qué segmento pertenece. Pueden ser heavy consumer, pueden ser consumidores de otra marca, dependerá del estudio que quiera hacer la empresa, y en función de eso añadimos el tamaño del segmento, cuánto suele comprar el segmento, inicializamos los drivers que van secados por el segmento concreto. Si eres un heavy consumer de Coca-Cola, vas a consumir ese producto de forma relativamente compulsiva y vas a comprar mucho. Entonces inicializamos a partir de un punto de partida y con una distribución normal, una cierta diversidad dentro del segmento y exactamente igual los distintos comportamientos de la gente en su consumo, en su cantidad de consumo, pero también en la probabilidad de hablar, que sean personas más propensas a hablar bien de su producto, a hablar mal de su producto, o de postear en Internet una opinión sobre el producto concreto. Una vez que tenemos modelados los consumidores, tenemos que modelar también las marcas. Antes de inicializar la simulación, tenemos que saber la penetración inicial de cada marca, cuántos agentes han ido comprando esa marca en el pasado, la experiencia del consumidor, si están contentos o no están contentos con ella. Todo esto se saca de los estudios de marca que realiza la empresa, y la distribución del producto o servicio, si están disponibles en un canal de distribución para compra automática o hay que solicitarlos con tiempo, o puede haber agentes que quieran comprarlos pero debido a la distribución no los tienen disponibles. Entonces, gráficamente tenemos esto, una población de agentes pertenecientes a distintos segmentos representados por el color de las bolitas, una serie de marcas que tienen una penetración inicial en el mercado y además, como decíamos antes, hemos incorporado la información específica de cada uno de esos agentes. Aquí tenemos dos agentes que pertenecen a dos segmentos distintos, tienen 3 drivers de compra, que podrían ser, pues por ejemplo, en un caso de un perfume, como estamos hablando después, la calidad, el aroma y el precio, y cada uno de esos agentes tiene una predilección distinta por cada uno de ellos. Este está más secado por el tercer driver, 40%, el agente 6.744, mientras que el de abajo está más secado también por el tercer driver, pero por un 49%. Las marcas que conocen, las que sí o no las conocen del mercado, la imagen que tienen de esas marcas, todo esa es la inicialización que tenemos que hacerle al sistema, y luego sabemos que hay una red de conversaciones. Entonces, esa red se modela como una red real y se trata de definir la densidad de la mejor forma posible, que es uno de los parámetros más difíciles de estimar, porque realmente no sabemos el volumen de conversaciones que genera un producto concreto. Ya tenemos marcas, ya tenemos la red de agentes y ya tenemos el comportamiento de los agentes. Los siguientes son los touch points, punto de contacto entre la marca y el agente. Entonces, ¿ahí qué incorporamos? Incorporamos las campañas de marketing, en qué momento se hacen, sobre qué touch point, radio, televisión, internet, out of home, en cada caso, en cada mercado modelaremos el touch point concreto y consideramos tanto los pagados como los ganados. Entonces, las propiedades que tiene una marca para un agente, reconocimientos, si la conoce o no la conoce, si la conoció y la olvidó, o si no la conocía y a través de una conversación o una campaña de marketing la conoce, su idea sobre esa marca y su comportamiento, la probabilidad de hablar sobre una marca concreta, bien o mal, vendrá determinado por la acción de esas marcas. Entonces aquí jugamos a modelar tanto los touchpoints de pago, que son las campañas de marketing pagadas, como los ganados, cualquier campaña que se realice en Internet y que tenga un marketing viral y que la gente empiece a hablar de él, se modela dentro de la herramienta dando la inversión en términos de GRPs, por ejemplo, la inversión en qué momento se hizo y a quién iba dirigida, y luego hay una cierta probabilidad, en función de share, de que un agente concreto, que es un patrón, escuche la radio o vea la televisión, vea ese anuncio y entonces le influencia. Y con esto lo que generamos es una gran cantidad de información. Entonces tenemos, gracias a tener un modelo basado en agentes, tenemos un consumer journey. El viaje del consumidor a lo largo, por ejemplo, del año completo de simulación de las 52 semanas que hacemos. Y aquí este agente naranja que tenéis aquí abajo, veis que en un momento determinado fue alcanzado por un touchpoint de out of home, leyó una revista, aquí compró, luego tuvo cierta experiencia, luego habló sobre el producto. Entonces tenemos un fichero de log sobre el comportamiento completo de ese agente y podemos hacer cosas como determinar la contribución de un touchpoint a una venta. Ahora lo veremos. Tenemos el proceso de compra. Como decimos, es una regla muy simple. El agente tiene sus drivers, el agente consumidor, y tiene una serie de heurísticas. En cada momento puede aplicar una u otra. Solamente las aplicará sobre aquellas marcas sobre las que tiene reconocimiento. No va a comprar algo que no conoce. Y cada marca tendrá una probabilidad o una preferencia que dependerá de las características de la marca y de los drivers de ese consumidor, de la imagen de marca que tenga. Eso va variando y en cada momento que le toca comprar, aplicamos una heurística para decidir qué compra. Muy importante, lo que pone aquí abajo. El ABM es un modelo descriptivo, no es un modelo predictivo a priori. Entonces nosotros lo que hacemos es coger datos históricos de cuánto se ha vendido de cada marca en cada momento, y el modelo trata de replicar y de aprender esa dinámica del mercado. De tal forma que en una semana concreta, si se han vendido 500 unidades de un producto, en nuestro ABM se tienen que vender 500 unidades de un producto. Compre el agente 1, el 2 o el 3 o lo que sea. Con eso captas la dinámica del mercado y ahora ya puedes jugar con los escenarios what if para tratar de hacer predicción. Si yo tengo un 99% de ajuste histórico, yo ahora digo, vale, y en ese mercado, si yo hubiera hecho tal, ¿qué habría pasado? ¿Habría vendido menos o más? Ahí es cuando lo utilizo como herramienta predictiva. Pero al aprender el modelo lo tenemos que hacer como una herramienta descriptiva. Finalmente tenemos este gráfico. Realmente este gráfico tiene una serie de flujos por dentro. Por confidencialidad no los he puesto, pero aquí tenéis reflejado todo lo que hemos ido contando. En el centro está el agente con sus características y sus posibles acciones. Aquí en la esquina inferior izquierda tenemos la empresa con los touch points y puede generar una campaña de marketing con una determinada creatividad, con un determinado coste de inversión en el touchpoint concreto o en otro, en un tiempo concreto, y todo eso provoca un comportamiento en un flujo. Ese anuncio puede provocar que una gente que no conocía la empresa la conozca, o que una gente que pensara que tal empresa de seguros daba seguros muy caros, acaba de hacer una campaña por precio y se plantee que se acerca más a su drive. Y todo eso va provocando un flujo dinámico que va interactuando con todo el sistema. Por poner algún ejemplo, aunque no puedo poner todas las líneas de flujo, aquí tenéis un ejemplo en que una empresa hace una campaña de precio y baja durante unas determinadas semanas el precio de su producto. ¿Eso que provoca? Que en el momento que los consumidores se enteran de esa campaña, cambia su experiencia de uso del producto, su experiencia de consumo, cambia su percepción de la imagen de marca, les puede hacer hablar de esa marca, les puede hacer escribir un post en internet diciendo qué barato han puesto tal producto por lo bueno que es y les puede provocar finalmente la compra. Pues exactamente igual, si hago una campaña sobre la marca concreta y saco un anuncio, eso me puede provocar que reconozca una marca que antes no conocía porque veo el anuncio en televisión o en internet o en el cine, que cambie la imagen que yo tengo sobre esa marca, ambas me pueden llevar a comprar, igualmente me pueden llevar a hablar sobre esto. Entonces, dicho eso, solamente nos queda, ya que hemos modelado todo el sistema, ejecutarlo y calibrarlo. Finalmente, ¿yo qué quiero? Ejecutar mi modelo sobre un año y tener el valor de las ventas o el valor del número concreto de veces que se ha hablado sobre mi producto y ver si ese modelo es realista. Entonces, los KPIs no se calculan con una fórmula, como llevo diciendo desde el principio. Se calculan ejecutando el modelo de simulación discreto, por ejemplo, por semanas, por días, por meses, dependiendo de la simulación concreta del mercado con el que estamos trabajando. Habitualmente se trabaja por semanas, modelo de 50 a 100.000 agentes, se ejecuta durante 52 semanas y al final, ¿qué hago? Agregar todas las acciones individuales que han hecho los agentes para contar cuántas ventas he obtenido, para contar cuántas veces se ha hablado de cada producto, para contar cuántas veces ha sido tocado un agente por una campaña de marketing concreta. Entonces, estamos representando de una forma natural el mercado real. En el mercado real no se llega y se dice una fórmula, hemos vendido 500.000 porque es 3 por X más Y. No, hemos cogido 500.000 porque ha habido 272.000 consumidores, este ha comprado 3, este ha comprado 2, este ha comprado 1 y la agregación me ha provocado esas ventas. Entonces, finalmente, una vez que ya tenemos ese mercado modelado, habrá una serie de parámetros del modelo que no somos capaces de definir con la información disponible en la empresa o por fuentes externas. Y para eso tenemos un proceso de calibración final del modelo. Ese proceso es cíclico, como tenéis aquí representado. Empezamos por decidir qué parámetros del ABM vamos a calibrar de nuestro mercado virtual. Solamente calibraremos aquellos de los que no estamos seguros. Luego, ejecutamos una técnica de inteligencia artificial, en nuestro caso un algoritmo genético, que es un algoritmo avanzado de optimización y búsqueda. Y va proponiendo valores posibles para esos parámetros dentro de unos rangos razonables. Y cada vez que tengamos un conjunto de parámetros, se simula el modelo y se ve, después de 52 semanas, qué salidas da ese modelo y se comparan contra las salidas históricas del KPI que tengamos en cada caso, que nos haya proporcionado la empresa. Entonces, el algoritmo está tratando de encontrar los parámetros más adecuados para que el modelo case totalmente con la realidad. Y se hacen con simulaciones de Monte Carlo. Dado que aquí hay una fuerte componente probabilística, un agente, yo todas las mañanas voy conduciendo y escucho una emisora de radio, porque llevo a los niños al instituto antes de venir a trabajar. Si un día los niños no tienen instituto y yo salgo más tarde, puede ser que ese día no escuche la misma de siempre y no escuche un anuncio que haya tenido en el momento determinado. Entonces, se simulan varias veces. Para cada conjunto de parámetros se simulan 15 o 20 veces el modelo, simulación de Monte Carlo, y se saca un promedio del comportamiento y unas bandas de confiabilidad. Se calcula el error final de cada uno de esos parámetros y nos quedamos con el conjunto de parámetros que menos error tenga. Y finalmente lo validamos como seres humanos. Porque puede ser que hayamos ajustado un parámetro que nos dé un error muy bajo, pero que ese parámetro no sea realista. Nadie se cree que en papel higiénico, más allá de los anuncios de Spotex, un 20% de la población esté hablando sobre papel higiénico, cuando un 20% de la población sí puede hablar sobre móviles o sobre otros mercados en los que habitualmente se habla bastante más. Entonces, lo bueno de esto es que se puede ajustar para cualquier KPI. Normalmente se trabaja con ventas. La mayoría de los proyectos que tenemos se trabajan con ventas, pero hay otras empresas que lo que les interesa es mejorar su imagen de marca o mejorar su reconocimiento. Entonces, una vez que tenemos ese modelo calibrado, como ya lo hemos dicho, y tenemos un ajuste significativo sobre los datos históricos, ya nos creemos ese modelo y ya podemos empezar a hacer escenario web. Ahí ya ejecutaríamos el modelo con nuevas acciones nuestras y si la competencia vemos que hace una acción nueva, también la podemos incorporar. Entonces, podríamos hacer cosas como incrementar un 3% de inversión en televisión en una marca o hacer una promoción de precio de un 10%, una reducción de precio durante las semanas de 12 a 18 y ver qué acción tiene, qué resultado tiene esa acción que hemos metido sobre el modelo. Termino los últimos 5 minutos con un caso de estudio para que se entienda. Es un caso de estudio real, simplificado lógicamente y con información oculta, sobre un proyecto real con una empresa de perfumes de lujo para mujer. Es un mercado muy competitivo y muy estacional. Ya se sabe que en Navidades se venden muchos perfumes y es el gran momento de la inversión en medios para este tipo de mercado. La publicidad es fundamental. Tenemos una empresa con 5 marcas propias y tenemos una serie de competidores externos. Aquí tenéis la delimitación del mercado inicial. Estamos en España y vamos a estudiar el mercado de mujeres de 25 a 64 años y el periodo modelado 2017 y 2018. 2 años. Tenemos las 5 marcas propias y 7 competidores. Los drivers de los agentes, de los consumidores, son esos 6 identificados por la empresa, donde tenemos, por ejemplo, la permanencia y la fragancia del perfume, la imagen de marca, la calidad, que haya promociones, el empaquetado, el envase. 2 segmentos, mujeres más jóvenes y mujeres más maduras dentro del mercado, y una serie de touch points de posibles puntos de contacto, de posibles puntos de inversión en marketing de la compañía, con anuncios por la noche y durante otro periodo, menores de 20 segundos, mayores de 20 segundos, cine, promociones directas out of house, radio, vídeo online, etcétera, etcétera. Aquí tenéis el resultado después de diseñar el modelo de la calibración, 98,44% de ajuste sobre las ventas en esos 2 años. Entonces, confiamos ya en ese modelo. Eso es el resultado de un error porcentual absoluto medio, de un margen. Y ahí vemos cada una de esas barritas, son las ventas que de verdad se produjeron en ese periodo y las ventas que te da el modelo. Hay veces que no puedes ajustarlo perfectamente porque como cada agente representa un número de consumidores, es un patrón, como si fuera una encuesta, como decíamos antes, del INE, pues que un agente compre más o compre menos suma un porcentaje de ventas, no suma una venta concreta, un ratio de ventas. Pero como veis, el ajuste está muy afinado. ¿Esto qué nos permite? Diagnosticar cosas como la marca concreta, ver cuánto tienen de venta base y cuánto tienen de venta como resultado por los touchpoints. Aquí vemos un 28,1% y un 71,9% y podemos estudiar la contribución y la eficiencia de los distintos touchpoints. Porque podemos ver ese consumer journey a lo largo de todo el tiempo, cuántos oyeron, cuántos contactaron a través de televisión, cuántos vieron un anuncio, cuántos lo vieron en internet y cuántos les afectó para la compra y contabilizar qué impacto ha tenido cada uno de esos touchpoints en la venta. Y finalmente, podemos hacer escenario what if. De nuevo, aquí tenéis un ejemplo muy simplificado. Se hace un escenario what if sobre un cambio en la política de una de las 5 marcas del media marketing, de una de las 5 marcas de la propia empresa. Esa sube un 3,90, otras de la propia empresa pierden, otras de ellas ganan un 0,88% y vemos el efecto que tiene eso sobre la competencia. Y nos podemos permitir cosas que esto es una de las cosas que siempre los directores de marketing nos han dicho que más valoran. Tener una herramienta y tener una justificación y no tomar decisiones hasta ahora, así nos han hecho muchas veces el gesto. Viendo por dónde viene el viento, en función de mi experiencia, no sé si ha cambiado, aquí tienen una herramienta en la que pueden simular y hacer esa simulación, pueden tener análisis de sensibilidad de la inversión de medios. Entonces, esa gráfica de abajo lo que representa es qué ocurriría, yo tengo el escenario de lo que hice, qué ocurriría si invirtiera un 40% menos, si invirtiera solo un 60% del budget que tengo para la inversión, habría perdido 7,1% de ventas, si invirtiera un 20% menos, hubiera invertido un 80%, habría perdido 3,8%, lógicamente si invierto lo mismo, gano lo mismo, y a partir de ahí, metiéndole un 20% más o un 40% más, me ocurría lo mismo, pero si consigo que mi consejo de administración me dé un 60% más, yo puedo arriesgarme a decirle, además ya os digo que damos una banda de confianza, que podría ganar hasta un 4,2%. Entonces, como conclusión final, se comprendió la dinámica del mercado para todas las marcas y jugando con el mix de medios de nuestras propias marcas, la empresa era capaz de aumentar las ventas hasta un 7%. Y con eso finalizo, simplemente aquí tenéis unos cuantos de los clientes con los que se ha trabajado. Como se puede ver, son mercados de distintos tipos, de distintos sectores, nacionales e internacionales. En la esquina superior derecha tenéis Havas Media, porque CIO tiene un convenio con Havas Media para explotar esta tecnología y varios de los mercados que están aquí reflejados, varios de los clientes han llegado a través de esa tecnología. Y por mi parte, nada más, esta es la única transparencia, deciros que esta tecnología no solo se puede aplicar a entornos de marketing, sino como comentábamos, existen muchos sistemas complejos en nuestro entorno y de hecho los modelos de predicción de pandemias, como por ejemplo el propio COVID que tenemos ahora o el SARS desde 2009 fue el primero que se hizo con modelos de ABM y con ciencia de redes, pues aquí tenéis otro mercado que es el mercado de la comunicación, otra aplicación que es la comunicación y nosotros, nuestro grupo de investigación, desarrolló el primer modelo matemático de la influencia de la comunicación del atentado del 11M de entre los días 11 y 14 de marzo de 2004 en el resultado de las elecciones del 14. Y la tecnología empleada era la misma. Cambiaban en la tipología de los touchpoints por aquella época, pero teníamos exactamente lo mismo. Por mi parte nada más, muchísimas gracias por vuestra atención y espero que os haya resultado útil.
primera parte definiré lo que son las tecnologías del lenguaje, dónde estamos, hacia dónde vamos y por qué este boom actual en TLH. Y en una segunda parte me voy a centrar en una serie de sistemas computacionales basados en TLH, basados en tecnologías del lenguaje, en los que está actualmente trabajando mi grupo de investigación, el grupo SINAI, y que los he llamado de manera genérica sistemas de alerta temprana, porque lo que tratan es de prevenir, intentar analizar el texto, hacer un análisis textual de diferentes mensajes que están todo el día surgiendo y vertiéndose en medios sociales, de manera que podamos hacer una predicción o una detección temprana de ciertos problemas que actualmente, por desgracia, están muy de actualidad. Son problemas sociales como, por ejemplo, la detección de noticias falsas, la detección de discurso de odio, detección de lenguaje ofensivo, de ciberacoso y de ciertos problemas de salud mental como pueden ser la anorexia, la depresión e incluso la prevención del suicidio. Por eso la segunda parte del título, para un mundo mejor. Pues empezamos. Y vamos a empezar viendo cuál es la terminología que se utiliza a la hora de hablar de la disciplina, de referirnos a la disciplina. Ya hemos visto una terminología que es tecnología del lenguaje humano, pero este término realmente es bastante reciente. Desde mi punto de vista, yo creo que lo que estamos intentando es acercar esta tecnología al ciudadano, a la sociedad en general. Realmente el término que normalmente se utiliza y que se suele utilizar fundamentalmente en el ámbito de investigación, desde un punto de vista científico, que se utilizó desde el inicio, cuando apareció por primera vez la disciplina, es el de procesamiento del lenguaje natural. Hay otros términos, como por ejemplo el de computational linguistics o el de natural language understanding, que suelen utilizarse sobre todo en el mundo anglosajón, aunque también algunas veces lo utilizamos en español. Pero ya les digo que lo que fundamentalmente se usa en el mundo académico, en el mundo científico, es procesamiento del lenguaje natural, tomando un poquito a la ventaja las tecnologías del lenguaje que las estamos utilizando cada vez más. Bien, voy a hacer ahora una definición de lo que son las tecnologías del lenguaje y voy a hacer una definición muy breve, muy somera. Si quieren una definición más precisa, pueden utilizar cualquier libro de texto, incluso la Wikipedia, pero aquí mi intención es que ustedes entiendan a lo que nos referimos, de qué es lo que estamos hablando. Pues bien, las tecnologías del lenguaje son un área computacional, por supuesto, es multidisciplinar, pero es parte de la inteligencia artificial. Y como una parte de la inteligencia artificial, lo que trata es de simular un comportamiento humano. ¿Y qué hay más humano que la comunicación entre las personas utilizando el lenguaje que normalmente utilizamos, que es lo que se llama lenguaje natural? De hecho, existen muchas teorías que postulan que el hombre realmente, el Homo sapiens, llegó a ser inteligente porque consiguió dominar el lenguaje. Consiguió incluso exterminar o extinguir a otras especies, porque era el que conseguía comunicarse con sus iguales. Pero bueno, esto es otro debate diferente. ¿Cuál es el objetivo principal que tienen las tecnologías del lenguaje? Lo ponemos ahí, que los ordenadores entiendan y generen el lenguaje igual que lo hacen los humanos. Esto hoy por hoy es ciencia ficción y yo creo que lo seguirá siendo mucho tiempo. De hecho, no existe hoy en día un sistema computacional completo que sea capaz de generar y entender el lenguaje como lo hace un crío de 5 años. Y fíjense que en esa edad tenemos un vocabulario muy limitado, las estructuras sintácticas y semánticas son relativamente sencillas, no hay tanta ambigüedad como cuando somos adultos, pues ni siquiera en ese caso somos capaces de tener un sistema computacional completo. Entonces, ¿en qué está la disciplina? ¿En qué está la tecnología? En hacer pequeños pasitos, dar pequeños pasitos, desarrollando distintas tareas que nos acerquen, por supuesto, a ese objetivo final, pero desarrollando ciertas aplicaciones. Y se pueden distinguir dos grandes bloques de aplicaciones en los que está trabajando las tecnologías del lenguaje. La primera es en hacer que la interfaz hombre-máquina sea muchísimo mejor, muchísimo más suave, menos rígida que cuando utilizamos lenguajes formales como puede ser lenguaje matemático o un lenguaje algorítmico o un lenguaje de programación. Quiere hacer una interfaz a través del propio lenguaje que utilizamos nosotros. El segundo bloque de aplicaciones está centrado en extraer conocimiento a través de toda la información, la gigantesca masa de información desestructurada, textual, que tenemos hoy en día almacenada de manera digital. Bien, vamos a poner ahora una serie de ejemplos, porque seguramente a lo mejor todavía no saben de lo que estamos hablando, todavía están un poco perdidos, pero ahora vamos a poner unos cuantos ejemplos que utilizamos muchas veces a diario y que seguramente le harán ver que las tecnologías del lenguaje son mucho más cercanas de lo que pudieran ustedes pensar. La primera de ellas es los asistentes los asistentes de voz. Todos tenemos ya un smartphone en el bolsillo, o utilizamos algo de domótica con Alexa en casa, o tenemos en nuestro PC de sobremesa Cortana. Estos en realidad son 3 sistemas que utilizan tecnologías del lenguaje en uno. Tenemos un pequeño sistema de reconocimiento de voz enganchado con un sistema específico de recuperación de información que se llama búsqueda de respuestas, junto con un sistema de síntesis de voz. Este es uno de los ejemplos. Tenemos otro muy interesante, el de la traducción automática. ¿Y por qué es interesante para mí esta aplicación? Me imagino que muchos de ustedes ya sabrán de lo que estamos hablando, la habrán utilizado alguna vez, pero realmente para mí es interesante porque fue la primera aplicación en la que se invirtió dinero y esfuerzo en investigación cuando apareció por primera vez el PLN, el procesamiento del lenguaje natural. Fue sobre los años 50, a final del año 50, en un pequeño laboratorio de Georgetown, que una serie de investigadores se juntaron y consiguieron traducir frases completas del ruso al inglés y del inglés al ruso. Estos estaban obsesionados con la típica Guerra Fría, ¿no? Y no solamente hacían una traducción de términos pequeñitos, sino individuales y aislados, sino frases completas con contexto. Los pobres ilusos aquellos pensaron que como aquello había sido un boom, pronosticaron que en 5 o 6 años la traducción automática sería un problema resuelto. Y nada más lejos de la realidad. Hoy en día seguimos invirtiendo muchísimo dinero y hay muchísimos investigadores que se dedican a la traducción automática. Esto es así porque realmente hasta hace unos 5 o 6 años no hemos tenido unos sistemas de traducción automática de calidad. Fue precisamente cuando empezamos a aplicar técnicas de deep learning cuando hemos conseguido esa precisión casi similar a la de los traductores humanos. Bien, otra aplicación que está muy de moda, lo que se conocen como agentes conversacionales o chatbots. Estos sistemas son una especie de robots que lo que hacen es simular una conversación mediante preguntas y respuestas y funcionan muy bien cuando están en un dominio muy específico, con un tipo de preguntas que siempre son las mismas, que siempre se utilizan en el mismo dominio. Durante la pandemia, por ejemplo, la empresa 1 Million Bots desarrolló Corina, que respondía a preguntas sobre el coronavirus, y lo puso a disposición de muchos organismos públicos, incluidas las universidades. Mi universidad, de hecho, lo tiene implantado desde abril. En el tema de salud hay muchísimos chatbots que están funcionando y están funcionando muy bien. Aquí tenemos algunos ejemplos. El huevo desde Facebook, que lo desarrolló en 2017, simula un psicoterapeuta que lo que intenta ver es si estás triste, deprimido, te intenta animar. La enfermera Rosa se centra en pacientes crónicos, pero para mí quizás el más interesante es el chatbot de Babylon, porque lo que hace es un primer cribado de pacientes, es decir, tú tienes unos síntomas, se los vas comentando al sistema, el sistema te va preguntando sobre otros síntomas posibles, si has tenido fiebre también, si has tenido tos, y dependiendo de las respuestas, lo que hace, el objetivo final es, intenta darte un especialista final, dirigirte directamente al especialista que necesitas. Con esto fíjense que muchas empresas, sobre todo americanas de salud, están ahorrando muchísimo tiempo y muchísimo dinero y lo están cada vez implantando más. He querido hacer un guiño también a mi universidad porque en mayo instalamos el asistente digital al alumnado, ADA. Este asistente digital lo que hace es, como decíamos al principio, está muy centrado, muy focalizado en un dominio. Concretamente, responde preguntas para los alumnos de primer ingreso sobre selectividad y sobre matrícula de primer curso. Fíjense que las preguntas, el 90% se tiene estimado que las preguntas de estos alumnos siempre versan sobre lo mismo. ¿Qué carreras se dan en la universidad? ¿Cuál es la nota de corte? ¿Dónde me matriculo? ¿Cuánto cuesta la matrícula? ¿Cómo la pago? Etcétera, etcétera. En estos casos sí que funcionan bastante bien. Si nos salimos de ahí ya es otra cosa. Pues bien, quizás hayan utilizado estas aplicaciones, quizás no las hayan utilizado, hayan escuchado a alguien que las usa, la hayan visto alguna vez, pero de lo que estoy completamente segura es que todos ustedes utilizan, y seguramente a diario, el buscador de información de Google. Pues bien, ese buscador utiliza masivamente tecnologías del lenguaje y cada vez más intenta capturar ese conocimiento. De hecho, Google tiene quizás el mayor laboratorio de tecnologías del lenguaje del mundo. Y no solamente Google, sino todas las grandes tecnológicas, redes sociales, plataformas donde hay generación de contenido, contenidos con usuarios que escriben continuamente y en los que los expertos humanos, equipos de expertos humanos no dan abasto, no son capaces de poder leer toda esa información y de asimilarla. Necesitamos sistemas computacionales que lo hagan y ahí van a estar precisamente los equipos de TLH. Como pueden ver, hay un boom, hay un auge de lo que son las tecnologías del lenguaje. De hecho, la tecnológica Gartner sitúa entre las top 10 technologies de 2020 a las tecnologías del lenguaje. Cabe preguntarse el porqué de este boom, si realmente esto es una moda o no. Vamos a ver algunas de las causas. Desde mi punto de vista hay 3 posibles causas que han hecho posible este boom. La primera es la madurez de la tecnología y esto lo comparte con la inteligencia artificial. Desde que en los años 50 Alan Turing definiera lo que era la inteligencia artificial, nunca se ha dejado de investigar en IA. Siempre ha habido, mejor o peor, con mayor éxito o menos éxito, pero siempre había investigación en inteligencia artificial. Lo mismo ocurre con las tecnologías del lenguaje. Entonces, ¿por qué ahora la inteligencia artificial parece que forma parte de nuestras vidas? Pues realmente uno de los motivos yo creo que es que la tecnología está suficientemente madura como para ahora poder dar los frutos. Tenemos la semilla ya y ahora sí que vamos a hacer un aporte a la sociedad. Nunca antes hemos tenido la capacidad de almacenamiento, ni de cómputo, ni las redes de comunicación que tenemos hoy en día. Hoy tenemos ya las suficientes mimbres como para hacer unos buenos cestos. Bien, el segundo factor creo que es la infosicación. Este término fue acuñado por Alphonse Cornellá en el año 99, que es casi antes de la era de Google, y hace referencia a la sobrecarga de información cuyo efecto es la falta de comprensión de los datos recibidos. Y por ende, lo que consigue esto es que no seamos capaces de hacer decisiones correctas, de tomar decisiones correctamente. Incluso tomamos decisiones erróneas debido a esta sobrecarga de información. Tenemos tal cantidad de inputs de entrada a diario que no somos capaces de asimilarlo. Tenemos que utilizar sistemas de ayuda, sistemas computacionales que sean capaces de hacernos un primer cribado, un filtrado para poder extraer conocimiento. Bien, y el tercer punto, y con esto ya engancho con la segunda parte de la presentación, está relacionado con el abanico amplísimo de nuevas aplicaciones que se nos abren debido precisamente a esa madurez que tenemos de la tecnología y a dar solución a los nuevos problemas que también aparecen debido a esa infosicación que decíamos. Aquí he puesto solamente algunos de los que en mi grupo normalmente hemos trabajado. Me gustaría comentarlos todos porque realmente Son todos apasionantes, pero si tuviese que elegir uno, hablaría de los historiales clínicos únicamente para que entiendan o por un momento se planteen la cantidad de conocimiento intrínseco que hay en los expedientes de todos los pacientes que tenemos en los hospitales. Hay una cantidad de información desestructurada en modo texto que si realmente pudiéramos utilizar sistemas computacionales basados en tecnologías del lenguaje para extraer esa información, nos sorprendería la cantidad de aplicaciones y de valor añadido que podemos conseguir. Bien, no me entretengo más en esto, aunque me encantaría, porque si no me van a regañar, voy ya tarde. Vamos a pasar, lo que decíamos, a esas nuevas aplicaciones que se abren ahora con esta madurez que tenemos de la tecnología. Y como les decía al comienzo, le he llamado, he cogido un paraguas para hacer una aproximación general y lo he llamado sistemas de alerta temprana. En todos estos problemas, mi grupo de investigación ha trabajado algunas veces de manera más superficial, otras de manera bastante profunda, incluso creando sistemas computacionales que están en funcionamiento. Pero todos estos problemas comparten una serie de características en común. Aquí la idea es que necesitamos analizar sistemas que analicen textualmente el contenido de mensajes en medios sociales con el fin de ayudar en la detección precoz de estos problemas que ponemos ahí. Lenguaje ofensivo, la detección de lenguaje ofensivo, la detección de discurso de odio, la detección de noticias falsas, de ciberacoso y de ciertos problemas de salud mental como anorexia, depresión o incluso la prevención del suicidio. Y como les digo, todo esto están dentro de un marco común porque comparten una serie de características. La primera característica es que todos son problemas sociales. Bien, cuando hablamos de problemas sociales, muchas veces las empresas no están interesadas, porque no van a obtener un retorno, un beneficio, no están interesadas en desarrollar esos sistemas que puedan ayudar. Deben ser los propios gobiernos, bien a través de proyectos de investigación, bien a través de otra serie de medios, los que puedan ponerle solución, si es que realmente luego le ponen solución. Otra de las características en común es que tienen una difusión muy rápida y muy fácil. Todos los problemas que hemos visto no son nuevos. Todos esos problemas, los bulos de hecho, están documentados desde la época de los romanos. ¿Por qué entonces ahora esta obsesión con las fake news? ¿Por qué ahora hay tanto boom en intentar resolver este problema? Bien, porque ahora el problema gordo viene cuando yo, con un único clic, puedo hacer llegar ese bulo a millones de personas en un segundo. ¿Vale? Ahora la difusión es muchísimo más rápida y muchísimo más efectiva y más fácil que nunca. La tercera característica, y dentro del marco en el que estamos de tecnologías del lenguaje, para mí es la más importante, y es que todos estos problemas comparten un lenguaje específico, un lenguaje determinado. Por supuesto, cada uno en su problema, pero cuando tú estás hablando de ciberacoso, el acosador y el acosado en medios sociales tienen una manera de hablar. Lo mismo pasa con las fake news, con las noticias falsas. Siempre hay un modelo del lenguaje. Eso es lo que nosotros queremos capturar. Ese es el objetivo final que tiene nuestra tecnología, el intentar capturar un modelo del lenguaje de manera que podamos hacer patrones. Y de esa manera, cuando viene un mensaje que es susceptible de ser una noticia falsa, nuestro sistema, si está entrenado correctamente, podrá detectar que es susceptible de ser una noticia falsa. ¿Vale? Bien, y por último, todos estos problemas pueden ser resueltos desde una perspectiva de clasificación de texto binaria. Si yo lo que quiero determinar es si estoy escuchando un medio social y viene un mensaje, voy a leer un mensaje y quiero saber si es lenguaje ofensivo o no, es una clasificación binaria. Yo leo el mensaje y es lenguaje ofensivo o no. Noticias falsas, sí o no. Discurso del odio, sí o no. Depresión, sí o no. Son sistemas de clasificación binaria, que dentro de lo que cabe no son muy complicados. Bien, pues vamos a ver cómo abordamos este problema de manera general. Aquí tenemos la diapositiva de sistemas de alerta temprana. Vamos a suponer que ya tenemos un modelo entrenado. El modelo ya lo tenemos entrenado en el problema concreto que estoy resolviendo, ¿vale? Porque, por supuesto, hay que instanciarlo luego con el problema concreto. Pues ya vamos a partir de que tenemos un modelo entrenado. Veremos en la próxima diapositiva cómo lo entrenamos. También partimos de que tenemos un medio social sobre el que quiero poner a escuchar a mi modelo. Un Twitter, Facebook, YouTube, los comentarios de los periódicos, un blog con mucha agresividad. Bien, ¿en qué consiste el sistema de alerta temprana? Nuestro sistema lo vamos a poner a escuchar en ese medio social para el que lo hemos entrenado, y por cada uno de los mensajes que van apareciendo, nuestro sistema va a determinar si concuerda con el patrón con el que está entrenado. Supongamos que estamos hablando de noticias falsas. Llega un mensaje, lo hemos puesto a escuchar, por ejemplo, en ciertas cuentas de Twitter que siempre son susceptibles de lanzar muchas noticias falsas. Vamos analizando ese mensaje, nuestro modelo dice, este mensaje concuerda con mi patrón, pues si concuerda lo pongo en un almacén que posteriormente será revisado por un humano, que no concuerda lo desecho o lo almaceno para luego analizarlo también, pero en principio esos no me importan. Fíjense que estos sistemas no están diseñados para que sean 100% precisos. Nos encantaría que fuesen 100% precisos, pero nuestra idea fundamental es hacer un primer cribado, un primer filtrado, de manera que luego un experto humano determine si, oye, sí, esto sí que es una fake news, esto hay que analizar más la cuenta que estaba detrás, ¿vale? Bien, pues vamos a cómo entrenamos nuestro modelo. Ahí en el medio tenemos un algoritmo de aprendizaje automático. Cualquiera, puede ser una simple SVM o puede ser la red neuronal más compleja que se puedan imaginar. En cierto modo nos da un poco igual, lo que hay es que ajustar ese modelo a cada uno de los problemas y dominios, la que mejor funcione, lo que mejor funcione. Ahora nos están dando muy buen resultado algunas redes neuronales, concretamente los transformes que veremos después. Pero en principio puede servir cualquier algoritmo de aprendizaje automático. ¿Qué es lo realmente importante desde la perspectiva de las tecnologías del lenguaje? Lo que está alrededor, los recursos lingüísticos que vamos a utilizar para entrenar nuestro algoritmo. El fundamental, el dataset de entrenamiento, el corpus anotado que tenemos ahí. Si yo estoy entrenando un sistema para detección de lenguaje ofensivo, tendré que tener un corpus con la mayor calidad posible en la que tenga mensajes catalogados o categorizados como ofensivos y otros que no. Este mensaje es ofensivo, este mensaje es ofensivo, este no, con la mayor calidad posible. Luego tenemos también otra serie de recursos en la parte superior, los recursos lingüísticos adaptados tanto al dominio como al idioma, que en el caso, por ejemplo, que estábamos comentando de lenguaje ofensivo, podrán ser diccionarios de insultos, podrán ser lexicones de palabras sexistas, homófobas, o incluso otra serie de recursos, como decíamos antes, de sitios web donde la gente habla de manera agresiva, ofensiva. Todos esos recursos los vamos a dar de entrada a nuestro sistema para que se vaya ajustando. Como les digo, el principal problema aquí son los recursos lingüísticos. ¿Por qué? Porque son escasos, son de mala calidad, totalmente dependientes del dominio y del idioma. Fíjense que si yo quiero hacer un sistema de fake news en inglés no es lo mismo que para el español, tengo que adaptarlo, el modelo, a cada idioma y a cada dominio, y además la anotación manual no está exenta de errores. Nos estamos encontrando que cuando hay, por ejemplo, anotadores manuales, anotadores humanos, que no están de acuerdo ni siquiera en el mismo tuit. Nos ha pasado, por ejemplo, con discurso de odio. El mismo tuit para una persona es libertad de expresión, para otro es discurso de odio. Pues ahí ya ni los humanos se ponen de acuerdo, es muy difícil que consigamos que un sistema computacional sea capaz de detectarlo. Pero bueno, con estos problemas son con los que nos estamos enfrentando. Tenemos estas aproximaciones nuevas que estamos utilizando para solventar precisamente estos problemas. El primero de ellos es utilizar Amazon Mechanical Turk para la anotación de los recursos. Los recursos de esta forma económicos nuestros son limitados, pero bueno, los podemos utilizar. Yo me imagino que todos saben lo que es esta plataforma de crowdsourcing, que lo que hace es paga muy poco dinero, a lo mejor 0,02 dólares por cada anotación que hace de un mensaje de mensajes que tienes que decir si es ofensivo o no para ti, ¿vale? Estos mensajes son dificilísimos de clasificar por una máquina, pero muy fácil para los humanos. Otra de las cosas que hemos utilizado es modelos preentrenados del lenguaje, utilizando word embedding, que están basados en deep learning. ¿Cuál es la idea fundamental de los word embedding? Pues capturar la semántica del lenguaje, de manera que lo que hacemos es codificar las palabras utilizando vectores, y cuando esas palabras semánticamente están relacionadas de alguna manera para un problema concreto, se supone que los vectores están próximos, ¿vale? Y por último, lo que hemos utilizado ha sido también transformer, transfer learning. Esto voy a definirlo aquí de manera muy sencilla, aunque esto es bastante más complejo, pero para que lo entiendan la gente que no esté familiarizada con este aprendizaje. Cuando nosotros tenemos un problema de clasificación y queremos a lo mejor instanciarlo a otro problema muy similar, vamos a poner el ejemplo de una tarea de clasificación de texto en español y la misma clasificación de texto en inglés. Supongamos que la clasificación de texto, para la clasificación de texto en inglés tenemos un dataset fantástico, con un mogollón de ejemplos y con una calidad perfecta. Obtenemos un clasificador muy bueno, porque tenemos un dataset de entrenamiento muy bueno. Sin embargo, para español tenemos un dataset muy cortito, con pocos ejemplos, con ejemplos confusos, ambiguos. Si utilizamos aprendizaje tradicional, pues vamos a tener el clasificador en español que podamos tener con el dataset de entrenamiento que disponemos. Sin embargo, si utilizamos transfer learning, lo que hacemos es que cogemos nuestro clasificador de inglés, que lo tenemos entrenado y que se supone que es bastante potente, cogemos también como entrada el dataset en español y lo que hacemos ahora es transferir el conocimiento que tenemos aprendido del clasificador en inglés, ¿vale? De alguna manera lo transferimos. Vamos a ver esto en un ejemplo real en el que ya ha trabajado mi grupo y que ya tenemos algunas publicaciones, que es la detección de anorexia en español en redes sociales. En realidad lo que aquí hemos hecho ha sido utilizar como entrenamiento, utilizamos un modelo preentrenado del lenguaje para español. En realidad hemos utilizado Beto, que está basado en Deep Learning, y también utilizamos un corpus etiquetado para anorexia en Twitter, para detectar la anorexia en Twitter. Es el corpus SAD que ven ahí, Spanish Anorexia Detection. Ese corpus lo hemos generado de manera que hemos cogido de Twitter distintas cuentas donde se habla continuamente de anorexia, dan mensajes cargados potencialmente de anorexia y otros mensajes, la clase negativa de real food, de vida sana, ¿vale? Para entrenar, para poner con las dos clases, la positiva y la negativa. ¿Se acuerdan? Decíamos que es un problema de clasificación binaria. Bien, ¿qué es lo que hacemos? Esas son las dos entradas. Esto me funciona aquí. Aquí. Vale. Lo que hacemos es un fine tuning. Con Beto lo que hacemos es un modelo preentrenado del español. Con SAT lo que hacemos es ajustarlo ya a detectar anorexia en español en redes sociales. Con esto conseguimos nuestro clasificador. Ya tenemos nuestro clasificador mejor, peor, más preciso, menos. Pero tenemos un clasificador que está entrenado para detectar mensajes anoréxicos en redes sociales en español. En la fase de producción, lo que hacemos es poner a nuestro clasificador, como decíamos, en Twitter, escuchando continuamente. Y lo que hace es que cada vez que viene un tweet, que lee un tweet, lo pasa a nuestro clasificador y determina si está cargado de un mensaje anoréxico. Si es así, nos da una alerta. En el caso que nos ocupa aquí, no sé si ahí se ve bien, dice, me levanté, me tomé un café y comí al mediodía, me doy asco. Nuestro clasificador determina que aquí algo está pasando, está entrenado para que dé una alerta. Fíjense que volvemos a lo mismo, aquí no se trata de que coja y sea capaz de detectar todos los mensajes anorésicos, pero solamente con que detecte uno ya es más que cero, con que detecte dos ya es más que uno. Siempre vamos a ganar, siempre podemos ir mejorando nuestro sistema, además podemos ir readaptándolo en base a lo que vayan surgiendo en redes sociales y intentar detectar precozmente estos problemas que comentábamos, estos problemas sociales en los que a lo mejor una empresa no se fija. Bien, pues con esto termino mi presentación. Simplemente un colofón para comentar que las tecnologías del lenguaje humano no son una moda, han venido para quedarse, creo que tienen muchísimo recorrido. Necesitamos, por supuesto, recursos lingüísticos. Es esencial que estemos invirtiendo en recursos lingüísticos. Necesitamos también invertir esfuerzo en adaptar los nuevos algoritmos que son cada día más potentes, pero que necesitamos adaptarlos a nuestros problemas concretos. Otra cosa importantísima es la necesidad de multidisciplinaridad. No nos sirve solamente el punto de vista de los informáticos. Aquí necesitamos fundamental lingüistas, psicopedagogos, juristas, en fin, una amplia gama dependiendo del problema en el que ya estemos, pero lingüistas sobre todo. Y por último, creo que es muy importante centrarse en lo que son problemas reales para dar una solución a dichos problemas que realmente tengan un retorno a la sociedad. Con esto termino, espero que les haya gustado y muchas gracias. Sí, no sé si tienen alguna pregunta, quieren comentar alguna cosilla. Vale, gracias.
Good afternoon. Well, my talk is focused on the global vision on the current European scenario for artificial intelligence. I want to discuss about the current situation and the perspective for this decade. First, let me to start with some pictures and a slide to focus the current situation. First, as we all know, and has been discussed along today with the different talks about artificial intelligence, we know that the world will change thanks to the ground of artificial intelligence. Different authors, and you can read different books, when authors discuss about the future, like Lasser Rouhanian, Noah Harari, that in the presentation some years ago of his book, Homo Deus, he expressed his opinion the world is going to change radically thanks to algorithms, big data, and artificial intelligence. Now, when we discuss about artificial intelligence, really it is a successful history about the use of the technology in industry. If we check the 10 largest companies in the world by market capitalization, we find that 7 of the 10 are companies developing or using artificial intelligence. A company like, in the leaks, in the slide you can find the list of companies like Microsoft, Apple, Amazon, Alphabet, Facebook, Alibaba, or Tencent. These 7 companies are focused on artificial intelligence. They develop artificial intelligence and they use continuously artificial intelligence. As you know, Amazon, Alibaba, the recommendation system is fundamental for this company, or Alphabet, Facebook, Apple, and the remaining ones are continuously developing artificial intelligence. As you know, we are now in the 4th industrial revolution, and also artificial intelligence is well known as the engine of this new industrial revolution. In fact, if we observe the history and the different revolutions we have, we can find, in this slide, you find the transition along our history and the transition of the society. This is the concept that Japanese research and Japan governments proposed as Society 5.0. We can find here the transition about the different society from hunting, agriculture, industrial, the information society 4.0, and the future, the digital society, the society 5.0. We can observe that in the transition between both society, between the current ones, 4.0, and the new one, 5.0, we have the fusion of the cyberspace and the current space, the combination of both space, and in this, in the near future, the technology like artificial intelligence, big data, and so on, really will work together in the society. This is the concept that in the near future really will be a reality. In this scenario, we have a clear scenario that the world is changing. The artificial intelligence is in the center of this change, and I would like to show some pictures about the current status of artificial intelligence in Spain, in Europe, and in order to discuss about Europe and the European vision, I want to show first the comparison between Europe, China, and America. Second, I will present the European vision on the last 3 years. And finally, I want to show some data about the current status of the artificial intelligence in the industry, the use of artificial intelligence in Europe, and the perspective and the topics for next decade. Well, if we analyze the three major markets of artificial intelligence, China, United States, and Europe, we know that in America, the private sector is the main driving force for artificial intelligence. In China, the country, the governments, are the engine of the artificial intelligence. Really, China is now probably the country with the highest economic investment announced in artificial intelligence. The objective of China is to get the first position in 10 years, in 2030. In Europe, we have a mixed situation. We have private sector, and also we have the support of different states. Depending on each state, we have different situations. But let me to analyze in depth the three scenarios. First, the American scenario, when the private sector is the main driving force. Really, the great advantage now in America is that they attract the talent, probably the most attraction of talent is now in America, in the area of artificial intelligence, really driven by its business ecosystem. Because really, as you know, they have the clear hegemony with the 5 most important companies that they are using and developing artificial intelligence. They well know GAFAM. We have, as we know, Google, Apple, Microsoft, Facebook, and Amazon. They are the most important, probably 5 of the 8 most important companies in the field of artificial intelligence. And as you can check in the picture, really, these big companies are continually including new startups, new small companies in their ecosystem. In this picture, we find the number of the small companies that they have included in their ecosystem, and we can find that Apple, Google, Microsoft, Facebook, Amazon, in this order, they are continually acquiring new companies, and really each important startup in the field of artificial intelligence usually receive an offer from this company. Really, the ecosystem is really very important, and their expansion into European territory. In the case of China, China really has a different advantage. Really, the population is really guaranteed to have a huge field of experimentation. Over 700 million of internet users is a market closed for American companies. Really, it's a big market for Chinese companies. Really, they have now probably the largest number of science and engineering graduates in the different areas related to artificial intelligence, more than 1.6 million 2 years ago. Really now with a very competitive university system, and also they have relevant business platform. We know that they also have Baidu, Alibaba, Tencent, that they are also 3 big companies like the 5 previous ones in America. In comparison with them, in Europe, we have the advantage of the new developments, the number of research institutions. If we check the ranking of the most important research institutions, we have more institutions in Europe than compared with America or with China. But of course, we have an important disadvantage: the lack of large business platforms like GAFAM or BAT, the 2 platforms in America and in China. But we have a good startup ecosystem. If we check the number of current startups in this slide, we find the ecosystem startup. We can check that, of course, the largest one is in America, but also if we compare Europe with America and with China, we are in a good position, and the number of small company startup is also very, very important. And if we analyze this ecosystem, this slide belongs to a study of Roland Berger, and a company that 2 years ago published a study about the current European ecosystem. We can find here that particularly the 4 countries in the best position are France, Germany, UK, and Spain. Spain is in the 4th position when Spain is compared with the other country according to the research and also the startup ecosystem. Really, the position of Spain is really good, and we have a good opportunity to be in the first in the division of the artificial intelligence in Europe. Well, under this circumstance, what is the current European vision and the position of the European Commission? In Europe, in the European Commission, they started to analyze the artificial intelligence ecosystem 2 years ago, and in 2018, 2 years ago, the European Commission published the first study, and the first study about the current ecosystem of artificial intelligence in Europe. And they really highlight important facts, and the most important, the digital transformation of the society is just begun, and really we have under a very, very important opportunity, and artificial intelligence is an opportunity for the future. And it is very important to be in the situation to compete with China and America in order to have an important ecosystem of artificial intelligence. Last year, the European Commission started to publish different reports. They created a committee of high-level expert group on artificial intelligence that they are creating different documents analyzing the current situation. Here in the picture you can find 2 of them. The first one is associated to the definition of the modern artificial intelligence, and the second one focused on the most important point for Europe, the trustworthy artificial intelligence. In the first one, in the definition, I want to attract attention about the current definition of artificial intelligence by the high-level group, and they discuss that now artificial intelligence is focused on data, and they highlight that really in the current scenario, the majority, the 90-95% of the applications are focused on data, and we are discussing about an environment through data acquisition and the interpretation of the collected data using machine learning and reasoning in order to process the information. Now, really, the most important application of artificial intelligence, all of them are focusing in the area of machine learning and the knowledge extracted from data. Another important aspect in one of the 2 studies of the European Commission is the use of the artificial intelligence, the ethics of artificial intelligence. They introduced the concept of trustworthy artificial intelligence, and in Europe the aim is to develop an artificial intelligence when the people, the humans, are in the center of the study. And they, from Europe, the objective is to push towards this kind of concepts, trustworthy artificial intelligence, to discuss about ethics, to discuss about the fairness of the data, to discuss about the transparency of the algorithms, in order to have a trustworthy artificial intelligence for people. This is very important because it's in contrast with the other power position of China or America. Really, the position of Europe is quite different, pushing this kind of study. The ethics is very important for the artificial intelligence developed in Europe. If we go down what happened in the different countries, the European Commission last year asked to all the countries to develop national strategies about artificial intelligence. Now, different countries presented the strategy to the European Commission. In the case of Spain, we have two strategies. The first one, the strategy about research and innovation, was presented here in Granada 1 year ago, was developed by the I Committee of the Science Ministry, and now in the current, you know that currently we have a secretary in the secretary of digitalization and artificial intelligence, and this secretary is developing the global artificial intelligence, Spanish artificial intelligence strategy, including the all different application areas. And probably along next months will be presented the Spanish strategy of artificial intelligence, including the first one focused on the research, with the aim to create an ecosystem and a network of excellent centers, and to push also the application of the artificial intelligence. After this first step of the European Commission, now the current scenario is that this year the European Commission proposed a data strategy. As I told you, now when we are discussing about artificial intelligence, we are discussing about data and the knowledge extraction from data. The data are fundamental because really, if we have data, we can extract knowledge and we can develop models. The artificial intelligence needs the data, needs the problems, and really solve the problems. Then the European Commission proposed to create a data market, and the objective of the European Commission is to create the most important platform for open data all around the world. The investment will be very, very important in order to have a big platform of data. This will be very important because the objective of the European Commission is to have the most important data platform in order to push the application according to this data. There are a lot of examples of this kind of data platform and different studies. We know that we have thousands of sensors in a lot of applications. Really, we can collect the information of the sensors. We have healthcare. Really, the healthcare is very important in Europe, and we can also collect all the information from hospital. We have social nets, and really we have a lot of opportunity to collect the data and really to have the perfect data market. Next, very important aspect now in Europe is the current, the future European program. Just now, this year, we finished the Age 2020, the current European Research Program, and next year, 21, we start the new European program, and we'll start with two special programs. The Horizon Europe is similar to the current Age 2020, is a program for research in all areas, research and innovation in all areas. And the second program, a very important program, is Digital Europe. Digital Europe is a special program associated to the digitalization of the company, of the society, and it focused attention in three big areas. High-performance computing is very important now to have important high-performance computing centers. For example, we have in Spain the Barcelona Supercomputing Center. Second, the cybersecurity. Of course, if we have a connected world, we need to have the security in the access, and the cybersecurity is very important. And the third big area is artificial intelligence. And they are focusing now the attention to focus the digitalization around these three big areas. And in the Digital Europe program, the objective is to create the European Digital Innovation Hub. The Digital Innovation Hub, they are regional ecosystem focused on one of these areas. The objective of Europe is, now we will have a call in November approximately, that they will they will select between 120 and 200 European Digital Innovation Hub. They are big, as I told you, big regional ecosystem that they will try to push the artificial intelligence toward the society and the company. The objective of this Digital Innovation Hub is to create a big ecosystem with the company and to offer the adequate information for the company in artificial intelligence or cybersecurity or high-performance computing, and also to help to the company in order to develop the prototype and the validation. Really to help the company to use the artificial intelligence along their business. And now I want to show and to discuss what is the current the situation of the company now in Europe. First, really, these two programs are very important, in particular the Digital Innovation Hub, because really, if we create in Spain a good ecosystem with between 12 and 22 Digital Innovation Hub, is the objective of the European Commission, we can organize a complete national ecosystem with the collaboration between company and university and innovation centers. The objective is to put all together in the ecosystem in order to facilitate and to help to transfer the artificial intelligence towards the company. Well, what is the current situation? Recently, the European Commission published a new study, was at the end of July, 2 months ago, and this study analyzed the use of the artificial intelligence in the company. It was a study with 9,000 companies around Europe from the different countries in order to know exactly what is the use, the situation of the artificial intelligence. The first conclusion is the awareness of artificial intelligence because it's almost universal. All companies, 92%, know the importance of the artificial intelligence for the future. Really, it's well known. But the other side is to put in practice this knowledge. The company know that it's very important, and in the future they need artificial intelligence, but only 2 of every 5 companies use now artificial intelligence. In Europe now is the 42% of European companies use at least one artificial intelligence tool, and only the 25% use at least 2 artificial intelligence techniques. The situation of Spain is more or less similar than in Europe. 40% of the companies are using artificial intelligence. In comparison with the 42 of Europe, we are in the same average. And the problem is that the number of companies that they have no intention now, in the short time, to use artificial intelligence is very high. The half of the company in Spain, 51%, the answer to the future use of artificial intelligence was, no, we will not use in the future artificial intelligence. Really, we have a problem, and probably this new ecosystem of European Digital Innovation Hub will help us to push this company to consider the use of artificial intelligence. On the other hand, analyzing the different artificial intelligence areas, we find that there are different areas. I will show the 6 most important, but the use is, the maximum is 13% of, or less, really near to 10% the use of the different technology at the moment. Of course, we have different cases of use, and depending on the different sector. If we are discussing about agriculture or fishing, the company are using autonomous machine. For electricity and water suppliers, they use for automation and processing optimization. In finance, for example, pues the company use outlying detection of anomaly or prediction. Depending on the sector, we can find different artificial intelligence techniques, of course, that they are more useful according to the sector. 3 important questions that when they ask to the company why they don't use or they will not use artificial intelligence. First problem is the right skills. We have a problem with the formation. The number of people expert in artificial intelligence is reduced. We have not, in the university, the number of people of specialty in artificial intelligence, the number of students is not so much. And also the master, you know that they have a reduced rate of acceptance, and really the number of experts is reduced. And if we analyze the number of PhD students, they are also less than because the number of current contract and scholarship is very reduced. This is a very important problem. Second, the cost of adoption. The company think that probably the use of the artificial intelligence, the cost may be high. We have a lot of small or medium companies, and also to adapt the operational process to understand the use of artificial intelligence. Well, if we analyze according to this study and we analyze the current technology, what are the perspectives for the next, for this decade? What are the most important techniques when we need to focus the attention? Here I show you the 6 techniques. The order doesn't matter. First one, automation and process optimization. There are some areas when it is very important. Second, autonomous machine, robots in general, really is very important, and we know that in the future they will be more and more important, and it is usual now to use in agriculture the autonomous machine and in other sectors. Third one, artificial vision, and now the use of deep learning. The use of the analysis of video and image is very important, so a lot of companies use them, and now recently in the last 5 years, the use of machine learning, deep learning, to process the image is really fundamental, and really it has a lot of application. And the other 3 areas, anomaly selection. Now we are in the IoT, Internet of Things age. We have a lot of sensors, and then it is very important to extract knowledge from the anomaly and to detect before to happen any problem in the system. Then anomaly detection is really fundamental now. Sentiment analysis and natural language processing will be very important now. The number of companies using it is around 3%, but of course the use of social networks, the use of the text to analyze the text, to extract information, to analyze the opinion is fundamental. In the future, it will have a lot of application. And finally, prediction. Prediction includes all techniques that they are the classical artificial intelligence, regression, classification, and clustering, and so on. And the analysis of time series really is fundamental, and we can find a lot of application. Well, these are the 6 important areas, and we want to call attention about the kind of data. We have artificial vision, we have image and video, we have prediction, classical numerical data, and we have natural language processing, we have text, words. And then we have the triangle of the 3 kinds of most important data: numerical data, image, and words, text. Well, to finish, in this scenario, it is very important to have data. The current European strategy about big data and to collect data is fundamental. Of course, to have platforms and software, Europe is developing now a platform of artificial intelligence. AI for EU is a European platform in order to include code algorithms and for company. And of course, as I told you, the European Digital Innovation Hub, when the objective is text before invest. It's very important to develop the ecosystem of labs around Europe in order to have this kind of strategy to help the company to use artificial intelligence. These are the 3 strategies of Europe for this decade, and it's fundamental to extend and to work in this strategy, because it's fundamental to develop the artificial intelligence in Europe and to eliminate the mentioned barriers in the previous study. The 3 barriers, the right skills. We need more and more information. We need more and more courses on information on artificial intelligence, and we need to reduce the cost and for production and adaptation. And then, as the text before invest is fundamental, and the new ecosystem of Digital Innovation Hub will be fundamental to get this level. Finally, let me to finish with a tribute. Leonardo Torres Quevedo was a real engineer, Spanish engineer, probably the most important Spanish engineer, and really 1 century ago, before to the use of the word artificial intelligence, that is was proposed at the middle of last century by McCarthy, Leonardo Torres Quevedo proposed the first machine playing to the final of checks, and also some of their robotics or some system, automation system, really was very, very important, and really was the precursor of the artificial intelligence. This is all. Thank you very much.
most attendees in this event, I am not an expert in artificial intelligence because my field of expertise is not artificial intelligence, but patents. I am the head of patent examination at the Spanish Patents and Trademark Office, and I was a patent examiner for many years. However, some years ago, when this issue of artificial intelligence became so trendy, I also grew interested in the relationship between AI and patents. I attended lots of conferences, webinars, seminars on the issue. I gathered quite a lot of information, and I intend to provide you with a summary of all that information. And also, since I guess that most of you are not experts in patents, maybe you don't have a lot of knowledge about what patents are, I am going to try to make a brief introduction about what patents are. What are patents? Patents, in fact, a patent is a property. A property title. The same way you have a property title on a house, on an apartment, on a car, on whatever, you can have a property title on an invention, something you have invented. The main difference is that in the case of patents, they have a legal life for a limited period of time. It doesn't last forever. It has a legal life of 20 years from the filing date, the day you file the patent application. After those 20 years, the patents, the invention goes into public domain, and anybody can exploit that invention commercially, as long as they have the technological knowledge to do so. So what we do at patent offices, patent examiners do, we check whether those inventions comply the so-called patentability requirements. Why do we have the patentability requirements? Because when the legal life expires, ends, the invention goes into public domain, and it must mean a benefit for society. It must mean a technological progress for society. So we check that by checking the patentability requirements, which are novelty, which means there mustn't be anything like that, inventive step, which means that it mustn't be possible for an expert in that technological field to arrive at the invention from what is already available. And also, inventions, in order for a patent to be granted, they must have an industrial application, which means it must be possible to exploit the invention commercially. And also, another question you might pose, a legitimate question, is, yes, but why are inventions patented? Well, the main reason why inventions are patented is because inventors want to make money out of them. They want to make business out of their inventions. They want an economic profit. That's condensed in this quotation by the famous Abraham Lincoln, one of the most popular presidents of the USA. He was an inventor himself. He had a patent, and he gave a very famous speech about the patent system, and he said that the patent system added the fuel of interest to the fire of genius. Why? Because, of course, genius has always existed in humanity, but thanks to the patent system, you have an incentive, because inventors, by filing patent applications, they can make money out of those inventions. They get exclusive rights for a limited number of years, 20 years, and at the same time, that's a technological progress for society. So after this brief introduction about what patents are, why we have a patent system all over the world nowadays, I'm going to talk about the relationship between patents and AI. There are two main topics. The first one is patentability, what can be protected with patents, and the second one is the use of AI for patents examination, the use we make at patent offices of AI. When we talk about patentability, we can distinguish patentable subject matter, what means, what can be protected by a patent. Also, we can talk about the right to the patents in the case of AI-generated inventions. We can talk about prior art generated by AI, about assessments of inventive step, in that case especially about who is the expert, the person skilled in the arts. We can talk about sufficiency of disclosure and also about liability, who is responsible in the case that a patent is infringed by artificial intelligence. I am going to talk about some of those issues because I don't have much time. The first one is patentable subject matter. The first question would be, can AI inventions be patented? Well, there isn't a definite answer, but some of them, yes, some of them can be patented. But we have to distinguish three types of inventions when we talk about AI. AI as software or computed implemented inventions, AI as a tool to obtain inventions, and the third issue is inventions generated autonomously by AI, which some people say is something from science fiction. That's my opinion as well, that we are several decades from that moment. But there are some other people, some experts, who say that that's something we already have here. I'm going to talk first about the issue of whether AI as software or computer implemented inventions can be patented. Some people say that software cannot be patented, but that's not true at all. What cannot be patented is code, the code in which programs are written that cannot be patented, but the process, the procedure carried out by that software can be patented. That's what we call computer implemented inventions. They can be patented as long as they have a technical character and they imply inventive step that can be attributed to the technical features. And of course, the next question would be, yes, but what is technical? It's not easy to define what is technical, but there is consensus in Europe that technical can be defined as a situation where there is a controlled use of forces of nature in order to obtain a result. So when we talk about machine learning, AI, all the different AI techniques, they are based on computational models and algorithms such as artificial neural networks, genetic algorithms, support vector machines, etc. And they are per se of an abstract mathematical nature, and because of that, because they lack technical character, those algorithms, etc., per se, they cannot be patented. And what's more, the European Patent Office, in the last edition of its examination guidelines, they caution patent examiners to be careful about the use of terms such as support, vector machine, reasoning engine, neural network, because you have some words like machine, engine, network, which might sound as technical, but usually they refer to abstract models, and because of that, they do not imply that there is a technical character. But, however, despite all that, there are some AI-related inventions that do have a technical character and thus can be patented. Here you have an example. This is a well-known example provided by the European Patent Office, which is the use of a neural network in a heart monitoring apparatus for the purpose of identifying irregular heartbeats. There is a technical contribution and it can be patented. In fact, here you have the patent document of the granted patents. Here you can see inside this red box, this code B, which means that the patent has been granted. And here you have the claim. The claim is the most important part of a patent. There are some people who say that claim is the name of the game. And there you have the claim which says heart monitoring apparatus comprising the different elements. It comprises input means, pre-processing means, and then you have neural network means for receiving, and then you have a definition of how that neural network means. So that's an example of an invention where AI is involved, which has technical character, which complies with the patentability requirements I mentioned before, and can be patented. Another type of inventions where AI is involved and can be patented is the classification of digital images, videos, audio, or speech signals. Here you have another example, and there you have the claim, and in this case it's a computer-implemented method for training a deep convolutional neural network to classify images of skin lesions, and then you have a definition of how it works. As you probably know, AI is being used extensively in the health sector, especially in diagnosis. In this case, the purpose is to try to distinguish those skin lesions that are cancerous from those ones that are not. So another invention where AI is involved that can be patented. Another type of inventions is or AI or situation where AI is involved is the use of AI as a tool to obtain inventions. There are numerous companies nowadays that are using AI to generate inventions. One of the most known industries is the pharmaceutical industry, where AI is being used with the following goals: identify new compounds, which can be patented, foresee how those potential compounds will behave in trials. No? That's something that's now on the news because of trials with the vaccines against the COVID-19. You have to carry out several tests. Also to analyze possible combinations of existing drugs in a synergic way can be patented. To find new uses of existing drugs, something that can be patented in most countries. And also to create personalized medicine based on genetic markers. Here you have an example of an invention. This is a test of a patent application, and you can see here in the description methods of generating computer learning algorithms to predict susceptibility to oxidation of a residue. No? Here, AI algorithms are used to foresee, to predict how a certain compound will behave. Here you have also an article that was published early this year. Here, the headline says that for the first time, an AI-designed drug was about to enter human clinical trials. In this case, the company used an AI platform that used a suite of algorithms to decide on the best chemical structure for the new compounds. The main advantage of using AI when designing new compounds, new drugs, is that it makes the whole process more efficient. It accelerates the procedure. Here, for example, you can see that we had to make and test only 350 compounds, which is a fifth of the normal number of compounds. So more efficiency. Here also another article that also appears this year when the pandemic was beginning. And here you can see how groups of scientists are using AI to try to find compounds that could fight the coronavirus. And as in the previous case, the main advantage is that it will speed up the process of designing. Also, another use of AI as a tool to obtain inventions is this one. This one is from a real company from Switzerland in Europe. They use what they call an invention platform. They use several AI techniques, machine learning, natural language processing, graph theory. They feed that platform with a series of data, articles, white papers, blogs, research papers, also with a detailed model of how invention works in that technological fields. And with after being fed with all that information, the platform provides you with a series of inventive elements. Those inventive elements are provided to human developers with a background on the different technologies. And from those inventive elements, those developers draft patent applications that are handed to the customers. Usually the customers are big companies, multinational companies, and they decide which patents applications they are going to file. Some people say that the use of these kinds of platforms might be behind the huge number of patent applications that are being filed, for example, in China. In China last year, 1,500,000 patent applications were filed. Probably it has to do with the use of these kinds of platforms. And finally, when we talk about different AI inventions, we have the inventions generated autonomously by artificial intelligence. Some people say that doesn't exist. That's something from science fiction, but there is a group of teachers or professors from the University of Surrey in the south of England. They filed last year 2 patent applications on 2 inventions, and they said those 2 inventions were generated by an AI entity called Davis without the intervention of humans. And because of that, they designated the inventor, designated that AI entity as the inventor. And here you have the patent application, and here you can see inventor. It says the designation of the inventor has not yet been filed. In fact, it was filed, but it was rejected because patent laws don't accept inventors that are not human. The invention that was supposed to be generated by an AI entity had to do with a fractal profile for containers that's made possible to hold several containers together without the need of additional accessories. However, as I told you, this patent application has been rejected at the USA, at the UK, by the European Patents Office, because the inventor wasn't human and that isn't allowed by patent laws for the time being. Here you have the arguments why the patent was rejected. Here it says, AI systems or machines have at present no rights because they have no legal personality. Because of that, the patent was rejected. However, it seems that there is a need to solve a problem when we talk about AI generated inventions. Last year, I attended a conference in Geneva at WIPO, the World Intellectual Property Organization. There was a person who is responsible for IP, intellectual property, at one of the largest German companies. He showed this image to us. They are vehicle parts. The one on the right was invented by a human, and the one on the left, the green one, was invented, according to this person, was invented by an AI algorithm. And according to this person, the invention complied with the patentability requirements, so the patents could have been granted. However, he said that they didn't apply for a patent because it was going to be rejected, so they couldn't protect this invention with a patent. So he proposed that maybe a solution to this problem would be that legal persons, companies, could be designated as inventors, or another possible solution would be that an electronic personality was created, an electronic personality with rights and duties. In the fields of intellectual property, they are a little bit more advanced because, for example, in the Spanish intellectual property law, we have an article that says that in the case of a collective work, the natural person or legal entity that publishes it shall be considered the author. That's not possible with patents for the time being. And also in the Copyright Designs and Patents Acts of the UK, it says that in the case of literary, dramatic, musical or artistic work, which is computer generated, the author shall be taken to be the person by whom the arrangements necessary for the creation of the work are undertaken. That's another way of addressing this problem. Now, After talking about patentability, what can be protected with patents, all regarding AI, we can talk also about the requirements of sufficiency of disclosure, which is as important as the patentability requirements, because it's key for the proper functioning of the patent system, because as I told you before, after 20 years, the invention goes into public domain, so it must be possible for any experts in the field to carry it out, to carry the invention out. So the invention has to be defined very, very clearly. And the problem, what's the problem we have with AI? That we have input data, at the end you have output data, the results, and in the middle sometimes we have like a black box. We don't know what's going on there. So there is a need to open that box somehow if we want the patents to be granted. So in order to overcome this problem, applicants are advised to disclose as much information as they have about the training process, the weight, the different data are given, the system architecture, whether the type of neural network, the number of layers, hidden layers, etc., etc. Otherwise, the requirements of sufficiency of disclosure is not going to be met, and probably the patents will be rejected. And now, I don't have much time left, but now I am going to talk about the other topic when we talk about AI and patents, which is the uses of artificial intelligence in patent offices. There are many more uses, but I have selected 3 of them. The first one is the use of AI for classification of patent documents, because there is an IPC, International Patent Classification, where you have more than 70,000 classification groups, where you can classify all types of inventions, all types of technology. There is a classification group for whatever you have invented. So this is a process that has always been done manually by patent examiners. It takes a lot of time, and by using these AI algorithms that can be trained continuously, all you have to do is to copy and paste, for example, the abstract of the invention in a box like the one you have here. After a few seconds, the algorithm provides you with the closest classification groups. In this case, it also works in Spanish. In this case, the invention had to do with a trap for insects. And yes, we were provided with the closest classification group, this one, A01M. This algorithm is available for free at the webpage of the World's Intellectual Property Organization, which is the UN Agency for Intellectual Property. Also, another use is the use in automatic translation. Of course, that's something, the use of AI for translation is something that has already been known for many years. But in the case of patents, it's especially relevant because in the past, patents, as I said before, patent examiners, they have to check whether the invention is new, whether there is already something like that in the prior art. In order to do that, they carry out online searches. But sometimes in the past, the patents were drafted either in Russian, Japanese, Korean, Chinese, so there was no way of understanding what they said. Nowadays, thanks to automatic translators like the one developed by WIPO or by the one developed by the European Patent Office, they provide you with very high quality translations into English and sometimes into Spanish, so it's possible for patent examiners to gain access to documents in those distant languages. And patent automatic translators, they have such a high quality because it's very usual that a patent application or a patent document is published in several languages. So that's a very useful tool for training those automatic AI-based translators. And finally, the other use of AI, the most promising use in patent offices is the use of AI in prior art search. As I told you before, patent examiners, they have to carry out searches to determine whether any invention already exists or not. That picture you have there is from the 19th century at the USA Patents Office, the USPTO, and there you have how patent examiners worked in the 19th century, also in the 20th century. I must tell you that when I joined the office in the 90s, we worked like that in some cases. All patent documents that belonged to the same technological field were printed and kept inside boxes or drawers. You went there and you revised, you went through all the documents, you read them, and you determined whether the invention was new or not. But now we are using artificial intelligence algorithms. What you do nowadays, well, that's beginning. That's mainly the short-term future, but now it's possible to copy and paste the texts of patent documents, and after a few seconds the algorithm provides you with a list of the closest patent documents. There are many commercially available AI-based patent searches nowadays. We have tested some of them, 8, maybe more than 8, and our conclusions are: it's not possible to rely exclusively on them. There is a need for human intervention, but they provide a good starting point. So, as in the case of the use of AI in the pharmaceutical industry, the main advantage of using AI for prior art searches is that improves the efficiency and the speed in search. And although we are far away from replacing patent examiners with AI algorithms, probably that's something that will happen in the future. Probably in the future, prior art searches will be done mainly by AI entities, algorithms, or whatever. So probably in the future, here you have pictures of one of the most famous popular patent examiners. Albert Einstein was a patent examiner at the Swiss Patent Office. Thomas Jefferson, one of the first US presidents, was a patent examiner himself, one of the former Japanese prime minister, and probably in the future you will have the picture of that AI entity that will be able to do such a complex work. But for the time being, the technology is not mature enough. It has to be improved yet. Also, that tool will make it possible to face the avalanche of patents applications that we are expecting in the future because of the intervention of AI. Probably there will be AI in both sides. On the one hand, generating inventions and patent applications, and on the other hand, examining them. Finally, to conclude my presentation, a wrap up. Some AI-related inventions can be patented, but there are some caveats. There must be a technical character, otherwise it cannot be patented. The inventor must always be human for the time being. There might be problems with the lack of sufficient disclosure, so attention must be paid to that. And also, AI is being used in IP offices to increase efficiency in examination. And finally, just to finish, since I work at the Spanish Patents and Trademark Office, I would like to tell you, if you wish to protect any invention, to patent any invention, you must go to our webpage where you have a lot of information available, and you can also contact us through phone, or it will be a pleasure to try to help you to to get as much information as possible about how to file a patent. And also, since this event takes place in Granada, and if you work at the University of Granada, and also you are interested in patents on how to protect the results of your research with a patent, you can also go to the O3 o la Oficina de Transferencia de Resultados de Investigación de la Universidad de Granada. So thank you very much indeed for your attention. Adiós, hasta la próxima.
So, hello everyone. My name is Nerea, and I'm going to give the last talk of today, which is called Cheat on Your Opponent in a Creative Way. So, first of all, who am I? My name is Nerea, as I was saying. There is my Twitter account there. You can connect me if you want. I'm an AI engineer in Singular. I also hold a PhD in artificial intelligence, as I mentioned it. And I'm also a co-founder of TechFest, which is an event, a technological event, free of entrance, and that has grown up a lot in the last 6 years. I also like to do a lot of speaking at these kind of conferences or other conferences which are maybe less technical or even more technical. So I enjoy a lot about talking related to AI and also robotics, okay? But today we are talking about a field of artificial intelligence that it's inside machine learning, that it's called generative adversarial networks. So generative adversarial networks, or GANs, are some kind of neural networks. I believe that you are familiar already with that term. So generative adversarial networks, we're going to see it through the presentation. What they try to outcome or to become, it's on somehow of cheating algorithm, so that I don't know if the output is true or false, okay? So I just want you to dive into that high-level concept of the neural network, and we will see step by step how they are built, and through the examples we will see how they are also executed, okay? So first of all, I believe that you have seen this on the TV or either social media. So these are our, or used to be our political leaders, and they look old, right? And how is this being made? Because how you can connect a style mixed with a real picture? Well, this is done with artificial intelligence, of course, in more concrete with generative adversarial networks. And the thing is that everyone is talking about GANs because they are really viral, right? So someone released this picture and suddenly this picture is everywhere. And the same happened with this Leonardo DiCaprio impersonation, right? So suddenly there was some Chinese guy doing an app that was called Sao. And this guy decided to replace Leonardo DiCaprio in every of the films, right? So the thing is that, and I want you to notice at this point of the talk, is that generative adversarial networks are a technology that it's really, really new, so it's really novel. And sometimes what happens is that it cheats to our eye, right? So I see that video and I can see that it looks quite natural or real, but the thing is that sometimes what happens is that it works really well in low to medium definition, but when I go to high definition, I start to see a lot of mistakes, and the algorithms are really, really slow, and they are really cost effective in terms of how to work with them fast, okay? When I mean fast, I mean in less than 3-4 days, okay, to be trained. So basically, let's start by situating ourselves in what it's artificial intelligence, neural networks, and GANs. So first of all, artificial intelligence has many areas. I have depicted here only machine learning, but I want you to realize that we have many others, okay? We are talking today about artificial intelligence and machine learning, and in more concrete way, there is also a deep learning area, which is a sub-area of machine learning. And what they all try to do is to transform data into knowledge, okay? So I have some data, it can be numbers, it can be a picture, it can be a video, okay? I send that information to my neural network, and the neural network is going to connect all this data, okay? It's going to find patterns, it's going to find some kind of replication, some kind of symbols that are somehow connected, okay? And that's how I transform data into knowledge. What happens with GANs is that first we need to know how to work with images, okay? And then what I also need to know is how neural networks work. And for that, I have depicted here a little glimpse of how could be a neural network of, okay, if it were placed right just in the in this schema. So basically I have some input data. I will have some neurons, which are simple multiplications, okay, in the mathematical way. Okay, this is a graphical view, but just imagine how it would work with numbers. So basically I will have a lot of multiplications, simple and fast multiplications. These neurons will decide if they are activated or not. And this is cycle, okay? This is just a cycle. So this will be repeated maybe for 200 times or 1,000 times. And with that, I will obtain if my data is classified, in this case, in between class A or B, okay? So also what happens is that when I work with neural networks, there are some other parameters that I'm not going to stop to talk here about it, but just for you to know, so the complexity of neural networks is not to run a neural network, but it's to configure the neural network so that it can do what I expect. Okay, that's also some part of complexity, and it's called hyperparameterization. But let's focus on how do we process an image, okay? So when I receive an image, the neural network is not going to understand, okay, this is a face. Okay, the first time that I see a picture, I don't know as a machine what I'm seeing. What I'm seeing in the best way is this has these colors, or this has this contrast, this change of balance here. Maybe this has always this pattern, okay? But I'm realizing this with all these training cycles, okay? So the most closer definition of what a neural network will see inside in each of these neurons is something as depicted here in this slide, okay? So the neural network is going to take just some pieces of the full images and is going to transform that into information. How can I do that? Well, we all know that images are done by pixels, right? So the neural networks, what they are most interested in is how to transform images into numbers, which become matrices, okay? So the key of the neural network, even if it's GAN or not, is to transform images into matrices so that I can work fast with numbers, okay? As I was saying, they use a lot of multiplication, so matrices are really easy to multiply, and that's why we work always with matrices as much as we can, okay, inside neural networks. So what we are trying to do is to erase some part of the data of the image, so we are just trying to focus on each neuron on some part of the data, but we will have the global view after a few iterations. So, as I was saying, just let's imagine that I have, for example, a data set of faces or a data set of cars. And what I could see is, okay, so I need to identify somehow the eyes, I need to identify a mouth, or I need to identify the wheels, okay? So in this case, the best neural network to use in these cases is convolutional. So convolutional neural networks are some kind of neural networks that are really, really useful and fast in extracting information from images, okay? So I'm not diving in detail, but basically convolutional neural networks, what they try to achieve is to get some feature extraction at first. So we are going to have this glimpse of the image, so these pieces of the real image divided along the neurons. They are going to learn all these features that they find in all those images, and then I'm going to find a second step of classification. Classification could be, this is a car, this is a dog, this is a tree, whatever we are trying to identify on the image, okay? So having that said, convolutional networks perform some kind of matricial operations, which I'll call this ReLU, or this convolutional or max pool operation. I'm not diving in at all here, but I want you to know because I think it's really useful to understand that we are every time talking about multiplication of matrices and trying to somehow reduce the amount of information so that we can move faster and faster on each iteration. So basically what we have here is a more graphical example of what I have put in this slide before. In here I have a car picture, and what I can see in each of the columns, okay, what I have here is all these features that I can find from the car in a grayscale. okay? We always work in grayscale. So basically, this will be like the inside of a convolutional network. I have there, for example, the mirrors, I have there the lights, I have there the 4 wheels, and I could identify after that I have a car, okay? So the thing, I need you to know this, because as there is a convolutional operation which tries to classify from image to data, there is another one that is the opposite, that it's called deconvolution. So deconvolution tries to understand from the data how can I obtain an image, for example. Okay, so I just want you to know that there exist these two processes. One that is convolution, so from features to classification, and the other one which is from random data to this image that I had at the beginning. Why? Because this is the basics of GANs, okay? So usually when you work in machine learning, you are working on a discriminative classifier, okay? So discriminative classifier, what it is it tries to understand what is happening with the data, is trying to understand how data is connected, which are the patterns, okay? And then it gives an output. But what happens with generative classifiers is that there are some parts that they are missing. If I want to put my face in some other face, I need to understand first how to get this shape of face, what is a face, what is the relation between my eyes and the eyes of the other person, okay? And they try to infer all this information using, well, a specific thing that we are going to see in a minute. But basically we can say that generative classifiers learns the how-to, opposite to the discriminative classifier, which just learns relations between data, okay? So how can, for example, in this image where I have a dog and I have a painting, how can I connect these two operations of having in one content and in the other style, and how can I mix this so that the output image still has the same content structure, and I have still see a dog, but also I see the style, right? So this is one of the first questions that GANs arise. How can I somehow teach the neural network that this is a dog, and I want to keep that as a dog, but I want to change the style of the picture, okay? So some researchers what found is that in these convolutional operations, there were some layers, here are depicted in red. There are some layers that store information about the content of the image, and there are some other layers that store the style of the image, okay? So what if we connected two instead of just having one? So that was like the basics before GANs were named GANs. This was like the first research that was done in this sense. And then how could they become generative adversarial networks? Well, by the way, that's a painting that has been painted by an artificial neural network, okay, by a GAN, and has been signed with the loss function, which is like a joke here. So it doesn't have like a human painted behind. It has just a mathematical function, okay, and this was, well, this is very famous. But anyway, so let's continue with GANs, right? We were saying that we have some style, we have some content, and how we can connect both. Basically, the first researcher that named GANs as they are was Ian Goodfellow, which is also the creator of TensorFlow and some other machine learning frameworks and algorithms. So he's very well known in the area, and basically what he understood was, okay, so there's a way I can generate examples because I can teach a neural network how to get to some target, which is an image, not data anymore, okay, not just information. So he took all these famous data sets from machine learning, which are MNIST, the FACE one, the CFAR, okay, there are a lot of famous data sets, and he took some of them and tried to replicate this behavior so that he could generate more examples for those data sets. And what it became, apart from viral in the community, is that, okay, now we have a way to maybe make data sets more diverse, or maybe generate synthetic data so that I can train specific things more than just the data sets that everyone knows, okay, in the community of machine learning. So this paper in concrete became really famous, and everyone started to talk about this technology. So how can we improve GANs? How can we generate more ensamples? Try to get to more use cases so that I can understand better the technology, because they didn't know which were the limits of GANs. And since 2015, a lot of works have been published after this one, okay? So this is the structure of a generative adversarial network. Basically what you have, as I was saying, is two operations in parallel, okay? So the one operation, which is the standard one, is the convolution. So basically we try to put the image or the set of images, okay, this training set. We have a training set of maybe faces, okay, and on the other hand, I have some random noise. Random noise is just numbers randomly initialized, and I have these two processes that go parallel working, okay? So one process is trying to extract information from those faces. The other one is trying to understand what is happening in the first process, okay? So what happens is that the output of the convolution is going to have some feature extraction and some picture somehow, okay? And the output of the convolution is trying to generate a fake image so that I could say this image belongs to this data set that I have used as training set, okay? So what I have here behind the convolution and the deconvolution is some kind of policyman or policy woman that is trying to say, this is fake, this is not, this is fake, this is not. So that while it says it's fake, it's fake, it's fake, this part of the algorithm, the deconvolution, is getting better because it's getting feedback about why this is not enough to be fake, okay? And the other one is training, is training, is training, is training. So what is happening is that at some point, the second process, the deconvolution, is becoming better, even better than the first one. And for the human eye, it's impossible to discretize between fake or non-fake anymore. Okay, so that's how we have these deep fakes, that's how we have these fake images of whatever you can think about. Okay, cars, clothes, everything. Okay, so GANs are just about disregarding about is it fake, is it true? Okay. We're going to see some examples from here to the end of the presentation. So basically, if you go to this person does not exist, which is a famous website on the machine learning community, what you're going to find, it's a lot of faces. So each time you click on the website, you're going to find a new one. And they are all synthetic faces. They are all synthetic faces like these ones that you can see here. And you might say, okay, these are human faces. Like, this is not fake at all. Yes, they are fake, but they are really well trained so that they can trick the human eye. Remember that GANs are all about cheating, okay? So what is the model learning? The model is not only learning how to generate a face, it's learning how to depict the hair, for example, the hair when it mixes to the background. It's learning how to smile, which is really hard. Like, if you can think, how humans smile, how can I put this thing in a synthetic way that looks natural, okay? So there are a lot of things in these pictures that the neural network has learned that might not even come to our minds quickly, okay? And this work, by the way, was performed by NVIDIA in late 2018. That was the first version of StyleGAN. And again, it became viral because GANs were almost forgotten, but then NVIDIA released this work and everyone was talking about generating fake faces, right? So just for you to have like a relation on how much it costs to train a high definition algorithm for GANs for generating fake images, basically they started to train first 4x4 pixels images until they arrived to 1024 by 1024. So they came from no resolution or really, really low resolution to having these high resolution images. And this took, I think the number is 23 or something like that. So 23 days of just learning, of having CPUs running, GPUs running to understand all these patterns, okay? This is a lot. This is a crazy amount of time. And this is also expensive for someone that doesn't have a cluster at home or at the research lab, okay? That's why also a lot of industry is becoming interested in this field, because they all have machines. You can think about Google, you can think about AWS, IBM, all these huge giants are interested on these technologies because they are expensive and they can create services that somehow maybe can release you more well, information or at least some process so that you can execute and run your guns, okay? But just think and look at how the image is very well defined by the end of the process. So at the first, we only have like some brownish and orangish tones on the image, and then we even have like smile, these lips, this makeup on the face, which is also kind of surprising because also the neural network learned that part, and it's really impressive. It's really impressive because no one did that before in that well, particular detail, okay? So there are some videos here that you can find online on how they even improved that model, because if you have entered into that website, what you're going to find is that sometimes it's really easy to see that the image is fake because you can find some errors on the background when they are mixed with the human on the first plane of the image. So basically, you are going to see what you see now on the right side of the slide. So there are some kind of well, defects on that part. But in general, they work really well. And what they also learned on the process is that they could somehow control the levels of abstraction of the image. What I mean is that they not only are able to generate a real or natural image of a face, but they also learn how to change only the hair, how to move from a red hair to a brownish hair or a curly hair, okay, or from different ethnias, faces. They know a lot about all these, well, particular things that make us human, right, and diverse. So this is really interesting work in all these terms. So they have like 3 levels of learning, and they can change a lot of features on that faces. StyleGAN 2, what fixed it mainly was all these defects, all these little details that everyone was saying, okay, I know this is a fake image, okay, this is not natural. So they were really focusing on trying to obtain these transformations so that they could see which are the defects that are promptly seen on this, for example, recording from the women changing to a man and these kind of things. So if you appreciate in the eyes, for example, the mouth or the glasses, you could see some of the examples that they fixed with this version 2. Okay, it's all in this video explained. And then also, besides NVIDIA, there are some other works that have been carried out by also universities. So in this case, CycleGAN is really famous. For example, it's really famous because it could change the content and the style between animals. So you have here a lot of examples, but I think the most famous one is the zebras to horses. So how in my head am I going to think that a neural network is going to learn not only how zebras are, but also how horses are, and which is the style of each one, and how can I move from one to another in the same picture without altering the background, right? So that's the concept of CycleGAN. So CycleGAN tries to have 2 concepts that are visually different, for example, this summer-winter as well, and it's trying to establish some kind of relation so that I can generate one picture or the other with information from one or the other, okay? So in this case, it's really interesting, for example, if you can think about generating new landscapes, or even trying to, for example, for autonomous cars, how can an autonomous car see a road that suddenly it's snowing, or it's really, really having a storm there, and I need to maybe understand how the autonomous cars will see it on in a realistic way. So you can generate synthetic landscapes, for example, using CycleGAN from ones that already exist, okay? There are some others that went viral as this Bangkok picture, and you can find all of them on the website of CycleGAN. And there are others, also by NVIDIA. We are going to see NVIDIA a lot here. They are really like the state-of-the-art of this technology, which became with a really fun idea, which was how to turn a simple doodle or just a simple, drawing that maybe a 5-year-old kit we do at home into a Flickr picture. So you know Flickr, right? Like this social site with when all these photographers upload their picture from either landscapes, events, or whatever. So they focused on the landscapes, and they were saying, what if we have like this interface, really simple interface, where when everyone with a color assigned was painting something, and I could just generate an image because I know which color represents a tree, which color represents a mountain or grass. Okay, so you can try this at home, and it's really surprising how it turns into a real image. Okay, something that you just have drawn quickly in 3 seconds. And not only you can see the image, but also you can see the image in different weathers or in different times of the day. And this is really promising technology because, again, you can generate synthetic landscapes that can be used, for example, for a video game, okay, or maybe for some storytelling. So in this case, this is a trial that I did at home. And what I can say is that it works really well if you don't put many objects one in front of the other, right? So these technologies work really good when the objects are, well, aside and on their place. So I have there a sea, I have some rocks, but I don't have rocks, a tree, and something else in front of everything. So as long as you more or less maintain the usual way of putting everything on a picture, it will work really fine, and you can obtain this image maybe in 20 seconds, okay? It doesn't take longer. There is also another application that it's image in painting. So image in painting is all about retouching pictures or erasing someone from the picture. There is a new version, I don't think it's the same work, I think it's a different work from another company, but there is already an algorithm that tries to erase you from some video directly, not even an image, okay? And this is done with GANs. So basically what they try here is to understand what's in the picture, why I want to erase it, and how can I replace it so that it looks natural. So this works really well with people, but it doesn't work so much or so well when you have people in the front of the image, as you can see in this example here. So here what happened is that someone tried to erase the first woman on the left, and what happened is that suddenly a face appeared like a ghost or some kind of fun thing in the middle. And that's because these kind of algorithms try to have first some face detections. In case they detect a face, they try to perform specific algorithms to that face, and then they erase the rest of the picture. So sometimes it's better to just erase first the face and then the rest of the body. And that's why I think the algorithm really messed up on the solution. There are some other examples with this one. I did a picture of myself, and I was trying to erase, well, like dark spots and these kind of things. I think my earrings were also, yes, erased, and the stamp of my T-shirt. And you can see that it works really well when the details are really, when they are little, you can see it works quite well. The result is kind of the same picture with everything almost fixed. And what I did after that was, what if I erase my eyes? Will the neural network understand those are my eyes and will try to replace them? Well, yeah, the answer is yes, it did. But as you can see, they don't look like my eyes, but they really look alike, right? So I was surprised actually by this try, because it's not only to have natural eyes. The thing of this picture that you can see before is that it's really hard to have, well, I was not in front of the camera. I was like turned a little bit on the right? So what happens is that I'm not in a position that it's easy for a neural network or anyone to paint those eyes, right, or try to replace them. So the thing is that I was really surprised, and even though those are not my eyes, I could feel that the neural networks understand that I need two eyes and somehow on the best position that they were at the beginning, and that I want to replace just that part of my face, okay? This is really hard to learn. There are some others which are called pix-to-pix. So pix-to-pix has a lot of transformations related with edges. So it's not edges, it's some sketch that you do in some well, just like if you were drawing with a pen. So basically the input is some kind of drawing that you have done with a pen representing something, and what you want is the neural network to feel that drawing that you have done. In this case, the example that I did is for edges to cuts, but if you go to that website, you can see a lot of examples. There is also a GitHub repository with a lot of neural networks already trained. And in this case, as I was saying, what I was trying to depict there is a cat. So that was my drawing on the left. And the output on the right was, I mean, quite good. As I was not expecting for it to be supernatural, because, I mean, this comes from a sketch that I'm doing as a human. The result was quite good. I mean, the algorithm knew which were the eyes, which was the nose, the ears, which was the tail as well. So, I mean, in general, they understand the context, right? There are some other examples that you can think about for Pix2Pix. So Pix2Pix has been trained, for example, to generate shoes, as you can see up in the slide. It has been trained to understand how we can move from an autonomous car view to a real view. For example, aerial maps are also now generated or can be generated with guns from Pix2Pix. I mean, this is all experimental, but it works nice, or at least most of the times it works nice. You can see also examples from grayscale to color. I mean, you can dive in a lot of examples which are quite interesting. Even this with the windows on the building. So this one on the middle tries to generate also images from colors to buildings. Okay, similar to the Gauguin. There are some others. So if we are thinking that we are trying to generate examples, and we have seen these faces, we have seen from sketches to some kind of real image, or this image in painting where I was erasing my eyes, you can think as well as, will I be able to generate a gun that is able to reconstruct something? Because as they are trying to somehow learn what it's missing, maybe I can use that feature to reconstruct something. So there is a famous paper that tried to impersonate all this IKEA furniture. So basically they took a lot of information from IKEA and other retailers, and they tried to generate all this furniture in 3D. Okay, so the gun is able to perform almost the full 3D vision of each of the furniture that you can see there. And it works quite well. I mean, it works well because the model is really small, so you cannot see it in high resolution. But this has launched some other use cases, for example, for cars or for clothes. And you can see it now, well, I'm not saying everywhere, but in research it's really common to see these, copies of this model. There is also a model that has become really popular this year, which is called the Oldify. And I really like this model because somehow we all have felt like we were missing something when you were seeing pictures from your grandparents or great-grandparents, right? Or even your parents. And they are all in grayscale. They are all black and white pictures in an album that no one knew how where the colors look like, how the cities look like in that sense. So there is some guy that has taught this neural network to try to accomplish this complex task, right? So they try to, they try to teach the neural network to learn how every color looks in grayscale depending on what you are appreciating on the image. That means that if you are giving him a landscape, the neural network will understand this is a landscape, so probably these gray colors or gray tones that I'm seeing here, maybe they are green, maybe they are grayish, maybe they are blue, okay? But if I give the neural network a picture from a woman or a man, I will try to apply the tones that are most closer to humans, right? So in this case, the results are really amazing. You can try it already on the internet. It's open to public. And also in combination with this ESR gun, which is enhanced representation, screen representation, I think it is, something like that, What it does is that it combines high definition, so from a video, for example, or an image that was really blurry or was really all recorded, it tries to turn the same video footage into high definition and then applies color, and you can see something as much as incredible as this Apollo lunar landing in color, okay, in vivid color, and it's really amazing that we are getting to have this technology, even though maybe the colors are not fully representative or they are not 100% okay, but I can assure you that it gives the footage or the photos more realism, and it's really nice to try. There is some others, as for example, warping gun. So warping gun is one of the latest that I'm going to talk today. And warping gun, what it does is that it generates models, human models, okay? So from some poses that you can send as input to the neural network, what it will generate is some kind of similar poses to the ones that you have given them as input. So for example, imagine that I have the pictures on the first column. So I have these, I think there are four models on the first column on the left. And what I am trying to do is for them to appear in these positions that are on the first row. So you can see the example of the girl, which is like first turning on the left, then a focus on the front, and then on the right, and it's posing, right? So it's not only how to generate this human look-alike, but it's also to generate a natural pose that a model or a professional model will do. What can achieve this? For example, to change how retailers are selling their clothes. So we can see now, we can think, for example, what if those clothes never existed, but I can see which ones work best in my platform, and depending on the demand of each ones, I can maybe send to fabric just some of them, or maybe all of them, or maybe none of them. So, I mean, it gives you more try to do this A/B testing on retail, right? There are some other applications. For example, you can see also a wide variety of models. So we all know that modeling is expensive, and retailers spend a lot of time and money in all this footage that they perform maybe daily or weekly. So just imagine if you can just give maybe your measures, your human measures, and this artificial intelligence is generating a human model that looks like you, so that you can see how that cloth will fit in your shape and height and everything that looks like you, right? And maybe not in other model that looks very different than you, and maybe you don't buy it, right? So this is a really nice example, and I think that we will hear a lot more about this kind of use of guns in retail. There are some others. I don't know if you have seen, for example, El Intermedio or some other contest. I don't remember any other right now, but I know there was at least one. I think it was also on the 31 of December in New Year's Eve that they used something similar. But the guns have been used on TV. It's just that they don't use it on real time. So every time that you have seen something related to guns in TV, it has been post-processed, because of course you can see some errors on these matching faces and these kind of things. But El Intermedio, for example, is really famous for having this technology that you can really see on your TV, and it's really, really fun to see the result. So now I want to talk briefly about some resources that you can find online. So the first one is for those of you that are not really familiar with neural networks and how they work. TensorFlow has some resources related with that, so you can dive in a more graphical way. So for example, in this playground, you can see how neurons are activating or deactivating, and how the knowledge is being transmitted from the left to the right. You can also learn how the parameters work. Remember that I have said that one of the hardest things is how to configure a neural network, and to understand how that affects the whole training system. There are some others which are called code labs. So code labs work also online. You don't have to download anything, and you can also benefit of using GPUs online. for free or almost for free, depends on the model and the place. But basically, there are some tutorials that are quite interesting in those links, and you can check them and can follow them. I mean, as long as you know more or less English. I think one of them has been translated to Spanish lately. This one related with TensorFlow. So, I mean, you can get a lot of knowledge about that without having a PhD or any technical degree. Also, there is this blog of Towards Data Science. So, Towards Data Science is a super famous blog on the internet now running on Medium that has been like a first resource for everyone that has been, I don't know, in machine learning in the last 7 years, for example. So they publish daily a lot of information. They also have GitHub repositories with all the examples that they mention on the blog post. And I really recommend them, for example, to learn in a more divulgative way how to understand neural networks and their applications. There is also this channel, this YouTube channel of .ccv. So .ccv is a Spanish YouTuber. He's also a friend of mine, and well, he does amazing animations and explanations on how machine learning works. The latest video, for example, has been about GPT-3 of OpenAI. So I believe that you have heard about this text generator, that it's really intelligent. So, I mean, you can follow their videos, and they are really, really divulgative and interesting. And also, there is this one, this YouTube channel that is called Control Sheet Face, which at least a few months ago, I don't know now because, well, the pandemic and all these things, but at least at the beginning of 2020 and the last year was uploading a lot of deep fakes that they did over movies. So there are a lot of examples here that you can see. And you will see this thing of having this medium resolution rather than high resolution for all these examples. The last one that I want to mention, it's 2 Minutes Papers. So in this case, 2 Minutes Paper is a YouTube channel that tries to summarize some viral papers, mostly related to the artificial intelligence area. They are really focused on machine learning, but they are also covering some other areas. And you can check them online. It's really interesting because they use a lot of audiovisual examples and videos and stuff. And then you have all these links from all the, well, examples, neural networks that I have talked today, so that you can just digest all this information easily at home. So they are all mentioned here. And if some link is missing, you can just contact me and I will send you the right information. So this is it on my side. Thank you so much. Just to know, you can reach me online. Also, thanks to Singular, which allows me to stay here today with us, with you. And well, let's see you soon. And I hope the talk has been interesting enough to at least dive more into neural networks and GANs. Thank you.
Thank you very, very much, Nerea. It's been a pleasure having you here. And for the people that is watching us, I would like to, just to go through a little bit of your professional career, which is amazing. I'm not going to go list everything because it will be so long. But for you to know that Nerea has been recognized as for Business Insider as one of the 23 talents under 35 for leading the technology revolution. And we are so lucky that we have her here today, not only now, but earlier on as well in another talk. Thank you ever so much for your time, Nerea, and see you around. Thank you very much.
Thank you.
Bye now.
Bye-bye.
Muchísimas gracias. Hi, good afternoon, everyone, and here we are, closing the event for the day. Now, we're going to be very lucky today, and we're going to have here on the screen, we will have Vanessa in a minute. Vanessa was supposed to be here, as I said before. She hasn't been able to make it due to personal circumstances, but now we're going to join her virtually. Vanessa Llorens is the main person at Uni4 leading this event, and she is our country manager as well as a senior manager of innovation. Let's see if Vanessa appears. Hello, Vanessa.
Hello, everyone.
Hello
Can
there.
you hear me?
Hi, Vanessa. How are you?
Hello.
How are you doing?
Hi. So good to talk to you.
Okay.
Very good.
How are you
Okay,
doing?
so-
Have you been following the day?
Of course. Of course, I cannot miss it. But first of all, let me tell you, Elena, that many thanks for backing me up when I've been at NEET. I really appreciate it. And there's no doubt that we have had the best opening possible this morning. And
Thank
I was
you.
watching at you, of course.
Thank you.
For me, it's a big pity not being there with you all, but if we look on the bright side, thanks to this strange COVID situation and the addition of a virtual layer, I've been able to follow everything and what has happened today and from this side of the screen. So at least we are lucky in this sense.
Good.
And again, no doubt that it has been a really intense and exciting day today. If you let me go and do a quick summary.
Yes, sure.
Yeah. So we started very early this morning with the institutional opening, where authorities, Junta de Andalucía, Diputación, and Granada Council show their support to events such as Software Week, which foster innovation and professional networking in Granada, who is a great place and a great opportunity ecosystem for technology. Then after the keynote of Cristina Aranda this morning, who gave us great insights around AI challenges, we have had the opportunity to hear 16 different speakers all over throughout the day, helping us to understand much better, a wide range of topics such as the impact of AI in financial planning or the payment sector, simulation models applied in marketing activities, how the tourism can be transformed by means of artificial intelligence. We also have learned about reinforced learning, how to clone human voices, autonomous decision systems, robotics, visual methods to analyze complex data sets. And in addition to this, we also had the opportunity to learn about the future developments of AI at a European level. This has been this afternoon, just a couple of hours ago. We have reflected on how AI-driven innovation needs to be considered when analyzing a patent. And just some minutes ago, we just ended our first day with the extraordinary keynote of Nerea Luis. And of course, it's really worth mentioning the 5 workshops celebrated today by Unit4, University of Granada, and UNED. And last but not least, the supplemental activities that we have had in the 360-degree scenario. First, Rafael Artacho presented the 5 finalists of Mini Crazy Lab contest, and Cristina Aranda and Nerea Luis shared with us their other passions besides technology. So about the organization of technology events, and also which is the impact of biases and stereotypes in everyone's decision-making process. These stereotypes that we all need to hack. So, as I said before, I've been living and experiencing all this from the comfort of my chair, and also, by clicking on different virtual rooms. But I'm really curious to know, from you, Elena, how has been your experience from the exhibition center?
Well, it was brilliant. I haven't been able to go to every single speak or talk. As we said before, they run in parallel, so you have to choose. Personally, I will mention, and I really like, the one by Oscar Cordon about how to simulate marketing strategies, etc., and how can you benefit from it. I really like as well about the one about Paco Herrera, and of course the 2 keynotes, Cristina and Nerea. I've been lucky enough to be not only in the keynotes, but also in the extra activities that they have done in the 360 degrees space, and it has been brilliant. I was just talking to Nerea when she was leaving, and I said, yes, so all this that you were explaining is Face Up, and it is Face Up. Face Up is using this kind of technology to change you from a man to a woman, from a woman to an old lady, etc.
Yeah.
So that's one use, only very, very minor use, but that's one use of the technology that she was explaining to us. As for how have we lived the event here, well, it is pretty obvious that all this COVID situation has changed things. So most people have decided to join the event from the comfort of their houses, like you are. Yeah.
Yeah.
And it's been pretty obvious. We have a huge peak in the morning, try to access the virtual platform, so much so that we have to increase the capacity of the virtual platform. So it's pretty obvious, it's a lot of people joining from home. It's been quite a few people here as well, not as much as last year, but still, considering the situation, it's been quite a lot of people here as well. So it's been a great day, all in all. A great summary from your part. I see that you have done your homework, gone through everything and see what's going on. Very well done. And tomorrow we'll be enjoying our second day of the South Tech Week. And again, I have said this the same this morning, and I'll say it again. As I said myself, I haven't not been able to attend everything because there's a lot of things that are running in parallel. So I will advise you to do the same. Have a look at the agenda for tomorrow. Try to see what talks or keynotes interest you the most, and plan your day ahead so you don't miss anything. And we'll see you here tomorrow, 9:15 opening time, and we'll be lucky enough to have here our CTO at Unit 4, Klaus Jespen, that from Denmark will be doing the opening speech. Anything that I have forgotten, Vanessa?
Just a minor announcement about today. So for those interested, we will be hosting an extra activity now at 6:30 in room Andalucía 3. And we are hosting a roundtable organized by the Granada's Marketing Club to discuss about the positive impact that a good corporate social responsibility policy generates within a company. In this round table, we will be sharing with the attendees the approach of Unit 4 to this matter. Okay. Unit 4 being a company that is in business for people. So, now just very briefly, as a reminder, you still have time to participate in the two contests organized by Unit 4, the mini crazy lab days and the quiz. And as you know, as Elena already explained this morning, and win an. So voting will be open till tomorrow at around 5 o'clock, and then the winners will be announced in the closing event that I will be happy to join tomorrow. So nothing else from my side, just many thanks to all the South Tech Week community, authorities, speakers, sponsors, and of course the attendees, because this is for you. So for joining today, also to see you tomorrow.
Okay. Thank you very much, Vanessa. Thank you very much, everyone, to everyone that has been joining today, and see you tomorrow. Bye for now.
Bye.
Esta es mi vida, chavales, darle un micrófono. ¡Eh! ¿Cómo lo lleváis? Venga, perfecto. Ya lo tenemos. Esto ha sido todo.